Hello? Can you be so kind to activate?
මේ PS එකට කියන්න උඩ ඉන්න කට්ටිය ඔක්කොම මේ දැන් conference halls වලට direct කරන්න කියලා. This is a medium. Starting the time again. Then we are starting in 5 minutes, man.
Okay, but I need to have permission to share the screen because
we will do that. We will do that.
Okay, thank you.
Make host. Now you have permission. We will connect.
Have? Okay, I'll try.
Right.
Okay.
Ma'am, your talk is not the next one. Your talk is.
Your talk is at around 11:30 advanced.
When is it? At what time is it? Because I was told it was at 8 o'clock, your local time. So that's why I'm here.
No, ma'am, we sent a link to be activated at 8 o'clock, but your talk is at 11 o'clock in our time. I think I emailed you last night.
At 11?
Yes.
So now it's 9, I have to wait 2 hours?
The time was given to you? Wait, man.
No, it was not. But it doesn't matter. It's okay. I'll come back again now then.
Yeah, sure. Thank you. I'm sorry for the inconvenience.
Okay.
Making up notes here.
Maybe screen share එක නැති කරන්න බැරිද?
Stop වෙලා තියෙනවා.
So can you tell me for sure at what time? Now what time is it in your watch?
Now it is 8:55. It is almost 9.
It is 8:55. And when do you want me to talk?
At 11 in 2 hours time.
At 11.
Yeah.
Okay, so I will come back at 11. And now
Yeah.
here in my country, it's 4:30 in the morning. 4.
Oh, I'm sorry about it.
At midnight. So I was waiting 4.5 hours because I thought I had to talk now. So that's why I will not stay these 2 hours and go and rest a little bit, okay? Because I won't be
All right.
2 hours.
Thank you, man.
Okay? Good. Okay. So
All right, thank you. Sorry about
see you
it.
later.
මේක කියන්නේ කොහෙද?
ඒක තමයි දැන් ඉන්නේ.
Hello, Dr. Mohan. Can you hear me?
Yes, I can hear you. Good morning.
Good morning, sir. We can't see you.
Yeah, I did not turn on the video. So, can you allow me to share the screen?
Sure.
Co-host. Yeah.
At 9 o'clock, our professor will introduce you. Then you can start after that, sir.
Yeah, no problem.
Right.
If nobody is going to introduce, don't worry.
No. They will.
I will introduce myself.
You don't need any introduction. Everybody knows you.
So now it is showing advanced sharing option, only host, all panelists. So what I need to click, all panelists or only host?
What? I will let you know. Mohan. එයා කොහොමද කරන්නේ කියලා අහන්න.
ඕ නෑ එන්න යට එන්න මෙතන කෙරුණා අපිට
permission දීලා තියන්නේ. Do finish. එයාට දීලා තියෙන්නේ.
දුන්නා permission දුන්නා.
එතන එයා අහන්නේ all panelists ද
අහන්නේ basic diagrams or basic can share.
So you can go to basic and share.
No, I am getting the option advanced sharing option on the screen. So I will try it once again. Let me see.
Right. You can do it now. So I will let you know if I can see the screen.
So can you see
Yeah.
this?
We are getting your screen, sir. All good.
Okay.
All right. Oh, now we see you.
Okay.
machine නෙමෙයි. මේ ඉවරයි download ඉවරයි.
Right. I'll see you in a bit.
Hello. 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 I think you have to unmute me. Hello.
Yeah, you are unmuted.
Okay. Now I can hear. No, I think you have to unmute me.
Unmute kar lati. We can hear you, Dr. Mohan.
Yeah, but I'm not able to hearing you. So I think is okay. You
All
have
right.
okay.
Can you hear what our speaker?
No, no. Now I can hear.
Can you? Okay, then shall we start, Pastor Mohan? No, you can hear.
Hello.
Hello? Hello? Can you hear?
Yes. Go ahead.
You can. Okay. Fine. So again, good morning again. So we are starting the session with an invite speech from Professor Dinesh Mohan. So let me briefly introduce Professor Mohan. He is a professor working at the Jawaharlal Nehru University in India. He has received a master's degree with first class honors and PhD both from the Indian Institute of Technology, Brooklyn. And he has vast areas of interest, including environmental, analytical, aquatic, and surface chemistry, and remediation and encapsulation of fabric pollutants from water, development of low-cost adsorbents and magnetic adsorbents, and also water quality monitoring and modeling, assessment and remediation of arsenic, fluoride, nitrate, and iron from water, and further the biorenewable resources and environmentally benign wood residues. The long list of specialties. And he also has many collaborations with leading universities in the world, to name a few. Mississippi State University, USA, Penn State University, USA, and Universidad de Extremadura in Spain. He has also worked as a visiting professor in a university in Mexico, and also in 2014, he's been given a special recognition because he's been selected as the Thomson Reuters highly cited researcher in 2014. So he has a large number of publications, communications, and also patents and books. And at the moment, he is a professor at the Jawaharlal Nehru University. So without further introduction, I'll invite very kindly for Professor Dinesh Mohan to deliver his invited speech. Professor Mohan.
Am I audible?
Yes, sir.
And can you
Yes,
see
you can start.
can you see the slide also?
Not at the moment.
Okay. So thank you for the introduction and good morning to everyone. And
Dr. Mohan, we cannot see the slides yet.
okay.
Yeah, all good.
Can you see now?
Yes, sir.
Okay. So first of all, I would like to thank Dr. Samira for giving me this opportunity to talk about my research work on this platform. Though we were planning to meet, but somehow because of this pandemic, we are not able to meet on the platform face to face. But anyway, so today I will be talking a little bit about biochar, where we are working for, I think there is some echo coming. So can you please take care of that? When I am speaking, some echo is coming back. Yeah. So today I will be talking about the biochar, which is a, very good product which can be utilized for different applications. So I will introduce that, and then I will be talking little bit about the work where we are heavily involved nowadays. But let me tell you about my university from where I am. This is Jawaharlal Nehru University. It is very much in the capital of India, New Delhi, established in 1969, and this is a very big campus, about 1,100 acres of land, lush green campus, about 8,000, more than 8,000 students, more than 1,000 faculty members. So it is a huge campus, also having the facility for the students, about 18 hostel, many quarters. So this is very close to the international airport in New Delhi, about half an hour from the international airport. So all are most welcome to visit our university. I'm working in different areas, and some of the areas I mentioned here, uh, which include water quality monitoring, modeling, assessment, remediation. Then we are working on the thermal conversion of biomass into biofuels, and there are many products and byproducts during the conversion process, and one of the product is biochar. So we are using this biochar for carbon sequestration. Basically, this is under the umbrella of biorefineries, where we have many products. When you are converting the biomass into different options like bio oil or biochar or syngases. We are also working on nano materials, magnetic nanoparticles, and applying in different applications. So today I will try my best to give some idea about why we are working in this area, especially in India. Because if you see this slide, I mentioned here that India is having about 600 million metric tons of the agriculture residue per year. And most of the residue is being burned by the farmers in the agriculture field itself because they want to clean up the field for the next agriculture crop. But if you see worldwide, we are getting about 3.7 petagram dry matter per year. So huge amount of biomass if we can convert that into some useful product. Though some of the applications where this biomass is being used as a animal feed, fodder, soil mulching, making compost, packing, many applications, but still huge amount of the biochar is being burned. Now, this is all over India. These dots are showing that where we have this biomass burning issues, including east, west, south, and north states of India. Especially, I think you must have heard about the pollution problem in winter when we have the biomass burning issue in the states very near to New Delhi, especially Punjab and Haryana. So what others countries are doing with the biomass, many applications, even here in this slide, I try to show that even in Sri Lanka, there are some biomass burning going on. This is the slide where you can see that most of the Asian countries, they are just burning the biomass in the agriculture field. So what they are doing, they are just putting in the fire in the agriculture field. So there are many problems associated with this burning issue. And also we are losing a lot of soil properties, including organic carbon when we are burning this in the agriculture field. What are those issues? When you burn, you are getting all sort of pollutants, whether it is PM 2.5, PM 10, methane, SOx, NOx, all sort of contaminants you are putting back into the environment. And let me give you an example. if you just take 1 ton of stubble and you burn it in the field, mainly you will be releasing about 2 kilogram of SO2, 3 kilogram of PM, that includes both PM 2.5 and PM 10, 60 kilogram of CO, 1460 kilogram of CO2, huge amount here. And also we are getting about 199 kilogram of ash. In addition to that, we are losing nitrate, phosphate, potassium, sulfur, and also the organic carbon when we burn in the field. So what we can do with this biomass, we can convert that into biofuel. There are 3 major platforms. Either you can use the thermal conversion platform, where the major processes you can have pyrolysis, gasification, or combustion. And out of these processes, you will be getting either bio oil or syngas, or you may also get some heat where you are doing the combustion or using the biomass as a fuel. Then you also go for the biological conversion process, where either you are doing the fermentation, converting that biomass into ethanol. When I said biomass, I'm talking mainly lignocellulosic waste. Or you can convert through digestion into biogas. And also, when we are sometimes talking about the biodiesel, that is purely the mechanical process, nothing to do with the biomass. You are purely working on the oil and converting that into biodiesel. Now, the basic difference is when you are dealing with a biological conversion process, you need to have the wet biomass where you need a lot of water. You will be ending up with a single specific product. I told either biogas or ethanol, but the problem is it is a very slow process. It takes hours or days. But when you are dealing with the thermal conversion process, you need to deal with the dry biomass. When I said dry biomass, that means the biomass must be having less than 10% moisture. Beauty is, it is a very fast process. You can complete this from few seconds to few minutes. You will be getting multiple products. Sometimes this is a big problem and sometimes this is an advantage. I will try to explain that in the coming slides. Now let's consider this is a thermal chemical conversion platform where either you will be going for fast pyrolysis. When I said fast pyrolysis, the whole process from cooking of the biomass to the condensation of the fumes into bio oil, it takes about 2 to 3 seconds and you will be getting about 75% liquid, we call bio oil. You are also getting about 12% biochar and again 13% gas. Now these numbers are typical. Why I'm saying typical? Because it depends on the quality of the biomass, the type of the reactor you are using, how you are doing the process, and how you are controlling the thermodynamic parameter. Then you can also do the carbonization process. This is a slow pyrolysis where we are getting from 30 to 40% of the char we call biochar. We are also getting some gases and we are also getting some liquid, but the major yield is biochar. Then you have gasification process, and there are many industries which are using these gasification processes to generate electricity. This require very high temperature from 800 to 1300 degrees centigrade. And you have the residence time between 10 seconds to 30 minutes. So you will be having syngases. Though in all the cases you are getting this char, but I will try to focus only on the slow pyrolysis char. All the chars are having different properties because of this variable temperature and residence time. Now let me try to give you a picture. Then sometimes there is a confusion when somebody is talking about biochar or char or activated carbon. So in this slide, I tried my best to have the comparative comparison among charcoal, char, and activated carbon. So when you have wood, mainly wood, you will be doing the thermal decomposition, and finally you are getting the charcoal, and we use that for heating and cooking purpose. So mainly the source is the wood. When you have the burning of the biomass, I have shown you one slide. You just burn it, means in presence of oxygen. So you will be getting char, and this char is having no organic carbon. So it is different from the biochar. And when you have the activated carbon, we sometimes do the activation of the charcoal and convert into activated carbon when we are increasing the surface area and pores available in the material. So this we use especially for the water decontamination. Now, overall, this biochar is a fine grained charcoal, which is high in organic carbon and largely resistant to decomposition. So mainly this property makes this biochar very attractive, because then we will be able to call it carbon negative technology. I will explain why. And this can be one of the technology which can be used for the carbon sequestration. In addition to that, because of the high surface area, this can be utilized for water decontamination. When you use this in the soil, it is going to increase the water holding capacity of the soil, enhanced plant soil interaction, increase microbial activities, and also increase the cation exchange capacity. So that will result into higher yield of the food products. So some work we have carried out on this aspect also. So I will discuss that at the end of the lecture. Now, when you are doing the cooking, means the pyrolysis, how you will differentiate whether the material you obtained is biochar or not. So there is a guideline given by IBI. If you are getting H by C ratio higher than 0.7, we do not consider that material as a biochar. So you have to be careful when you are doing the pyrolysis. You have to bring that ratio below 0.7. Depending on the temperature, residence time, catalyst, and medium, you can have the biochar properties, which can be having electron donating capacity or electron accepting capacity. So it depends how you are making the biochar. Now, when I said this is being used for carbon sequestration, because when you have this photosynthesis process, you have this CO2 absorbed by the plant and then going back into the atmosphere. So basically, this is a CO2 neutral cycle. So what we are interested in, we want to take some of the biomass out of this cycle, convert into biochar, put it in the soil so that it can be staying in this soil for more than 1,000 years, because the half-life of the biochar is more than 1,000 years. So what we are doing is we are converting this CO2 neutral into CO2 negative cycle. So this is the aim why we are interested in converting this biomass into biochar. Now, recently in 2018, October 2018, IPCC also considered this is or recognized this as a negative emission technology. So because of this inclusion into IPCC, I think we are looking forward to get more funding in this area. Now, initially we started with the auger fed reactor in the beginning in 2005, where we developed this reactor with a capacity of 1 kilogram per hour, having 3-4 condensers. So aim at that time was to make the bio oil. So initially we developed this to have the temperature control or temperature window between 400 to 500 degrees centigrade and residence time from 0.5 to 5 second. The beauty is you can have the condensation of the bio oil from these condensers, and those bio oils you can use for different applications, including to convert or to use as a transport fuel. So I'm not going into that detail. So this is the first picture of our reactor, which we started using in 2007. So basically this is having these condensers. So our aim was to condense those vapors and collect the bio oil. Because I had the experience in working this carbon technology. So there was a product I told you, which we were getting during this bio oil production that was about 10 to 15%. And we thought, let us try to use this for water purification. So we got some students and we started working on that. So initially we used that for the remediation of arsenic, cadmium and lead. So this paper we published in 2006 online. Finally it came in 2007. So at that time this was the first paper where we utilized this biochar for water remediation. And you see, if you see this picture, in 2007, hardly you will have any publication, but after the publication of this paper, you have now exponential increase. And now you have many applications of the biochar in different area. So from that time, I called this biochar my baby. So I don't know, a large number of studies have highlighted the benefit of using biochar in terms of mitigating global warming, soil amendment, enhancing crop yield, water filtration, and carbon storage. So many applications. These are few. Even now, this is being used in making boards to increase the strength. Now, in recently, because in India this is a big problem, so we made some reactors using some clay mud, because we are trying our best so that farmers can use that itself in the agriculture field. And you know, we use this using the clay available itself in the village. And the beauty is, after making the biochar, they can destroy this, dismantle it. And we have demonstrated when you have the clay soil with biochar, this combination is going to increase the yield of the crop. So this is an advantage. Or you can keep it, you can make the big one. So we already patented these two reactors, and we are working with some farmers in North India, in this Punjab and Haryana. Now, you can also make some designer biochar. You can do the manipulation by manipulating different parameters, different operational parameters, including type of the biomass, operating condition where we have temperature, heating rate, mass transfer rate, residence time, oxidative condition, pressure, type of input, some catalyst. You can also do some pre-treatment. We demonstrated how we can increase the cation exchange capacity if you are going to use in the agriculture field. So you can also do some pre-treatment. You can have some soaking in some calcium or magnesium mixed aqueous solution. You can also do some treatment once you have the biochar, depending on the application. So the beauty is, when you have the biochar, you think about the groups available on the biochar. Whatever groups I have shown, these are few, but you will have many groups, and these groups are always going to give you some advantages when you are going to use that in the water remediation. So I'm not going into that detail. At that time, we published a review article. If somebody want to start work in the pyrolysis process, I think this is a worth reading. It is published in 2006, and so far it is cited more than 5,000 times. You get many properties and types of reactors, how to characterize the biomass, many things we have included in that. These are the applications where we apply the biochar. We are heavily working on the water filtration. We use that for organic as well as inorganic contaminant removal. We apply in the soil for soil fertility and also for the soil immobilization or remediation, and finally in the food security. Now, why we are interested to use to replace the activated carbon or the RO system? Because most of the time we are using RO in our houses, and if you look into the properties, what you are getting after RO treatment, you will hardly getting any ions. So the problem is nobody is looking into what is the minimum required concentration for the body. Only everybody is interested in the final concentration, that the limits of calcium, magnesium, or the TDS should be below a permissible limit. But you know, WHO, as per WHO recommendation in 2004, you require a minimum of 10 milligram per liter magnesium and about 20 milligram of calcium. So when you are going for the RO system, you are not able to achieve that. So basically, we are looking for the options if we can replace the costly activated carbon by using this low cost biochar. So we developed many biochars and we use for different contaminants, and we have demonstrated that how we can increase the absorption capacity of those biochars for these contaminants, even for the emerging contaminants. Then we also worked on a project to remediate arsenic from water, and we developed magnetic biochar because in the villages, especially in Bengal, where arsenic is a big problem, poor villagers cannot use the fancy treatment options, including ion exchange columns or different treatment systems operated using the electricity. So what we have done is we made this magnetic biochar where these biochar particles can be just dispersed in the tank, which they can make at the community level. And later on, after treatment, they can take this by using a simple magnet out of the water. And this water is ready for the drinking purpose. We also did some studies to find out if there is any leaching from the biochar or any other ions in terms of the toxicity. So there are many studies we have carried out to find the suitability of the biochar for arsenic remediation. We made those cartridges also, which can be utilized at home in simple bucket, or we developed a filtration unit. So I think this can be a good replacement for the costly activated carbon. Now, the second application I will briefly discuss. This is about the biochar application in soil. So what we have done is we took the biochar and apply at the recommended dose as recommended by IBI, International Biochar Initiative. You can select the dose between 5 to 55 tons per hectare. So we selected 8, 24 and 48 tons per hectare. Then we also use Then we also use the chopped biomass at the same rate, and we took the control, and then we carried out the studies. Let me show you the setup. This was a CO2 detector. This is a pump. This is the CO2 chamber where we have mixed the biochar and the biomass. So when you mix these together, we will be able to directly get the CO2 reading at the CO2 detector, and this will directly go to your computer. We use CO2 efflux analyzer. Now, this is, let me give you one simple calculation. If you made a char And let's say this char is having 90% carbon, and you are applying about 10 kilogram of this char, which is having 90% carbon. So based on a simple calculation, you will be able to sequester about 33 kilogram of CO2. So think about, if you are going to put several tons of biochar, how much CO2 you can take out of the atmosphere. So this is how we are dealing with the carbon sequestration. Now, the setup we made, this is the setup we developed in our laboratory. And these are some of the experiments which were carried out in the laboratory. These are some of the experiments which were carried out in the field, in the biochar research station we have in the school, and also we applied in the field. So overall, I just summarized this experimental work in 1 or 2 slides. So when you have biomass and when you have biochar, how you are going to also decrease the CO2 emission from the soil. So this graph is showing the study up to 79 days. You see, if you are applying the biomass and biochar, this is for the biomass and this is for the biochar, you will be able to decrease the CO2 emission up to 90, more than 90%. So if you are not converting the biomass into biochar and you are using the biomass, finally this biomass is going to convert into CO2 or nitrous oxide or methane. So that is again going back into the atmosphere. So this is, here we have the carbon neutral cycle, and this is where we are saying this is a carbon negative cycle. These studies were carried out with the rice husk biochar. Similarly, we also use other biochars, so I'm not going to discuss other biochars here. Let me give you some idea about the soil properties, how these soil properties are changing. This is the water holding capacity. This is the control without any biochar. So you have about 11.2%. But when you are using, say, about 30%, 3% of biochar, you will be increasing the water holding capacity to 30%. So this is how you will be dealing with the water holding capacity. Then again, you see the cation exchange capacity, it increases from 4.16 to 36. So there are many things. Nowadays, we are also working on the nano biochars because our Department of Biotechnology, they release the guidelines that you can start using the nano fertilizers. So we are also working on different issues, including how you can hold the fertilizer for the long time. So nano biochar with slow release of the fertilizers. So this is one of the applications where we are working nowadays. This picture is directly showing you how you have the growth of the plants. These are the tomato plants with the different doses of biochar. This is the control one. So this will clearly show. We also calculated the yield, the quality of the fruits, and we also carried out the other routine type of studies which are required to measure the plant growth. So overall, if you apply the biochar in the soil, it is going to increase the nutrient availability, microbial activity, soil organic matter, water retention, and crop yield. Simultaneously, it is going to decrease the fertilizer need. I am not saying that this will be 100% replacement of the fertilizer, but somehow you will be able to decrease the required fertilizer which you are using right now without any biochar. Then you are able to control the greenhouse gas emission, and this is also going to control the leaching of the nutrients as well as the erosion. This work, if somebody is interested, we recently published in RSC Advances, where you will get a lot of calculations regarding the carbon sequestration when you are applying the biochar in the soil. Now, let me give you the last slide where I think we demonstrated that even if you have the contaminated soil, this is the soil we collected from the contaminated area, industrial area. with high concentration of lead, cadmium, copper, and nickel, and then we put some biochar, we are able to immobilize those metal ions. So basically, what we were able to do is we are able to convert this bioavailable fraction into non-bioavailable fraction. So at least that soil can be utilized for the agriculture purpose. So this is what I was interested to show. And let me give you one last slide for the biochar market right now we have. So global biochar market is estimated to reach about $653 million by 2024, and it is growing at the CAGR of 16%. If you see from 2016 to 2026. So in terms of the volume, the global biochar market is estimated to reach about 32,000 tons by 2024, which is right now in 2015 was 6,271. So you have huge market available for that. And we hope, I think many people are going to contribute in this area and going to use the biochar for carbon sequestration or water purification or soil fertility, or even now many research groups, they have started using this biochar in the cement. They are using that for to replace some of the silica. So many applications are available. So this is what I was interested to show you, and I hope, I think I will be able to, I am able to give you some idea about the biochar research, what we are doing. So thank you for your attention. And now if somebody has any question, please feel free to ask. Thank you.
For the informative and excellent talk. And although you are not able to present physically, and we really appreciate your presence online, so let's see whether there are questions for you. Questions or comments?
So now,
so you, Dr. Mohan, you were talking about the carbon and oxygen ratio. Hello.
Ms. Mohan, can you hear? Said you can't.
Dr. Mohan.
Yes.
Can you hear?
Yes, yes, yes.
Yeah, so you discussed about the ratio between carbon and oxygen, and you explained it should be less than 0.7 to be considered as biochar. And if your product exceeds that ratio, and what is that called, and are there any applications of those products? Can you please explain?
This is basically, this is the guideline, or this is the definition of the biochar as given by the International Biochar Initiatives. So based on different research groups and the properties of the material you are getting. So if you have value more than that, I think then you will be keeping that in the under the umbrella torrefaction. So that is called torrefied wood. That is not actually the biochar. So that is a standard definition. And I talked about the H by C ratio, not the oxygen.
Further, I got it.
Yes.
Doctor, earlier you explained the difference between charcoal and charcoal. So in the definition, it was mentioned that both are produced from the thermal decomposition of different biomasses. So can you clarify whether if the only difference is the various biomasses or the biochar production?
Can you speak loudly? I'm not able to get your question. Can you speak loudly?
Dr. Mohan?
Yes.
Can you hear us, Mohan?
Yes.
Earlier you mentioned the difference between charcoal and char. So it was mentioned that both are produced from the thermal decomposition or different biomasses. So may I know the only difference is the using different biomasses or whether there is a difference between the biochar production?
Yes. I think this is a good question. Basically, when you are making charcoal, mainly you are using wood. But when you are making biochar, we can use any sort of biomass, agriculture residue, even you can use rice straw, wheat straw, you can use corn stubble, which you cannot use for making the charcoal, which finally you are converting into activated carbon, which we are using for water purification. But wood is also a biomass. So mainly wood, when you are using, you are dealing with the slow pyrolysis, the same what we are using for the biochar, but mainly you have the wood in case of charcoal.
Yeah, thank you, Mr. Mohan. Any further comments or questions? Mr. Mohan, thank you once again for sharing expertise on biochar with us. So let's thank him or this is representing Usual Man.
Thank you, thank you, thank you so much.
Yeah, thank you again. Okay, now we are starting the regular presentations. Again, as you know, the institute is conducting this conference under unusual circumstances due to this COVID-19 crisis. There are some guidelines that I have to announce. Professor Mohan are still here.
I can.
Yeah,
Yes.
there's a token of appreciation to be given to you. So we will honor you while you are not in India. So please stay with us for a couple of minutes. We are formally presenting you the token of appreciation, Professor Mohan.
Thank you so much. Thank you, Professor. Thank you, Dr. Samira. Thank you, everyone, for giving me this opportunity. Thank you.
Thank you again, and we'll meet you another time, Professor Mohan. Thank you again.
Thank you. Thank you.
Okay, so we are now starting the regular technical session. So the announcements from the organizing committee. So we should strictly follow safety guidelines and follow the seating arrangements with distance and wear the mask, the face mask. But when you make the presentation, maybe you can remove it. And also after each presentation, the surface around here, the podium, microphone will be disinfected. And if you want to use disinfectants here, the spray bottle, so maybe after and before your presentation, you can do so, you can use it. And about the time guidelines, as you all are aware, each talk is designed for 15 minutes. So therefore, each presenter is allowed 30 minutes for their presentation, so that 2 to 3 minutes will be allowed for questions. And to guide you on timing, the organizers will ring the first bell after 10 minutes, just once, and then after 3 more minutes, that means after 30 minutes, you will hear the bell ringing twice. So that is the signal for you to stop your presentation, so that will allow the audience have 2 more minutes for questions and discussion. And so, further ado, let's begin our sessions. And I was also asked to announce that the first 2 talks have been withdrawn, and they are from other countries, I believe. So therefore, we have to advance the presentations by 2 slots. So therefore, the first one in the session is ID number 15 on comparison study of the oxalate content in commonly used green leaf vegetables, authored by Devi Lianake and UK Jashundar, and presentation will be made by Devi Lianake.
Good morning, everyone. I'm Janani Devange, and I'm currently working as Morning, everyone. I'm Janani Devange, and I'm currently working as a teaching assistant in College of Chemical Sciences. So this is my undergrad research project, which is the comparison study of oxalate content in commonly used in vegetables. So, coming to outline, in introduction, I want to explain what is oxalic acid and what are kidney stones, and I'm going to explain. And in objectives, there are major 2 objectives are there. In materials and metals, there are main 3 steps: the oxalate extraction, distillation, and the quantification. And in results and discussion, I'm going to explain about the results, comparison, and then the conclusions. So basically, as you all know, oxalic acid is a dicarboxylic acid, which have a low molecular weight. And in plants, there are several types of oxalic acid, like free acids and water soluble salts, which combine with monovalent cations, and at the same time, water insoluble salts combined with bivalent cations like calcium, magnesium, iron, etc. So they occur widely in plant tissues. So, however, these salts cause kidney stones in human body. So, kidney stone is a hard mass of mineral consisting salts in our human body can be formed. So, basically, kidney stones have 65% of calcium oxalate or magnesium oxalate, according to the literature. And apart from that, kidney stones can consist calcium phosphate, uric acid, or cysteine. So, who is at risk for kidney stones? Kidney stones are more prevalent in men over 40 than in women. So, the person with one stone has 50% chance of developing another over next 10 years. So, patients diagnosed with kidney stones are advised to control and limit oxalate intake 40 to 50 milligram per day, according to the American Diabetes Association. So, coming to the objectives, there are major two objectives are there. So, analyze the oxalate containing different types of lipids, such as dietary intake, water, glucuronide, nimidy, carriage, etc. And at the same time, the comparison between oxalate content in those plant foods. So when it comes to biosynthesis of oxalic acid, there are major several parts, including different precursor molecules that come into biosynthesis of oxalate in plants. So serine, ascorbic acid, oxaloacetate, citric acid are there. So according to the literature review, commonly found that the primary content of ascorbic acid provided the oxalate formation in plants. So I have choose 50 different types of plants to my research. So those are the most commonly we are taking dietary intake in our consuming plants. Those are nidhi, kangkung, harvincha, hatavarya, tebu, etc. So coming to the methodology, for the sample was raw materials were collected from local market and they were freshly used for the next procedure. And coming to the preparation, they were pre-weighted and dried for 20 hours for room temperature and later were dried for 60 Celsius for further 20 minutes and also calculate the moisture content of each green leaves. So coming to the next step, oxalate extraction, I have used 20 grams of the plant material because I need to get a quantification and it was refluxed with acidic medium. I used 1.8 hydrochloric acid and it was, I tried for 6 hours, 8 hours and 12 hours, but the best results was given from 12-hour reflux. And after the extraction of oxalate, it was separated from using dilithium ether and all the organic compound to get rid of all the organic compounds. And using the aqueous layer, it was pH controlled by using ammonium hydroxide solution, and the resultant solution was treated with the saturated calcium chloride and got the precipitate of calcium oxalate. And then the precipitate was filtered off and washed with ammonium hydroxide wash solution. And the precipitate was dissolved in the sulfuric acid and it was used to a traditional standard method using standard solution of potassium permanganate and calculate the oxalate containing each plant. So coming to the results and discussion, the moisture content of each plants were calculated using this equation. And it was used to use loss on drying aerotic method, the standard aerotic method to get the moisture content. And all the plants have got about 80% of moisture content. So this is the side. And these are the results from my research. So nidhi, kangkung, harvincha had the highest oxalate content in the plant material, and least value of oxalate content had cabbage, leeks, and salad leaves. So according to my research, I categorized them into 4 different groups, which is arbitrary categorization. So the high oxalate content have, as I mentioned before, nidhi, kangkung, harvincha, and glucuronide. So this value is ranging from above 150 milligrams per 20 grams. So the next categorization is medium oxalate content. So it is Bulat, Patruguruga, and Pegu. It is ranging 100 milligrams to 150 milligrams. And the third category is lower level of oxalate. It is ranging to 10 milligrams to 100 milligrams. And the results was Godupola, mango leaves, minchi, and Hatha Varia. And the last category is undetectable amount. So this is below 10 milligrams. So the leaves are leeks, salad leeks, and cabbage. So conclusions, commonly consumed green leaf contain different levels of oxalate. So mainly, there are several factors depending on the oxalate level in plants, such as climatic change, soil condition, nitrogen status, or the species of the plant. And the preliminary explanation has mentioned that the most uneven distribution has found in plant leaves. So according to the results, if a person has a kidney stone disease or in his or her family history, they should reduce taking in their dietary intake in high oxalate plant materials, and excessive consumption of green leafy vegetables with high oxalate content may result formation of kidney stones. So I would like to acknowledge Dr. Udeki Jaisundara, my thesis supervisor, and I would like to thank College of Chemical Sciences and Institute of Chemistry for funding this project. And thank you very much.
Time for 2 questions. We can entertain a few questions, and I think one question now is spinach is a excessive amount of oxalate. So would you advise not to eat spinach?
If the person has kidney stone disease with family history, yes, right.
Questions from the audience? You also study the spatial radiation, the geographical radiation of the level of
No, sir, I collected all samples from the central province.
There are no further questions. Let's thank speed again. Next presentation will be on item 27. Effect of fertilizer application. And the next presentation is idea 27. Effect of fertilizer application, agricultural soil, and the determination of soil plant transfer coefficients of selected elements authored by W.P. Adi Pereira, M.D.N.R. Dayananda, W.S.N. Koteju, and J.A. Milyanege, and presentation will be made by M.C. Pereira.
You can make it in. PPT.
Good morning, ladies and gentlemen.
Some people
Good morning, ladies and gentlemen. Today I am going to discuss from my research work effect of fertilizer application to the agricultural soil and determination of soil plant transfer coefficient of strength of the demands. I am Ruan Pedro from University of Carolina. First of all, we will move on to the background of the research. Agricultural elemental sources can be categorized mainly in two parts. First one, potassium nitrate phosphate fertilizers, and second one, pesticides, including herbicides, insecticides, and fungicides. So, cadmium, lead, arsenic like toxic metal and metalloids contains in those pesticides and fertilizers. So there are four major pathways to contamination of the soil with heavy metals. Those are industrial activities, solid waste disposal, irrigation waste road, and pesticide and fertilizers. As the agricultural land, we need to more focus on pesticide fertilizers as well as irrigation waste road. So contamination of those heavy metals resulted slow accumulation in the crops and become direct source of the entry into the human. And our main objective is to evaluate the quality of the frequent use fertilizers and risk assessment of heavy metals in the paddy plants. And let's move on to the methodology. So 15 composite paddy soil samples and rice plants were randomly collected from selected paddy field in Kepawara Graminirani division in Anuradhapura district, and duplicate composite sediment samples were used for the chemical analysis. And urea, potash, and triple superphosphate selected for the analysis as commonly used fertilizers in Sri Lanka. 15 composite samples were collected from each type of fertilizer in the main store in Anuradhapura district. And this is the selected Graminirani division. The special thing is those Graminirani division has located near to the Kepawara phosphate mine, and soil will be definitely phosphate rich in paddy fields. And sample analysis was done using inductive bubble plasma mass spectrometry instrument. All paddy soil, paddy roots, rice sample, and fertilizer samples, digested sample were analysis. And data analysis, under the data analysis, we did descriptive statistics for the data treatments. And in order to evaluate the quality of the soil, we calculated geoaccumulation indexes. And in order to evaluate the risk, soil to root transfer coefficient also were calculated. And let's move on to the research and discussion part. Here you can see urea, potash, and triple superphosphate are recognized as frequent and commonly used fertilizers in Sri Lanka. And it is important to evaluate risk. That means safety and quality of those fertilizers. And this is the overall results of the fertilizer analysis. According to that, you can clearly see in urea some toxic heavy metals like cadmium, arsenic, lead, and chromium present in considerable amounts. Apart from that, potash and triple superphosphate also contain some amount of toxic heavy metals except arsenic and cadmium. And when we discuss risk of the fertilizer, our discussion should focus in two different scenarios. First one, the quality of the fertilizer, and second one, amount of the fertilizer. It means the farmers, we need to check whether the farmers are following the guidelines. That means they are applying, whether they are applying the exact amount than excess amount. And here you can see once the fertilizer contain most toxic metals, so paddy soil may readily contaminate with those toxic metals, and soil may retain chromium, cadmium, arsenic, zinc, copper, and heavy metals. And this is the soil sample, heavy metals contained in soil sample and rice fruit sample. So according to the transfer coefficient calculation, most of the transfer coefficient value as recorded as higher values. It means those heavy metals more ready, that means favorable to transfer from the soil to plant other than retention in the soil. And in order to evaluate the soil quality of the paddy soil, we have calculated geoaccumulation index. According to that, we have identified most of the heavy metals paddy soil have been moderately contaminated with most of the heavy metals. And again, I will come to this diagram. So once this toxic metal retained in the soil, it can be absorbed by the paddy roots, and toxic metal can transfer from plants roots to rice grain. And another risk is generating to food chain contamination with those toxic heavy metals. And this is the average amount of cadmium, lead, arsenic, and chromium content in rice grains in selected paddy plants. So according to that, it's clear there are considerable significant amount of toxic metals have accumulated in those rice grains, and human food chain also can be contaminated with those toxic heavy metals. So once those food chains contaminated with those toxic heavy metals, and the peoples who are frequently exposed to those heavy metals and long-term exposure may result chronic disease like chronic kidney disease in those areas. And this is the small discussion of the toxicity of the some heavy metals. So cadmium can accumulate in kidney and liver, and it results in renal dysfunction, decrease of glomerular filtration rate, filtration capacity, and the reabsorptive dysfunction. And another thing is lead. The long-term exposure to the lead can influence the nervous system, brain, liver, and kidney. And arsenic also have recognized toxic elements. So arsenic can deactivate enzyme, resulting in reducing DNA replication and repairing, and forming reactive oxygen intermediate, resulting for different type of carcinogenic conditions. And another thing is chromium. Chromium also kidney is one of the major targeting organs of some chromium compounds. So according to the results, it can be concluded that there is a high risk generating incorporate toxic heavy metals into food chains via agricultural soil, and because the considerable amount of metals coming from the fertilizer are remaining in the soil, and main toxic metal source of the soil will be low quality fertilizers. So quality and dosage of the commonly fertilizers need to be evaluated, and farmers should frequently educate regarding this issue. And finally, I would like to acknowledge CKD Research and Information Center, University of Calgary. Let me conclude my presentation. Thank you all of you.
This is now open for discussion.
What was the rice variety grown by there?
Rice variety. I don't know the rice variety, but the
So
sample.
different varieties have different accumulation.
Yeah, maybe. Yeah. So our intent was to identify the main heavy metal source and how to contaminate the paddy soil, and whether there is a risk to transfer those metals into the rice grains. So the rice variety also there's some impact on those scenario.
Yeah, further questions? I have a couple of questions. Now, you gave the analytical report on this phosphate and also urea.
Urea
and
potash.
And potash. And urea, among the three, urea has the highest level of arsenic.
According to the results.
Yeah. So, E6, okay, this is the warning to us. The highest level of arsenic among the three is from urea.
The level, we don't have the guidelines for the Sri Lanka, for the fertilizers, I was not able to find guidelines.
How much of that will be transferred to Ghana? Approximately.
Some small percentage, that means very, very small percentage can transfer into the rice grains according to our results. So the very amount, the tiny amount also maybe generate a risk due to the long-term exposure of those metals via rice varieties.
When you give the result of the rice grain analysis, it has a very high level of chromium.
Yeah.
Right. So is that level acceptable? The common level that you have pointed out for the rice?
No, it has beyond the permissible level. I don't have permissible limits.
It is above.
Yeah, above.
And also, the standard deviation of the many measurements are higher. We have the analysis of 3 trials or 3 different samples.
3 trials.
Different.
Sorry, 3 different samples.
Different samples. Yeah. So that's why there are high standard deviation.
Yeah.
Further questions? There are no further questions. Let's start the speak again. The next presentation is ID number 28. Removal of methylene blue from wastewater using cinnamon wood, authored by D.N. Vijayasekara and C.S. Udavatta, and to be presented by Ms. D.N. Vijayasekara.
Presentation.
A very good morning, everyone. So I will be presenting on removal of methylene blue from wastewater using cinnamon sawdust. So one of the major key areas of environmental pollution is water pollution, and it has impacted our environment very harshly. So when it comes to water pollution, removal of industrial effluents into these waterways have created a lot of problems with respect to water pollution. And as you can see, these are few images I obtained. Most of these industrial effluents, if not all, they use either one or more types of dyes, right? So these dyes end up in waterways, and my research is based on methylene blue, which is a cationic dye. You can see the compound over there, and some of the industries that use these cationic dyes are textile, rubber, plastic, cosmetic, leather, and painting. To be few, right? So 10,000 types of various dyes are made available every year in the world. So that sums up to around 7 to 10 to the power 5 metric tons of dyes. So when you take that yearly percent, the amount, from that 5 to 10% end up in industrial effluents. So that is a huge amount that ends up in the waterways, right? So even though a lot of dyes are carcinogenic, methylene blue is not that carcinogenic. It's not carcinogenic, but methylene blue has its own adverse effects, right? So it has burning of the eye when inhaled, breathing difficulties, nausea, diarrhea, mental confusion, vomiting, gastritis, and visual effects as well, because the color of the water is turned blue as well. So there are several treatments that are being carried out to remove these dyes, including chemical oxidation, reverse osmosis, coagulation, membrane separation, and so on. However, these end up being so expensive, right? So a country like ours, which is a developing country or less right now, so we need to find out an economical solution to this. So that is where a low-cost absorbent comes into play. So an absorbent is considered a low-cost absorbent if it does not require much processing, or if it is available in abundance in the nature, or it can also be a waste or a byproduct from agriculture. So natural absorbents tend to be really good candidates for low-cost absorbents because they are biodegradable, non-toxic, and biocompatible. So there are several studies that have been carried out in this area to be used as low-cost absorbents, sawdust of various types, tea waste, and rice husk, to name few. So the general objective of my research is to use cinnamon wood as an absorption medium to bind into methylene blue from industrial effluent, and specific objective includes to make a chemical economical modification into the sawdust to increase the absorption capacity. And in order to do that, a characterization study was also done with the absorbent, and a comparative study for the modified and the non-modified sawdust, while varying several physical parameters was done. And the data obtained were used to fit into the kinetic models and isotherm models to figure out what the mechanism is. And finally, to add a commercial value to the cinnamon sawdust, right? So why cinnamon wood? The question, the answer to the question is, it is native to Sri Lanka. It is Cinnamomum verum, also known as Cinnamomum selanicum. It is native to Sri Lanka. And I know most of y'all know cinnamon wood as with respect to the bark that is being used in the food industry, the fruits, the leaves, all of which are used in several industries. So, but the wood is discarded, right? So it is available in abundance, making it an ideal low-cost absorbent. So the methodology that I followed when producing a low-cost absorbent out of cinnamon wood, simple sodium hydroxide modification was done using the literature, and the modified and the non-modified sawdust was separately a characterization study that included SCM analysis, FTIR analysis, and batch absorption experiments with a control to vary physical parameters and kinetic studies and absorption isotherms. So the characterization study for both the absorbance, the FTIR analysis suggests according to the literature review, because the wood is composed of cellulose, lignin, hemicellulose. So once the modification was done, the peak at 1732 tend to disappear. That is resulted from the carbonyl functions from carboxylic acid esters that belongs to most of the lignin part is removed when you do the sodium hydroxide and create the polyol surface is converted into negative where the cationic methylene blue can bind easily. Therefore, absorption is increased, and this is what is said in the literature review if the modification is done correctly. So the SCM analysis, you can see the non-modified sawdust tend to show a low porosity and irregular surface structure. However, after the modification was done, large pores with macroporous surface structure can be seen. So the absorption capacity was calculated using this equation that finally you get how much milligrams per gram of sawdust was absorbed to the sawdust. Right? So the effective particle size, the smallest particle size obviously gave the highest absorption capacity. There were few outliers, but for the modified sawdust and the non-modified sawdust, it was the smallest, that is 150 micrometers. And the effective pH, as you can see, for modified sawdust and non-modified sawdust, even though there was not a big variance at pH 2, a drastic difference can be seen because the cationic dye is going to compete with the abundance of H flux at the pH 2 to bind into the sawdust. And effect of shaking time. And right, so from the effects of shaking time, the kinetic data were obtained, and these kinetic data were used to fit into several models: pseudo first order, pseudo second order, intraparticle diffusion model, and liquid film diffusion model. So once the data were plotted into the pseudo first order and second order kinetic model, they were fairly linear, and the R squared values were high for pseudo second order from modified sawdust. Even though the values were quite similar, you can see that for the modified sawdust, calculated QE is going to be quite similar to the experimental. So if you take the intraparticle diffusion model and the liquid film diffusion model, those are kinetic models that are used to identify what is the rate determining step. So if intraparticle diffusion model is the rate determining step, in the plot, when you plot this intraparticle diffusion model, it should be linear and it should pass through the origin. However, in my data, you can see multilinearity is observed. Therefore, intraparticle diffusion might have not been the solely rate determining step. There might have been other steps that are being included, and there is also an intercept you can see, that is boundary layer diffusion. The boundary layer thickness can be also, after extrapolating from the C, that is intercept, you can find that out. If you take the liquid film diffusion, that seems to pass through because the intercept was very small and it was very linear, and it showed high R squared value as well for both non-modified sawdust and the modified sawdust. So it is most likely that the liquid film diffusion was the rate determining step, which is a linear driving force rather than intraparticle diffusion being a radial force. So the data obtained were used to plot several absorption isotherms, namely Langmuir, Sips, Brunlich, Redlich-Peterson, Todd, and Temkin. And using the origin software, these curves are obtained, and the isotherm, the highest R squared was observed for the non-modified sawdust, and for the modified sawdust, it was for Redlich-Peterson. So this shows that the surface is heterogeneous and multi-layer absorption takes place. And so to compare the maximum absorption capacities from the non-modified sawdust and the modified sawdust under the optimum conditions, the physical parameters previously that was tested. So it shows a three times increment when it comes to the modified sawdust compared to the non-modified sawdust. So the absorption capacity has increased. In summary, as I mentioned before, threefold the absorption capacity has increased upon the base modification, and the kinetic data suggests the possibility of liquid film diffusion being the rate determining step, and the isotherm models fit best for non-modified sawdust, the top model, and Reddish-Peterson for the modified sawdust, and highest absorption capacity are also mentioned. So the results that were obtained from these studies suggested that cinnamon wood is an ideal low-cost absorbent, but with a simple and also an economical modification, it adds a value to the cinnamon sawdust. So the future work that I'm planning to do is to do desorption studies to regenerate the absorbent and to vary the temperature and to determine the thermodynamic parameters that affect. Thank you.
It's now open for discussion. Question. So, which is the option?
Yes.
On the soda.
So if you take the zero first order and zero second order, for the modified sawdust, it was zero second order that fitted best. So chemisorption must have been the major process that the mechanism that has been taking place. However, for the non-modified sawdust, the zero first order, even though the R square value was very quite similar to zero second order as well, the zero first order seemed to be the highest R square. However, it cannot be precisely said whether it is chemisorption or physisorption because the pH also it didn't vary much for the non-modified sawdust.
You do the studies with pH, how the pH affects the absorption of.
Yes.
No,
Yes. So I did within for modified sawdust and non-modified sawdust. For the modified sawdust, it didn't show much pH variance at all. So it was conducted at pH 6 with the deionized water. But however, for modified sawdust, there was a drastic lower compared to other points for the modified sawdust at pH 2. So because methylene is a cationic dye and H plus will be completing to absorb onto the cinnamon sawdust. So that might have been the reason that was conducted at pH 4 because even though it was comparatively similar, that showed the highest. Yes.
Questions? I have another question. If there are no questions, the audience. Now, what the difference between this transspectroscopic peaks?
Yes.
One after modification.
Yes.
Now, after between blue absorption, you do transspectroscopy.
Yes, sir, but there was not many characteristic differences not found. I analyzed the FTIR, even the SCM images were analyzed. So, not a change is not observed, sir. Only after, before and after the modification, there was a change in the IR on that small band because it's a good cellulose matter. See the same.
Normal soda is cinnamon.
Yes.
And even the special substances present.
In the FTIR analysis, if you consider, so with the literature review, FTIR analysis seem to be the same for all of the sawdust. Once the modification is done, it shows that characteristic difference.
In all substances are not present.
No, sir.
In absence of further questions, we'll stand speak again.
Thank you.
The next presentation, ID number 39, bioaccumulation of nephrotoxic metals in rice grains in a CKDU hotspot in Sri Lanka via soil analysis, authored by MD N.R. Dayananda and J. Lianage, and the presentation will be given by Ms. Dayananda.
Good morning, all of you. I am Nalika Dayananda from Department of Chemistry, University of Canada. Today, I am going to present our research findings on bioaccumulation of nephrotoxic metals in rice or rice sativa and spatial distribution of metals in a CKD hotspot via soil analysis. This is the outline of my presentation. I started my research on a deadly non-communicable disease which is prevalent in most of the dry zone in Sri Lanka. It is an unusual form of CKD known as CKDU. It means chronic kidney disease of unknown etiology. It is concentrated mostly in North Central and Northwestern provinces, but recently it appears in Uva, Eastern and other provinces as well. So majority of the CKDU patients were agricultural workers, and it is a huge economical burden to those family members and also as a country. So the main responsible cause for this disease has not yet been identified, but many of the researchers think that there can be a multifactorial origin for occurrence of this kidney malfunctioning. But those risk factors can be associated with materials which are consumed by the people in those areas in their day-to-day life, like soil, food, and water. In this research, we have focused on soil and food. So the sufficient amount of safe and nutrition food is key to sustaining life and also the promoting of good health. According to the Food and Agricultural Organization, food safety means ensuring food that the people consume is safe and free from any kind of contamination, including microbial, parasitic, and chemical contamination. If our food is contaminated, it causes severe chronic diseases like CKDU. When considering the country like Sri Lanka, the food contamination can be severely affected or severely cooperated with chronic diseases because the people in those remote areas are having poor or low middle income. So government should pay more attention to identify the food contamination pathways in order to mitigate those food contamination problem and those health risks. So according to the WHO, the dietary habits in Sri Lankans are generally distinctly different from other global dietary habits. According to the WHO GEMS, it means a global environmental monitoring system for food contamination monitoring and assessment program. Sri Lanka is categorized under G14 cluster based on the high consumption of cereals, especially rice, in their diet. So it is very reasonable to evaluate the dietary patterns and associated exposure to different nephrotoxic contaminants through rice in order to build a relationship between occurrence of those chronic diseases like CKDU and the food contamination. Okay, soil is need to the crop production. If the soil is contaminated with those nephrotoxic contaminants, it can be also adversely affected on our health. When considering Sri Lanka as a country with an agricultural background, the more attention should be allocated to contamination of soil when considering the spread of those chronic kidney diseases. So if the soil gets contaminated with those nephrotoxic contaminants, it has a potential to move to plants and get contaminated, bioaccumulated in the edible plant tissues, and they can enter to food chains in sufficient amount. Then it can adversely affect on our health. It means it can generate chronic diseases like CKD. So our specific objectives are to interpolate the spatial distribution of selected chemical elements via soil analysis, and to investigate the bioaccumulation of nephrotoxic metals in Orissa saliva in the CKD hotspot, Kirandurukote Gramandhari division, Badula district, Sri Lanka. Let's move on to research of the methodologies. Those are the two sampling sites we have selected for the sampling. Kirandurukote Gramandhari division was selected as the CKDU hotspot according to the data of Ministry of Health and Nutrition. And Dambetalavu Gramandhari division in Ampara district was selected as the reference where no CKDU cases were reported. And triplicated 30 soil samples were selected from the Kirandurukote Gramandhari division according to the random stratified sampling design. As you can see in the table, we calculate the number of samples each different strata according to the area of different land use pattern. And those collected soil samples were microwave digested according to standard procedures, and then those analyzed for the metals using inductive coupled plasma mass spectrophotometry. When moving on to the collection of paddy plants, plant samples were collected from corresponding soil sampling sites of paddy fields, and 5 paddy plants with grains and roots were collected randomly, each selected sampling point with an area of approximately 10 meter diameter. Altogether, 50 paddy plant samples were collected from each sampling site. In this picture, you can see the method of sampling paddy plants in Kirandurukote Gramandhari division for the analysis. Okay, then paddy plants are cut and separated into grains and roots, and those are separately microwave digested and then analyzed for the metals using ICP and MES. Let's move on to the finding and discussion of our study. This table showed the concentration of selected heavy metals, metalloids in soil according to Kruskal-Wallis test performed on the both data sets. Lead, cadmium and arsenic concentrations in soil is significantly higher in Kirandurukote Gramandhari division than the reference. It means Dambetalavu Gramandhari division. This slide onwards, you can see the spatial distribution maps we developed from the inverse distance weighted tool and the Moran indices generated by the spatial autocorrelation tool in ArcMap 10.2 software. So according to that, this map shows the cadmium spatial distribution. It shows the random distribution pattern throughout the Kirandurukote Gramandhari division. As you can see, there are some points with higher cadmium concentrations. Most of them are found in agricultural areas. It means the area with paddy cultivation. This is the lead spatial distribution in Kirandurukote Gramandhari division. It also showed random distribution pattern according to the Moran's index in low amounts. This is the arsenic distribution in Kirandurukote Gramandhari division. It is also it means higher arsenic distribution concentrations were found associated with the paddy cultivation, and it also showed a random distribution pattern throughout the area according to the Moran's index. This is the chromium content in soil in Kirandurukote Gramandhari division. And it also showed a random distribution pattern. Here you can see the nephrotoxic metals, metalloid in rice grains According to that, lead and cadmium were the most ingested nephrotoxic metals via rice consumption in the Gandhul-Kotte-Gramdari division. According to values of Krustal-Wallis test, the lead, cadmium, arsenic in rice is were significantly higher than the reference in the Gandhul-Kotte-Gramdari division. When talking about the bioaccumulation factor and the enrichment factor, bioaccumulation factor is less than 1 or equals to 1. It indicates the plant is going to absorb the selected metals, but it do not accumulate the inside the plant. If the bioaccumulation factor is greater than 1, it means that it accumulates the metal inside the plant. So those are the bioaccumulation factors for soil to rice grain. Those all are less than 1. It means rice grains do not accumulate the nephrotoxic metals, but they absorb those metals. Those are the enrichment factors calculated from soil to root and from root to grains. The root to grains enrichment factors are greater than 1. It means the higher availability of those metals in rice grains and rapid transferring of metals to grains via roots. So based on our findings, we can conclude that the degree of soil contamination by nephrotoxic metals, including cadmium, lead, arsenic, was significantly higher in CKD hotspot than the reference. And also they showed a random distribution pattern, and lead, cadmium were mostly ingested nephrotoxic metal via rice consumption. And based on those, rice can be considered as a major exposure route for the dietary intake of nephrotoxic contaminants in the Gandhul-Kotte-Gramdari division. So we can suggest that implementation of integrated agricultural systems and the awareness, development of awareness among the people living in those areas is important to mitigate those issues. Thank you.
Presentation is now open for
So we didn't identify the sources, but we think that one could be the fertilizers and pesticides, but they have a geographical relationship between those release of those metals to the soil.
much less.
Yeah.
Any idea of whether it comes from water?
Actually, sir, we tested the water samples, but the concentration is very lower than we thought. So we cannot identify the sources exactly, but that there is a relationship between the geographical, the minerals containing those.
Pointing towards the geographical.
Yeah.
Why do you identify only these 4 metals?
Sir, according to the toxicology of those metals, we searched the renal toxicology. According to that, we found those 4 metals as nephrotoxic heavy metals. That is why we taken. So we calculate the estimated weekly intake and compare with that with provisional tolerable weekly intake values. Cadmium and lead exceeding the safe limits, and at that moment arsenic safe limit is withdrawn by the WHO. Therefore, we cannot tell it exceed or not the safe limit. Chromium is no.
That is for all of us, I believe.
Yeah.
There are no further questions. We can speak again.
Thank you, sir.
the last presentation of the morning session, item number 9, in vitro antiglycation and antioxidant activity of the aqueous extract of leaves of Solanum by F.A. Irfan and Mr. Dharanyandala. Mr. Irfan will make the presentation.
Maybe online. Online, sir.
Oh, I'm sorry, that will be, the presentation will be made by online.
Hello. Hello.
Hello, yes, we can hear you.
Can you hear me? Okay, awesome. You can see the screen as well.
Can see the screen as well.
Awesome, thank you. Good morning, everybody. My name is Afra, and my research topic is on in vitro antiglycation and antioxidant activity of the aqueous extract of leaves of Solanum torvum, or more locally known as Tibbatu. Firstly, antiglycation was the main focus of my research, and it is said to be closely related to anti-diabetic properties. And diabetes is a disorder of carbohydrate metabolism where the body finds it difficult to produce or respond to insulin. And so it causes an imbalance in the blood glucose levels in your body. Another part of my research involves oxidative stress, which occurs due to an overproduction of reactive oxygen species. And the body is capable of producing certain antioxidant defenses against these free radicals, but when these defense mechanisms lessen, then in that case, it can cause harmful conditions in your body, such as cancer, Parkinson's disease, and also diabetes. In patients with diabetes, the high blood glucose concentration in the bloodstream leads to a condition that is called chronic hypoglycemia. And this is a condition that accelerates a certain process in the body called protein glycation. What protein glycation does is that it forms stable compounds known as advanced glycation end products or AGEs, where the accumulation of these AGEs in the body can cause serious chronic diabetic complications like retinopathy, neuropathy, nephropathy, and such. To give you a brief overview about what protein glycation is, basically what it does is reducing sugars such as glucose and free amino groups that are found in amino acids and proteins. They react together and form something called shift-based structures. And these shift-based structures, they rearrange to form amidori products via chemical transformations. This entire process is reversible, but then as soon as these amidori products undergo dehydration and rearrangement followed by other reactions such as oxidation and cross-linking, they form irreversible and the more stable AGEs, which are an advanced glycation end products. Another name for this process is also called Maillard reaction. For my research, I used fructose as the reducing sugar and bovine serum albumin, which also known as BSA, as my protein to induce non-enzymatic protein glycation to mimic the formation of AGEs. And my positive control that was used was aminoguanidine, which is a synthetic drug that was given initially for treatment purposes, but it was found to be toxic, so which is why we are looking into more holistic methods for medication. And as you can see on the screen, it shows that the aminoguanidine over here, what it does is it prevents the cross-linking from the amidori products that would form the AGEs and thereby reduce the formation of the AGEs. I also looked into the antioxidant properties of my plant. It's because antioxidants are said that they can help with the anti-glycation function by reducing the free radical production during the step of the formation of AGEs during the Maillard reaction. Also, phenolic compounds and flavonoids, they're both natural bioactive compounds that are found in vegetables, fruits, and plants, and they show potential anti-diabetic as well as antioxidant activity. The objectives of my research were to determine the antiglycation capacity of the aqueous extract of the leaves of Solanum torvum on fructose-mediated non-enzymatic glycation. So the aqueous extract of the plant was prepared according to the Kasai method in preparation in Ayurvedic medicine. And also another objective was to determine the content of the total phenolic and flavonoid content as well in the aqueous extract of the leaves, as well as to determine the antioxidant capacity using the DPPH and the hydroxyl radical scavenging assays. This was the plant leaf that I used. The plant was Solanum torvum, or more locally, commonly known as Tibbatu in Sri Lanka. And the mature leaves of this plant was collected from the tree before they had fallen down, and they were given to be identified at the National Herbarium in Peradeniya. I will be discussing the methodology and the results of each assay, like assay by assay. And how I extracted the plant material was the fresh plant parts were first washed and then air dried and ground to a powder. And then a known weight of the plant material that was ground was extracted with water according to the Kasai method of preparation in Ayurvedic medicine. And the water extract was filtered with a cheesecloth and then given to be freeze dried to obtain a powdered extract. And this powdered extract was stored in the freezer in airtight containers. My research on in vitro non-enzymatic proteoglycation inhibition assay used fructose as the reducing sugar, bovine serum albumin as the protein, and they were both prepared in a phosphate buffer with pH 7.4, which is the body pH, and it contained 0.4% of sodium azide to reduce microbial activity. And then the reaction mixtures were prepared as shown on the table, and they were all incubated at room temperature for a week. It is clearer in this diagram that is shown over here, where the control contains the BSA and the fructose in buffers in the buffer, as well as, and the control blank contains just BSA and the buffer, while the sample contains the BSA or everything, the BSA extract, the plant extract, fructose, and the buffer, and the sample blank just contains the extract, the plant extract in buffer. And the percentage inhibition was calculated using the equation that is shown on this screen. The fluorescence emission values of all of these mixtures, they were measured after a week using a spectrophlorometer. As you can see, I obtained values and I had a fluorescence spectrum that I obtained, and with each concentration of the plant extract. The control shows the highest fluorescence, which means that the largest amount of AGEs were formed with the control, which should be true, because since it doesn't have anything inhibiting the formation of AGEs. But then, as you can see, with the increasing concentrations that of the plant extract that we introduced to it, you can see that the inhibition increases as well. The smallest amount of concentration of the plant extract shows the least amount of inhibition, while the highest concentration shows the highest amount of inhibition. These were my values that I tabulated. And this bar graph shows the comparison between my positive control as well as my plant extract. As you can see, they're quite similar in inhibition. And I also found the total phenolic and total flavonoid contents of the plant extract, where because phenols and in particular flavonoids are shown to exhibit considerable antioxidant properties. And so I used them to see their antioxidant potential. So the total phenolic content was expressed in gallic acid equivalents per gram of the extract. And this was the method that I followed according to previously published articles. And the total phenolic content of the leaf extract was found to be around 111 milligrams gallic acid equivalents per gram using the calibration plot. And the total flavonoid content was determined using the aluminum chloride colorimetric assay, and it was determined with respect to milligrams of quercetin equivalents per grams of the dry mass. Again, the method that I used according to previously published articles. The total flavonoid content of the leaf extract was found to be 137.7 milligram quercetin equivalents per gram according while using the calibration plot. I also did, for my antioxidant assays, I followed the DPPH radical scavenging activity, where this assay measures the ability to scavenge the stable radical DPPH by the antioxidants that are present in the plant aqueous extract. And BHT or butyl hydroxyl toluene was used as my positive control or my reference standard. I used the methodology that is found in previously published articles, and my result, the scavenger activity percentage, was determined using the equation shown on the screen, and my values are tabulated as shown. And this is the comparison between my plant extract and my BHT, which is the BHT, which is the positive control. And as you can see, it shows a significant amount of it shows significant amount of scavenging properties in comparison to the BHT. My next assay was the hydroxyl radical scavenging assay. The hydroxyl radical itself is one of the most potent reactive oxygen species that is found in the body, because it can cause cell damage, as well as it plays an important role in tissue injury at sites of inflammation in oxidative stress originated diseases. It is also said that the hydroxyl radical scavenging capacity of any extract is directly proportional to its antioxidant activity, which is quite significant. And ascorbic acid over here, ascorbic acid was used as the positive control. This was the methodology that I followed according to previously published articles. And the result was found, the percentage scavenging activity was found using the equation that you can see on screen. And these were my tabulated results for each concentration of plant extract. The bar graph over here shows that the percentage hydroxyl radical scavenging properties of ascorbic acid and the leaf extract. And as you can see, it is quite similar, but the plant extract does show a little bit of a higher radical scavenging property than the ascorbic acid, which was my reference standard. And to come to a conclusion, we can say that the aqueous extract of the leaves of Solanum torvum that is prepared according to the Ayurvedic method of kasaya preparation, it has the potential to suppress complications arising due to the formation of AGEs in patients with chronic hyperglycemia, as well as the results also show that the plant extract itself has good antioxidant properties. And so it has the potential to be developed into a remedy to prevent diseases in which radicals are implicated. And thank you.
Ms. Irfan, I have a question. Now this inhibition efficiency you have explained as a function of concentration, and except in the last set of inhibition efficiency, they were linearly increased with the concentration. But in the last one, with this ascorbic acid, the inhibition efficiency was not linear. So any explanation? Yes.
Sorry, yes, I can hear you now. I'm sorry.
Can you hear the question?
I think I caught a little bit of it. Could you ask the question again?
Okay, again, yes, sure. Now the inhibition efficiency, you have like studied with different concentrations, and they were pretty linear, except for the last one, which is the ascorbic acid. Any explanation for the non-linear relationship with concentration?
the concentrations itself, like I believe I should have taken larger sort of ranges in the concentration itself. I did try so many, like I tried taking smaller concentration, but it still showed quite a linear sort of a linear sort of a build, like to the plant extract. So I did take a little bit of a different concentration range, but it did show only a small sort of increase in each concentration. So I believe like I should do more studies on it where I can take larger concentrations and also see whether it shows a high sort of concentration in a radical scavenging activity.
Further questions, the audience? Thanks, speaker. Now, this ends the morning session of the presentations. So we had 5 presentations and the invited speech, and they were really good, I would say, and covering many areas. Environmental chemistry and mineral chemistry, and the last one is antioxidant properties. Now I think they are ready to distribute the certificates. So may I call you by the name of the person? Now we distribute the awards, but not the certificates are for the presenters. Miss J.V. Lienege. Mr. W.P.R.T. Pereira. And the next one is P.N. Vijayasekar. And the next one is M.G. Renard Dayananda. The last one will send it to the person who was online, is Irfan. Irfan. So now we will have a keynote address. I think there. Also, yes, there's an Apple group for that. Out of 4 presenters, there are 2 winners to be selected. So I'm supposed to go to the Apple. I will. I pick 2. Mr. Irfan, who was online. The next one. Mr. Pereira. Could you come forward? So please come back at 11:30 for the keynote address. Thank you. We are done. We have to wait till those who are from the other two to come here to start the one speech. So I would say in about 10 minutes or so, we'll have the keynote address to be started. So we will leave and come back if you like in about 10 minutes.
you hear me? Can you hear me, Professor Rauter?
Yes, I'm here.
Okay. First of all, on behalf of the organizing committee, I want to extend my sincere apologies for the inconvenience caused early morning today for the miscommunication. So I would like to introduce you first. Right. So today's proceeding, the next item is the keynote address by Professor Amelia Rotel. Amelia Rotel is full professor of organic chemistry at the Faculty of Sciences of the University of Lisbon, Portugal. She is the president of the International Carbohydrate Organization and the secretary of the European Carbohydrate Organization. She serves IUPAC as the vice president of the Division on Organic and Biomolecular, she serves IUPAC as the vice president of the Division on Organic and Biomolecular Chemistry, as titular member of IUPAC, Division of Chemical Nomenclature and Structure Representation, and as associate member of its Interdivisional Committee on Terminology, Nomenclature and Symbols. Professor Rotel is the founder of the Portuguese Society of Chemistry Carbohydrate Group and the founder and leader of the CQE Carbohydrate Chemistry Group at the Faculty of Sciences of the University of Lisbon. Professor Rotel's research covers the development of new molecular entities for the treatment and prevention of metabolic, neurodegenerative diseases such as Alzheimer's and prion disease and infection. She has published more than 150 research papers and book chapters and authored 8 granted patents. She has been invited as speaker of national and international meetings. She is editor of Carbohydrate Chemistry book series published by the Royal Society of Chemistry, associated editor of the Mediterranean Journal of Chemistry. She serves as member of International Advisory Board of many reputed international journals, namely European Journal of Chemistry, Medicinal Chemistry, Journal of Carbohydrate Chemistry. She holds fellowships of the Royal Society of Chemistry and the Chemistry Europe. Among her honors, she was awarded with the Mention of Excellency by FCUL in all evaluations since 2007, with the prestigious prize offered by the Spanish Royal Chemical Society. Now, I would like to invite Professor Amelia Rotel to deliver a keynote address on salvia celluloides for dementia prevention from nature to the lab. Over to you, madam.
Thank you very much, Mr. Chairman, Chair Lady. Thank you so much for your introduction, for your long introduction. And thank you so much for Professor Paranagama and for the organizing committee to invite me to talk a little bit to you about part of the work we develop in our laboratory. And that is, as chosen by Professor Paranagama, related to the work we did with one plant, Salvia scleroides, for dementia prevention. In our group, our strategic areas are based on sustainable chemistry for functional molecules. We are carbohydrate chemists, and also we are natural product chemists, so on functional food ingredients from nature to the lab. We look for drug leads for pharmaceutical industries and more in the area of the sugar chemistry. And from natural resources, mainly, we look for functional food ingredients for food industries. The diseases we deal with are infection, diabetes, and Alzheimer's disease. And in nutrition, we are interested in finding nutraceuticals or food ingredients for prevention of the Alzheimer's disease. Now, Salvius clareoides, it is a plant that is spontaneous in Portugal and Spain. It is from the Iberia Peninsula and belongs to the genus Salvia. And as probably most of you know, Salvia is a very rich genus and has plants that are used for skin infection, for headache, memory loss, insomnia, and also Alzheimer's disease. So this plant is traditionally used for memory loss and headache in our country in infusions. And so we decided to study, to find the rationale, the chemical rationale for the activity that is traditionally used for. As you know, Alzheimer's disease is a very dangerous disease, has no cure, and the problem is that the patients have less acetylcholine than they should, which is the neurotransmitter. And there are two approaches, mainly two approaches, that have been for long studied to find new chemicals to address this disease and the cure or the control of this disease. One is the cholinergic hypothesis. And what makes it is nowadays they are inhibitors of acetylcholinesterase, which is the enzyme that controls acetylcholine in the brain, the levels of acetylcholine in the brain. So what happens nowadays mainly is that the treatment of 80 patients is made with rivastigmine, donepezil, and galantamine, which are inhibitors of this enzyme. So then there is also the amyloid beta cascade hypothesis, because there are formed plaques of amyloid beta, and these plaques isolate neurons and kill them. And so the problem is that it's also very typical, a typical event in Alzheimer's disease. So we will investigate our plant in these two hypotheses. But to investigate a plant, we need to make the extracts first. So we had we first made the infusion, as it is the infusion that people take when they use the plant. And then we made some extracts just to concentrate components, the acetone extract, and then from it in sequential extraction with the chloromethane, with methanol, and from here with butanol and water. Can you hear me?
We can hear you. Can you please change the slides? We can see only the first slide, the title slide only.
I don't quite understand. Do you see the presentation? Did you see the presentation?
We can see the presentation. Okay, you have to share the screen again. Now we can see.
Okay.
Okay, now, yeah, now we can. Yeah,
okay. Okay. Can I go on? Can I go on? Yeah. Okay. So then we make the extracts, and we studied the inhibition of Salvius clareoides extracts. And as you see, all acetone butanol water extracts at 10 microgram per milliliter had quite an interesting inhibition, particularly the butanol in the water extract. And at this concentration, the drug used in the market, rivastigmine, did not act at all. So these results were very promising to us, and so we decided to go on the study with the plant. And because in all diseases, there are always problems with the reactive oxygen species, antioxidants are always welcome in any kind of diseases, and also in AD as well. And because the total phenolic content is often responsible for the antioxidant activity, we studied the extracts of acetone, butanol, and water. And with a very simple methodology, as you know, the DPPH, radical scavenging assay. And we found out that the butanol extract, which was indeed the one that had the highest phenolic content, was the most promising one, with values, with IC50 values, the same order of magnitude of the reference compound, the ascorbic acid, in this methodology. It was also, again, quite interesting and promising. And because we cannot use an extract if it is toxic, we also studied the acute toxicity and the genotoxicity, and we found out that none of the extracts was toxic anyway. And the best, again, was butanol in all the indexes when compared to the blank and when compared to the toxic oxygen peroxide. And then, okay, we started, because all these promising extracts were preliminary studied with some interesting bioactivities. We decided then to make the phytochemical study of the plant. The acetone extract gave us triterpenes as major compounds. We isolated lupendiol, ursolic acid, heterarginine, and compound 5, and a new compound, which is the new lupin 1-beta-3-beta loop 2029 in 1,333-ol-1. And this compound was in fact new. Nepetidine appears in Salvia species for the first time, and sumaresenilonic acid appears in Salvia species for the first time. To elucidate the structure of this compound 1 was indeed a challenge, and it took us some time because, as I'm sure you know, NMR spectra are complex, carbon spectra are even more complex. We had to use all the bidimensional NMR techniques and mass spectrometry, but the key one that gave us that made us sure that we had this structure was NOESY, with the correlations of this double bond here, which is here, depicted with some other protons that were, which NMR was no problem to assign, as well as those of the C30 protons. Then we went to study the phenolic compounds, and we did this a little bit by HPLC, as you can see here, by HPLC MS, and we studied the three extracts: the acetone, the butanol, and the water extract. In acetone, the major compound was luteolin 4-O-glucoside, while in butanol and in water, we had as major compound the rosmarinic acid. And then we went to study also by HPLC, now HPLC DAD, to investigate the concentration of rosmarinic acid in all the extracts. In acetone, very little, as you could see before in the chromatogram. In butanol was the most promising one, with 134 micrograms per milligram plant, more than water. So you see, we have the butanol extract, which is the more antioxidant, which is the more active, which is the one that has the highest content of phenols and also of rosmarinic acid. Then we went to study by NMR and saturation transfer difference. We went to study, investigate the detection of ligand protein interactions with naturally the protein is the acetylcholinesterase enzyme. And we studied first the three extracts and also rosmarinic acid. And you can see here that only the butanol extract shows the interaction with with these protons of the rosmarinic acid, okay? And here they are. The C is the butanol extract and acetylcholinesterase, and the D is the NMR of the butanol extract acetylcholinesterase off resonance spectra, so that we can identify what these interactions mean, okay? So then transfer nosy experiments and calculations allowed to identify, to determine the major local minimum conformations in the bound state for rosmarinic acid, contacts with these protons HA and B, 2' and 6', the aromatic protons. And then after these studies, we wanted to see if this interaction was competitive with other enzyme inhibitors. And we made STD competition binding experiments with donepezil. And the result was that there is no competitive binding. So if you see here, you have in A, the STD spectrum for rosmarinic acid. In B, you have the STD spectra for rosmarinic acid and donepezil, both at the same quantity. And then you have the spectrum in C, where there is 3 more times, the amount is 3 times bigger for donepezil than rosmarinic acid. So here you see clearly that we identify here the protons of rosmarinic acid that interact with AC, with the enzyme, with acetylcholinesterase. You find them here, okay, no modified, but you see that from donepezil you have other results here, other signals. And when the quantity of donepezil is bigger, what becomes intensified are these signals of donepezil, not these that keep the same. So this means that they don't bind at the same site. So there's no competitive binding. Oops. No competitive binding. And finally, we could assign by making docking of donepezil and galantamine with both 3D models that we have a new binding site for rosmarinic acid. So discovered a new binding site for rosmarinic acid. Donepezil and galantamine, and they bind in site A, but our compound, our rosmarinic acid here, this is donepezil, our rosmarinic acid binds in another binding site. And this is this was our proposal, that we have this model for the interaction of rosmarinic acid with acetylcholinesterase. So from this part of the work, we can say that we discovered a new binding site to inhibit acetylcholinesterase in rosmarinic acid. And regarding the cholinergic hypothesis, we discovered new and not expensive and non-toxic functional food ingredient from Salvia sclarioides. And these results are quite interesting because they encourage the design and synthesis of other molecular entities based on rosmarinic acid as scaffold to exploit allosteric effects between the two binding sites. And this is a beautiful picture of the plant that was grown in the Escola Superior Agraria. So this is not a savage one as those that we studied. It's the one that is cultivated, and it works very well. It's quite easy to cultivate, and the plant is very, very beautiful, as you see. Now, we can instead of targeting, I told you in the beginning that we were interested in targeting everything we can find in the plant for to target AD or AD factors that this multifactorial disorder is really devastating. As you know, there's no cure. And I showed you what we did now on this cholinergic hypothesis, because a little bit more information. The AD patients have a reduced synthesis of the neurotransmitter acetylcholine, so have lower levels. And this gives a dysfunction of the cholinergic activity, the decline in memory and recognition. And the acetylcholinesterase is indeed the hydrolase that controls these acetylcholine levels in the brain. And the treatment is only effective, the treatment that is currently available is made with rivastigmine, galantamine, donepezil, and is only effective in the early disease stages. Then everybody knows that the amyloid hypothesis results from the normal amyloid protein precursor, which is not toxic, but it cleaves abnormally. And then it forms A-beta 142 oligomers. They are small circle oligomers that are very, very toxic. And that further oligomerize into fibrils. And then we have the plaques that isolate neurons and promote death, as you can see here. So the extracellular deposition of the amyloid beta peptide as amyloid plaques is a hallmark of AD, and it happens something similar also in the prion disease, which is also an amyloid disease, which is also related to Alzheimer's disease, because we know now that the interaction of the A-beta peptides with prion stimulates FIN kinase, activates FIN kinase, which activates by itself tau hyperphosphorylation. So all these issues are linked in these diseases. So we wanted to see if our extract also acts on the prion disease, on prion disease, and because here the cellular form, the soluble form PRPC of prion is transformed into also the insoluble scrappy form. And so in the Alzheimer, in AD, the fibrillar aggregates are toxic, promotes neuronal dysfunction and death and dementia. And you see here very, very well known, and everybody shows this picture. We have the healthy brain and the brain of an advanced AD patient, where it's much smaller, as you can see. So when we decided to study, we found out that rosmarinic acid does interact with A-beta 142. And we could see that the most involved in the binding are also HA, HB, and some aromatic protons also here, you see. And a little bit like before, we found it that HA and HB are indeed important players in interactions with with A beta 142, as well as I showed you before with acetylcholinesterase. So, in addition, we found out that rosmarinic acid removes preformed cystatin B fibrils. What is cystatin B? It's an amyloid. It's an amyloid protein that indeed is much easier to handle and to work with and acts like amyloid. So this experiment was done. And you see here the fibrils, right? Sorry. You see here the fibrils. And when you add rosmarinic acid, they are transformed into non-amorphous and non-toxic aggregates, which was a very, very interesting and promising result for us as well. And regarding the prion, as I told you, only the butanol extract interacted with prion PRPC. The residues with the resonance affected, we did this by NMR. The residues affected are 93 to 112 in the N-terminal region, 130 to 187, comprising the two strands of the beta sheet, helix 1 and helix 2, and 205 to 225, helix 3 at the C-terminus. It's all highlighted here. What happens is that indeed, we have here also compounds that interact with that stabilize the PRPC, somehow preventing that it becomes the scrappy form, which was also we were very interested in this result as well. Then we have we studied the salvius clareoides infusion, and what we went to see was, in fact, as you know, in an infusion, you have, when you study extracts, we concentrate all components. So in the infusion, the presence is the overall components, okay? And so the concentration is much lower. However, we mimic the digestion in the gastrointestinal tract, the gastric digestion, and the pancreatic digestion. So we made HPLC control of infusion components and evaluation of the bioactivities at 0 and 4 hours. And we investigated if the antioxidant activity and the anticholinesterase activity remained after treatment of the infusion with this, under these conditions. And we found out that they were maintained, both activities were maintained, antioxidant and the anticholinesterase. And we found out by the HPLC chromatograms that they kept their profile and their composition after the gastric digestion and pancreatic digestion. They have very similar HPLCs as those without, for comparison. So the rosmarinic acid peak, as you see, was not at all affected in any of the cases, and it's the major compound. Then, in collaboration with two other institutes in our country, Instituto Superior de Agronomia of our university and the Instituto Nacional de Saúde Dr. Ricardo Jorge, which is the National Institute for Health and Nutrition. So we studied, the master student studied the nutritional composition and the food fiber content, again, the total phenol content and the bioactivities of the cookies. We made cookies. We made salty cookies and sweet cookies with salvia, not with the extracts, but with the plant. With the plant grounded, and it was very interesting because we found out that the fiber, by adding salvius clareoides, the food fiber content increased. So the cookies are potential interesting for the prevention of colon cancer by increasing the food fiber. Then the total phenolic content we investigated, and in the cookies with 5% of S-scleroids and grain size 2 millimeter, we had a quite good phenol content. And we could see that the ethanol extract of the salty cookie made with 5% salviciclarides inhibited as well acetylcholinesterase activity. So you see here, we made several experiments, the control, then 2% salvia, then 5% salvia, the salty and the sweet cookies, and these were the best results we got was for these cookies with 2 millimeters grain size and with 5% salvia. They are not yet in the market, but we are working on it. So finally, in summary, our salvius clareoides is indeed a promising source of functional ingredients. The has multi-target extracts and infusion. They are not the extracts nor the infusion are toxic. They have antioxidant with radical scavenging properties. Acting on the cholinergic activity, they are really potent anticholinesterase inhibitors, mainly the butanol extract. The active principle is the rosmarinic acid, and we found out that there is a new binding site for this compound, for this rosmarinic acid. On the amyloid events, the rosmarinic acid interacts with A beta 142, these toxic oligomers in AD, removes preformed fibrils of amyloid protein, generating amorphous aggregates. So it acts on both cholinergic and amyloid events. The butanol extract also interacts with prion protein, avoiding her conformational changes. And this is important. This is important for both events, either for the prion disease itself as well as for the AD, because prion protein is very important by interacting with A beta oligomers to start the signaling pathway of FIN kinase. And the gastrointestinal digestion does not infect neither composition nor cholinergic activity of these compounds. And this is my beautiful plant that I love so much. And now, because you heard that I belong to the IUPAC division of organic and biomolecular chemistry, and you can, with this site, you can access what we have online on the division. I cannot lose this opportunity to talk to you, to invite you to be interested in our events and in our activities, and also to join us. Sooner or later you can join. We had the pleasure of having in the last meeting Professor Paranagama, and our division has also sponsored your meeting a little bit. What we can, we do. So our goals and strategy, the major goals are, what we want is really to encourage the application of chemistry to meet the world's needs. It's very, very important, as you know. And how do we do that? By strengthening the interaction with the chemical community. We organize and support some, not many, but some conferences. We have projects. We try to motivate and incentivize collaboration between scientists from all over the world. We promote chemistry in the wide public and policy makers by projects, website, collaborations, and so on. we submit projects and we encourage projects on relevant chemical problems. In fact, we are not an agency to support research properly. We support projects to generate ideas, to bring solutions, but not to run experiments. This is not probably a research funding agency. But it's very interesting, and in these projects bring a lot and are very, very interesting in many, many areas. We want to contribute to the education and professional development of organic and biomolecular chemists worldwide. We promote the advancement of chemical industry. We have lots of collaborations, and we encourage collaborations with industry. We encourage the application of chemistry to meet the world's needs. We are very much interested in motivating young talents, young chemists, talented chemists, and young from around the world to collaborate in these activities. Normally, and you will see in this meeting, we have young observers, which are young chemists, young biochemists, young scientists that are interested in our activities, want to come and are really welcome in our meetings. They only have to ask us in advance so that we allow them, and with all the organization that they are then allowed. They cannot come at the last minute, of course, but they are invited to work with us. And we promote diversity all over the world. So you will see here, if I would tell you, we are all from different countries from all over the world. Presently, our president is Nikolai Nifantiev from Russia. It's this gentleman here. The past president is Francesco Nicodera from Italy. He is, let me see here. I'm the vice president now, and the secretary is Slavomir Jarosz from Poland. He's not present in this meeting. This meeting was in Brazil in 2017. I don't have the photo, a nice photo from the last meeting. So Slavomir became secretary in the last meeting in 2019 in Paris. So he's not here in the building. Then we have 6 titular members, 6 associate members, and 10 national representatives. And of course, organic chemistry is important in many, many areas as biomolecular chemistry. So our members are national representatives are encouraged to belong to our subcommittees. And we have subcommittees on organic synthesis that bring together the experts in organic synthesis, on biomolecular chemistry, photochemistry, structural and mechanistic chemistry, and biotechnology. So what does this mean? So we have meetings every 2 years. We meet in the big IUPAC meeting, World IUPAC Congress meeting, and we make a general assembly before this meeting. And so they are scheduled, the meetings of the subcommittees. And finally, the last meeting is of the division with all the members of all subcommittees, so that we discuss everything we have to discuss. What should we promote? The projects we should go, the meetings we encourage, and bringing all together. It's very, very interesting and really very encouraging, very interesting. And I'll show you one of our projects, just for example, it's just one of them that is a little bit dedicated to the public in general, to bring people, non-scientific people knowledge by bridging ethnic food cultures through chemistry. And I take this opportunity, of course, to invite you all that are interested to collaborate with us in the project. We are very, very open. The task members, which are the people that are that should work for the project actively, doesn't mean that it's the only people that work in this project, but they are responsible to bring the project ahead. is the chair and the task group members. And we have here members from Portugal, from Italy, from Russia, from India, and from Hungary. And in this project, we will make a chemistry-based rationale on the benefits of various food cultures for disease prevention, of course. And the website is already online. You can access them. I think it's in English. It's a very interesting website that we are now enlarging with this new project and with these new food cultures. And this is the link. You find it Persila Nutri-Aging and then the link. It is a very interesting one, has one button, healthy eating, where you find all data that one should know on nutrition, based on nutrition made by our national reference laboratory that I talked to you about before. Then we have recipes and videos. It's a chef that is cooking and that is discussing about the properties with 3 experts, a young one and 2 other experts, okay, all in the areas and in the recipes. And it's very, very funny. And all the information and all the talks were studied from Web of Knowledge and Web of Science in the contributions, the recent contributions in there. So this is really very, very unique. And in the recipes, you see some kind of leaves. And then you click, because it's an interactive website, you click and you come to the vegetable gardens. And there you are taught how to plant the condiment or the green or the spinach or whatever, how you can plant it in the garden or in your window, some of them, okay? And then you are also encouraged by an architect how to make gardens. It's very nice. And then you have the clinical nutrition, the nutritional labeling, which is very important, and this enjoy button. This enjoy button is really unique. These are games that were made uniquely for this website. So it's I really encourage you to look at it, and I'm sure you love it. And if you love it, maybe you would like to collaborate with us by improving the information on this part on nutrition, or we are open to any contribution that you may find interesting for this website. And I'm almost saying goodbye. Our labs and our molecules. I just talked to you about rosmarinic acid, but we have many other interesting molecules for neurodegeneration and diabetes. This is anti-diabetic. This is an acetyl, a very interesting molecule. It's an inhibitor of butyrylcholinesterase, which is the enzyme that is important in late disease stages, because acetylcholinesterase level decrease. And by the end of disease, only butyrylcholinesterase is there. So these are selective inhibitors of butyrylcholinesterase. This is in our campus, our building. It's a beautiful building, won an award, and that is where we work, where we make our research. And now it's a little bit a problem with COVID-19, but I'm sure that this will not last forever. And I'll be delighted to invite you to visit our city, Lisbon. It is really a beautiful city, with bathed by Tejo, the river Tejo. This is very typical from our city. This is Monastery of Jerónimos. This is the Tower of Belém. This is all in Lisbon. And this is my group, my research group. Some of them are still with us. Others are already left, and new ones are coming. And so here we did a very, very beautiful, I also advise you to look at this site, because to celebrate the International Year of Chemistry, the 150 years of the periodic table, okay, for the 150 years, we made a flash mob with the music, we danced, and here are not dancers, these are university professors, university students, and administration. And they all, on a voluntary basis, they work together to make this dance. And I tell you, it's unique. And so we opened in the day where in Paris was opening the opening year, the opening event. We did this flash mob, which was the most cited and the most seen website up to now. It was really a success, and really people enjoyed it very, very much. And I have to thank the FCT is the agency that funds our research, for researching our center, and Europe for funding this project, Diagnostic and Drug Discovery Initiative for Alzheimer's disease. I showed you just a very, very little part of the work we did, of course, because we don't have time for more. This is my institution. I belong to the Faculty of Sciences of the University of Lisbon. This is our carbohydrate chemistry group. The link we had and is still active, because we changed from this Center of Chemistry and Biochemistry to the Center of Structural Chemistry. It's a bigger one. Here we have 80 researchers. Now we are 350 researchers, and it's a bigger center, and more important, it's classified as excellent. And it's a little bit what I brought to you, and I hope you enjoyed it. And I look forward to any of your questions if you like.
Hello, I'm Priyani here. Can you hear me from Slovenia?
Yes, I can hear you. A little bit far, but I can hear you.
Okay, yeah. It's a very nice presentation, informative one. I think there are a lot of young chemists in the audience. They learned a lot from you about carbohydrate chemistry, and also, about these assays and about the Alzheimer's assay and your aspartate esterase assays that you have done in the laboratory. And also, I think whatever that you said about the last few slides, very important. They also can touch with you to collaborate if they wish to collaborate, initiate in collaboration, so they can write to you also. I have to thank you very much for your nice presentation. I heard that there's a miscommunication happened, and you had to get up very early in the morning, and sorry about that. So thank you very much. So hope to see you again tomorrow morning in the Village Chemist Forum. Thank you.
Thank you, Professor Amelia Rauter, for sharing your expertise with us today related to isolation of bioactive compounds from natural resources to treat neurodegenerative diseases. Personally, as early career chemist, I enjoyed your talk, and I gathered a lot of information, since I am also working on organic synthesis and natural products chemistry. And there are, as Madam mentioned, there are a lot of young chemists here. Your information on IUPAC division on organic and biomolecular chemistry will be helpful for them in future. Thank you very much for joining with us today and it's your busy schedule. Even though you are not physically present with us today, we have arranged token of appreciation for you. We will deliver that to you in due course. Thank you very much for joining with us today.
Thank you.
This is the token of appreciation for you.
Thank you.
So this is the end of today's proceeding in the morning. So you can have lunch and we will meet in the afternoon session. Thank you.
Small announcement, lunch will be provided at the rooftop, but there are no seating arrangements at the rooftop. Lecture hall, that means the conference hall B, can be used to lunch, and also at the moment visit the poster presentations also in there.
By Professor Sarah Thomas from Royal Society of Chemistry. So we would like to invite all of you to come to the auditorium to listen to the keynote address.
Good morning from Cambridge in the UK. I'm Sarah Thomas from the Royal Society of Chemistry, where
to the afternoon proceedings. The next item is the keynote address by Dr. Sarah Thomas. So we have the video recording of her keynote address. Dr. Sarah Thomas completed her BSc program in chemistry at Warwick University, UK in 1983. She then worked for 1 year for a biosensor company before beginning her PhD at the University of East Anglia, UK with Richard Stevenson. Having graduated from UEA in 1990, she moved to Australia where she spent 3 years at the John Curtin School of Medical Research at the Australian National University in Canberra. In 1995, she joined the Royal Society of Chemistry in the books department, becoming shortly afterwards an assistant editor on chemical communications. She was later promoted first to deputy editor, and then in 1999 to the editor of the journal, a position she held for 10 years. In 2009, she began a new role in international development with responsibility for Asia and is currently the Senior Program Manager, International Engagement. Now, I would like to cordially invite the audience to listen to the video presentation of Dr. Sarah Thomas' keynote address on chemistry and Commonwealth.
For those of you who aren't already familiar with the Royal Society of Chemistry, we are the oldest chemical society in the world. And the core of what we do is connecting the world of science to advance chemical knowledge for a better future. We are a professional society for chemists, and as I'm sure many of you know, we are also a global not-for-profit science publisher. And finally, we are a voice for the chemical sciences. So let's have a look at some facts and figures about the Royal Society of Chemistry. Well, as I mentioned, we are the oldest chemical society in the world, and we were established in 1841, and we are a registered charity. We are a chartered professional body, and we have over 50,000 members worldwide. And as I mentioned, we are also a global publishing business. And last year we published 35,000 articles. And in addition to having a very successful publishing business, we also organise a great many events, scientific events, networking events, and events where our members get together. And in a typical year, we organise around 200 different events, and around 15,000 delegates will attend these. In terms of the staff who work for the RSC, we have about 550 staff all around the world. But importantly, we have a great many thousand volunteers who all work with the RSC to deliver its programme and are all around the world. Whilst the headquarters is located in the UK, we do have offices around the world in China, Germany, India, Japan, and the USA. Our purpose is to advance excellence in the chemical sciences, to improve the lives of people around the world now and in the future. And the way we strive to achieve our purpose is by fulfilling our three core roles for the global chemistry community. As a professional body, as a provider of knowledge, and as a trusted voice for chemistry. Throughout our history, we have in some ways fulfilled these roles for the community. And in the modern world, we do more on a bigger scale, but importantly, with more international partners. But the core roles remain the same. We are a professional body, we are a knowledge provider, and we are a trusted voice. So let's look at our roles in a little bit more detail. Our first role is championing the chemistry profession. And we're the UK's professional body for chemical scientists. And in doing this, we set and maintain professional standards and we support practicing chemists. And in particular, we do this through our Chartered Chemist scheme. And anybody who is a chartered chemist is recognised at having a particular skill set in chemistry and having been educated to a certain standard in chemistry. But we also enrich the teaching and learning of chemistry, and we have a very significant education department that provides resources for the teaching of chemistry in both schools and universities. The second role we fulfil for chemistry is as a provider of chemical knowledge. And here we accelerate the growth, dissemination, application and impact of chemical science knowledge. And I'm sure many of you are aware of the ways in which we do this. So we do this, for example, by publishing high quality scientific research, analysis, information and data. And in particular, we do this through our range of journals. But we also promote and enable the exchange of ideas and facilitate collaboration across disciplines, sectors and borders. And much of this is done through the great variety of different meetings and events that we organise. So, for example, last year we published over 35,000 different scientific articles across our 40 high-quality journals. And 25% of these articles were published as open access. And as open access becomes more important, we're trying to make the transition as easy as possible for chemistry, while remaining a sustainable publishing business. We're launching new open access journals and agreeing new deals with institutions that enable researchers to publish open access more easily with us. We also, of course, publish books and have published more than 1,000 books over the last 50 years. And of course, there's all of our events, more than 200 scientific events worldwide, attracting more than 15,000 delegates. And through these events, our members and our authors and our delegates can all come together to share their experience, share their research, share their knowledge, but also, of course, form new networks and new collaborations. And some of the events that we organise worldwide are collaborations with other international chemical societies, so our sister societies around the world. And we have many memoranda of understanding with these societies. The third role we have is using our voice for chemistry. And here we ensure that chemistry has a recognised and influential voice. And we do this by engaging and enabling our diverse community to use its voice to promote the chemical sciences. We try to influence decision makers wherever possible, particularly in the UK and with the UK government and funding agencies. And we lead debate and discussion with our own research, such as our recent Breaking the Barriers report into women's progression in the chemical sciences. And this report was launched last year and has been distributed all across the world and caused Lots of discussion, panel discussions have taken place at various events, and it really seems to be having an impact in terms of ensuring that the retention and progression of women in the chemical sciences is high on everyone's agenda. And finally, we connect the chemical sciences with the wider world. And that last point is particularly relevant in the context of this talk that I'm giving today. A big priority for the RSC is bringing chemical scientists together. One of our strengths as an organisation and one of our most important responsibilities is to convene the right people in the right place at the right time to advance chemistry. And Commonwealth Chemistry is a prime example of this, and I'm pleased now to be able to go on to tell you a little bit more about this new and exciting initiative. So why the Commonwealth? Well, the Commonwealth is a uniquely diverse group of nations with shared values and a powerful voice. It represents all the corners of the globe, from small island nations to large countries. And with its 54 countries, has 2.4 billion people. It is home to 12% of the world's researchers and accounts for around 10% of global research and development expenditure. So science is uniquely placed to contribute to the Commonwealth's shared goals of democracy and development. And with an estimated 60% of its population under the age of 30, the Commonwealth is set to play an ever more important role in the world's future, a future that will present many challenges where science and chemistry can identify solutions. So where did the Commonwealth Chemistry Initiative start? Well, the Royal Society in the UK has organised two very... Seeing how successful these were, the RSC explored, and we were really pleased that Professor Sophie Swaran was able to meet with us at the FACS Congress in Melbourne and share his thoughts on the Commonwealth Chemistry Initiative. All the roundtable discussions generated extremely enthusiastic responses, and it was clear that the Commonwealth Chemical Societies were interested in exploring how we might establish stronger links as a group of Commonwealth societies. So following this, the RSC was honoured to be able to host delegates from 24 Commonwealth countries, representing more than 20 chemical societies. And you can see here the meeting taking place in our headquarters in London, in the library at Burlington House. And all around the room, we have the representatives from all of the different chemical societies, scientific academies, and federations, representing the 24 different countries. And we put flags on the tables to represent all of the countries. And it was a really exciting event to be part of. And the group collectively concluded that there are significant opportunities in creating a federation of Commonwealth chemical societies, and that this umbrella organisation should mirror the concept of the Commonwealth itself, which is to be aspirational, inspirational, and provide strong role models. And all the countries should have equal representation within the federation, enabling the voice of smaller countries to be heard equally alongside the larger countries. and in particular countries that don't have a chemical society. So within the Commonwealth group of nations, there are several countries who have communities of chemists but don't have a chemical society. And the Federation would provide an opportunity for them to have a global voice. In addition, the Federation would organise a series of Commonwealth Chemistry Congresses featuring the contribution of the chemical sciences to the UN's Sustainable Development Goals, and championing also the role of early career chemists. Following the meeting, a task group comprising of some of the attendees was formed, and Commonwealth Chemistry, a federation of Commonwealth Chemical Sciences societies, was created. And it has as its vision, one community, one voice, catalysing equality for all, and has as its mission to inspire, elevate and celebrate the role and practice of the chemical sciences for the benefit of Commonwealth nations and their people. And Commonwealth Chemistry, the Federation, also has very clear guiding principles. And these are to have equal and inclusive representation from all Commonwealth nations, and to recognise that those with greater resources will contribute more in order to assist those with fewer resources. So both of these together support the idea that the Federation will have the equal and inclusive representation, and that all Commonwealth nations, regardless of whether they have a chemical society or not, will have a voice through this Federation. And in fact, one of the goals of the Federation is to help the countries who don't as yet have a chemical society and would like to have a chemical society, to help them to establish one. The Federation now also has an executive board. This has just been set up and is made up of 12 different people from all across the Commonwealth. The first president is Dr. Vicky Gardiner, who is also the current president of the Royal Australian Chemical Institute. And we are really pleased also that Professor Pirana Gama is a member of the executive board. So there were two recommendations from that meeting held in London in 2018. The first was the creation of the Federation, and the second was to organise a series of Commonwealth Chemistry Congresses. And the first of these was scheduled to take place in May this year in Trinidad and Tobago. But of course, it has had to be postponed due to the COVID-19 pandemic, and it will now take place in May next year. And it's planned to be a physical event still in Trinidad and Tobago at the University of the West Indies. The aims for the Commonwealth Chemistry Congress really mirror the mission and guiding principles of the Federation. So importantly, equal representation, so that all Commonwealth countries taking part in the Congress are equally represented. But one of the aims is also to strengthen the scientific capacity within the Commonwealth and inspire and elevate the role of chemistry to society and also to policymakers. And again, thinking back to the vision, mission and guiding principles, to celebrate the achievements in our discipline of chemistry. And the Congress also has a big focus on early career chemists, and how to support early career chemists. And finally, within the scientific scope of the meeting, the aim is to create effective partnerships for the UN, for delivering the United Nations Sustainable Development Goals. And that leads to the strapline for the Congress of Partnership for the Goals. The Congress has 6 scientific themes, all linked to the UN Sustainable Development Goals. But it also has additional sessions on topics such as career conversations, which will particularly be targeted at the early career chemists, on topics such as taking chemistry to market, a panel discussion on inclusion and diversity across the Commonwealth, and a look at research infrastructure throughout the Commonwealth. And all of these sessions will take place within the Congress, either as plenary sessions or parallel sessions, via panel discussions or through poster sessions. We very much hope that all of the delegates who would have joined the Congress in Trinidad had it taken place this May will still be able to come to the Congress when it takes place next year. And we are hoping that about 300 delegates will join the Congress. And within those 300 delegates, that at least 40% of them will be women. At the moment, we have 41 Commonwealth countries taking part in the Congress. And within those 41 countries, this represents 21 Commonwealth chemical societies. And importantly, there's 120 early career chemists taking part. And in order to achieve the goal of equal representation, each country, regardless of its size, will be represented by 3 early career chemists. And we are really pleased that there are 3 early career chemists taking part in the Congress from Sri Lanka. Because each country is only represented by 3 early career chemists, the national chemical societies or other leading organisations in countries where there is no chemical society were responsible for the selection of their representatives. So we're really looking forward to when we all can come together in Trinidad next year to meet all of these outstanding early career chemists from across the Commonwealth. But in addition, there will also be 38 senior speakers, again from all around the Commonwealth, who will be talking around the topics, around the scientific themes, and also taking part in the panel discussions and other sessions. And from the early career chemists, 66 have been chosen also to give talks in the programme. With the postponement of the Congress, the Commonwealth Chemistry Executive Board wanted to hold an event that would build on the momentum and engagement that we'd seen in the lead up to the dates of the Congress and create an opportunity to start building the partnership. And so a virtual poster event is scheduled now for next month. So this event is called Commonwealth Chemistry Posters, Building the Partnership. So it links to the Congress, which has the strapline, if you remember, Partnership for the Goals. And we're looking here at bridging chemistry across the Commonwealth to tackle the SDGs. And this poster event is for all of the early career chemists who would have attended the postponed Congress and will attend the Congress next year in Trinidad. And they will be presenting the poster that they would have presented at the Congress. And so it's an opportunity for networking and research sharing to take place before the Congress takes place in 2021. So we can really begin to build the partnership. And as all the themes link to chemistry and its role in tackling the SDGs, we can really begin to bring chemists together across the Commonwealth to really tackle the Sustainable Development Goals. And the poster presenters will also be judged, and poster prizes will be awarded. And the criteria will include the way the poster is presented and the presenter's scientific understanding of their work, and also how they relate it to the Sustainable Development Goals and to the wider Commonwealth. So what else is the Commonwealth Chemistry Federation doing? Well, in partnership with the Royal Society of Chemistry, members of Commonwealth Chemistry chemical societies can access content in the RSC's members magazine, Chemistry World, for free until the end of the year. And this is a special scheme set up for members of chemical sciences societies that are part of Commonwealth Chemistry. And it's very easy to claim the free access to Chemistry World. Simply log on to the website and register, and you can start reading and accessing all of the information on the Chemistry World website. Another important piece of work that the Commonwealth Chemistry Federation is undertaking is a survey of the Commonwealth chemical science community, and in particular, the early career chemists within the chemical science community. So this survey really provides a fantastic opportunity for early career chemists to share their views with the Federation. And the survey is going to focus on the needs, challenges and opportunities that early career chemists are currently encountering. So for example, around training and funding, the working environment, career progression for early career chemists, and networks and collaborations. The survey is planned to be live in September, and the outcomes from the survey really have the potential to influence the strategy and direction of the Commonwealth Chemistry Federation. So the Executive Board really want as many early career chemists within the Commonwealth to complete the survey, because the more people that complete it, the more information they will have, the more they will be able to think about what are the important things that the Federation needs to focus on in the coming years. So when you get notification from your chemical society that the survey is live, please do get involved and complete the survey. It really is your opportunity to influence potentially the strategy and direction of the Commonwealth Chemistry Federation. So other plans that are underway are the creation of a website for the Federation. That's currently in progress now. We hope to launch that very soon. And the Executive Board are also thinking of other ways to support the Commonwealth Chemistry community, particularly during this COVID-19 pandemic. So thinking about resources that we might be able to make available. So do get involved and do look out for news from your chemical society about what the Federation is doing. So I've talked a lot about we, and in many of those instances, I'll have been referring to the Commonwealth Chemistry Secretariat, which is currently provided by the Royal Society of Chemistry, and in particular, the four people here on the screen now. The Secretariat is led by Ali Palermo. I'm sure many of you here will know Ali. And also with me are two other colleagues, Rachel Thompson and Stuart Govan. So many communications that are coming out from Commonwealth Chemistry will have our names on them. So now you'll know the faces that go with the names. So just in the final 3 slides, I want to share with you some information about 3 schemes that the Royal Society of Chemistry run. The first of these is our Grants for Carers scheme. And some of the research that the Royal Society of Chemistry has undertaken has shown that many people have caring responsibilities, and that actually the caring responsibilities can have an impact on someone's career. So, for example, someone who is caring for children, or is caring for an elderly or for a sick relative, these circumstances can make it difficult for that person to, for example, travel to attend a chemistry conference. And so it can impact on their career because they lose out on opportunities to present their work, to share their research, network, and potentially meet new collaborators. So the Grants for Carers are there to cover the costs associated to help with the caring responsibilities. So, for example, someone who has childcare responsibility could apply for one of these grants to cover the cost of their partner also travelling with them to the chemistry conference so that they can look after the child or children while that other person attends the conference. But the purpose for the Grants for Carers has also been temporarily extended during this COVID-19 pandemic to also cover the costs for any equipment that someone may need to work from home or to provide homeschooling, as we're all finding that we are having to work from home and that schools are closed. And also to cover costs for any care that you usually provide, so that you can attend online meetings or online conferences such as this one, for example, or workshops or professional development and teaching responsibilities. Again, this is during this COVID-19 pandemic. And the grants for carers are available for up to £1,000 a year. The equipment for home working and homeschooling is a limit of £500. And this is open to all RSC members. We also have our Chemists Community Fund, and this is the RSC Members Benevolent Fund. This fund was actually set up in 1920, so this is our centenary year. And the aims of this fund are to prevent and alleviate poverty, but also, importantly, financial support for members and their families. And all of the insecurity that's created through this pandemic has led to a significant increase in requests for help this year. But this fund is extremely well funded, and so all of the eligible cases are being supported. And just to add that the fund is available to our members, of course, across the world. Finally, 3 questions. So, who can adapt resources for students with disabilities? Who can research inequality in the chemistry community? Who can raise the profile of female scientists? Well, the answer to all 3 of these questions and many other similar questions are you can. And the RSC can help with this with our Inclusion and Diversity Fund. Now, this fund provides financial support for innovative products, activities, and research projects that help make the chemical sciences community more inclusive and diverse. And this particular fund is open to all RSC members and RSC member groups, but importantly, it's also open to non-members. So anybody can apply for this fund. And we're finding applications come from researchers in academia or industry, but also from museums, from community groups, from not-for-profit organisations, arts groups and libraries. And the funding for this scheme is up to the value of £5,000 for every application that is made. So this is a really exciting opportunity to really make a difference in inclusion and diversity. So if you have a great idea for how you can make a difference in this area, do have a look at this fund and submit an application. So with that, I would like to say thank you very much for listening, and thank you again to the organisers for inviting me to join this conference. Apologies again that I can't be there in person. Obvious travel restrictions have prevented me from coming to Sri Lanka. I would have loved to have been there with you. I was so looking forward to visiting Sri Lanka. Hopefully I'll have another opportunity in the future and we'll be able to meet you all in person. Of course, as I can't join you in person, I can't take any questions at this point. But if you do have any questions about Commonwealth Chemistry or about the Royal Society of Chemistry, please do get in touch with me via this email address here. So thank you all once again for listening. I hope you have a fantastic conference, and I really do hope that I'll have a chance in the future to meet you all. Thank you very much.
Thank you very much for listening to the keynote address by Dr. Sarah Thomas, Senior International Development Manager, Royal Society of Chemistry. Even though she is not present with us here, we have token of appreciation for her. So we will send this to Dr. Sarah Thomas in due course. Thank you very much for attending the keynote address. Technical sessions commence at 2 p.m. in 3 halls, Hall A, Hall B and Hall C. So you can join the technical sessions.
Good evening, ladies and gentlemen. Before we move on to the technical sessions, we have the award distribution for the poster presentations. And to distribute the certificates for the poster presenters, I would like to cordially invite the Registrar of the Institute of Chemistry, Ceylon, Mr. N.I.M.S. Nadarasa. H.D.P. Vikramaratna for the poster presented on nitric oxide radical scavenging potential of selected widely used spices and a mixture of spices. D.P.H. Kandambi for the poster presented on the development of novel photodegradable linear low density polyethylene and investigation of the antibacterial properties. R.A.D.J. Ramanayaka for the post presented on qualitative analysis of heavy metal absorption by the green synthesized silver nanoparticles. H.N. Vimalasekara for the post presented on development of a herbal tanner stream using 4 medicinal plants. We have Ms. G.P.H. Kandambi for the post presented on the development of a novel photodegradable linear low density polyethylene and investigation of the antibacterial properties. P. Prabodha Deshani Kure for her poster presented on the development of a herbal drink using Sri Lankan varieties of Sesbania grandiflora and Citrofortunella with microcarpa and its antioxidant activity. DRLM Vimala Gunasekara for her poster presented on in vitro antioxidant and anti-inflammatory activity of the Ayurvedic medicine Rasna Saptaka Kashara. K.P. Madhushanti for her poster presented on antimicrobial potential in extracts and topical ointments prepared from Acorus calamus L. EMRKB in the distinct for the poster presented on assessment of mercury and arsenic contamination of cow's milk and goat's milk in Anuradhapura district. A.N. Vekalava for the poster presented on development of perfumery products from cinnamon wood extract. Thank you, Mr. Madrasa. Those were the poster presenters for today. Shall we give a round of applause in appreciation of their hard work? Now we move on to the technical sessions, and I would like to hand over the controls to our session chair for Hall A, Dr. Sisira Salivindamuge.
Can I have your attention, please? There's another small announcement. You all know that tomorrow morning there is a session for that is called Women Chemists Forum. So all of you are invited. No discrimination, right? Please attend everybody. So all are invited for this forum. It's not a joke, right? So all are invited. Therefore, please be present tomorrow morning, starting from 9 to 10:45. All are welcome.
Good afternoon, everyone. Now we are about to start the technical session 8 after the lecture from Professor Todd Lesnar, Department of Chemistry, Mississippi State University, USA. Before starting this presentation, I would like to read out his citation. Todd E. Lesnar was born and raised in southern Michigan, USA. He is a professor in the Mississippi State University Chemistry Department, where he teaches analytical and environmental chemistry. His bachelor's degree is from Albion College and his PhD from the University of Texas. His graduate work focused on synthetic organic fluorine chemistry, as did his postdoctoral work at Clemson University from 1994 to 1998. He worked at the Naval Research Laboratory, Washington, D.C., on the development of adsorbent polymer film based chemical sensors. In February 2003, Dr. Lesnar founded C-Coast Science, a private chemical sensor company, and served as president for 6 years. He joined the chemistry faculty at Mississippi State University in 2009. His current research is focused on miniature chemical sensor systems, water remediation, and soil amendment using byproducts from the biofuel generation industry. So it is the time for us to listen to his speech.
No,
Well, before I get started, I'd just like to thank you for the invitation.
Well, before I get started, I would just like to thank you for the invitation. I'm very sorry that I could not join you in Sri Lanka this summer. I was so looking forward to the visit. Well, let me go ahead and get started. As you can see, the title of my presentation is Energy Use, Past, Present, and Future, Alternatives to Fossil Fuels. And my name is Todd Melsna, and I'm a professor at Mississippi State University in the Department of Chemistry. Well, I'd like to start off with an overview of my research. I have a group of about 10 graduates and 10 undergraduates, and I have a few collaborators on and off campus. And with 20 people in the lab, we have a lot of projects. Our focus is on environmental chemistry, and here we have some of the visual abstracts of some of our recent papers. We have some projects that are aimed at environmental monitoring. We have those that are focused on method development. We have most recently been doing some soil amendment, but for the most part, our research has lately been focusing on water remediation. All right, so that's my research. Now let me move on to the presentation, the energy past and present. That's what I'd like to start off with. Mankind has gone through several energy transitions over the years. 500 years ago, energy needs were met with food for man and animals and the burning of wood. The concept of energy transition is based on the notion that a single energy source or group of sources dominate for a particular period or era and then are replaced by another major source or sources. This has happened throughout history. Man started off with using food for labor and for animals, also with the burning of biomass for heat and energy, but we moved on, and today most of our energy comes from fossil fuels, the coal, petroleum, and natural gas. And that's where we are today. In the United States, most of our energy is met with these fossil fuels, and here you can see the transition from the 1800s to today, where petroleum, natural gas, and coal dominate. Another non-renewable energy source, nuclear power, is also a big contributor in the US. So this is where we get most of our energy. Coal, oil, and gas are called fossil fuels because they've been formed from the fossilized remains of prehistoric animals and plants. They provide about 66% of the world's electrical power and about 95% of the world's total energy demand. Without energy, life does not exist. All forms of life extract energy from the environment and convert it into forms which can be used. Throughout history, man has developed ways to expand his ability to harvest energy. The primitive man found in East Africa 1 million years ago, who had yet to discover fire, had access only to the food he ate, so his daily energy consumption was estimated to be about 2,000 calories a day. Throughout history, as societies become more advanced, their energy use has increased. Early man relied on himself to provide all the energy to do all the needed tasks. Energy consumption of the hunting man found in Europe about 100,000 years ago was about 2.5 times that of primitive man, or about 5,000 calories a day, because he had better methods for acquiring food. With the discovery of fire, humans began to use energy that was not obtained for food. Fire was used for cooking and for heating. As civilization advanced, animals were used to provide energy. Energy consumption increased again by almost 2.5 times, or about 12,000 calories a day, as man evolved into primitive agriculture man about 5,000 years ago, who harnessed draft animals for the growing of crops. The advanced agricultural man of 1400 AD in northwestern Europe again doubled the amount of energy consumption to about 25,000 calories a day as he began inventing devices to tap the power of wind and water, began to utilize small amounts of coal for heating, and harnessed animals to provide transportation. A great surge in the use of energy came with the development of the steam engine in the 1800s. This happened at the start of the Industrial Revolution, and in 200 years, from 1725 to 1925, the per capita energy increased by another tenfold. Wood was initially used to fuel these steam engines. Then in 1830, wood became scarce and coal was used. And by 1910, coal was a major source of energy in the United States and provided about 70% of all energy used. Petroleum did not become a significant energy source until the end of the 19th century. Petroleum was discovered in the US in 1850, but it wasn't widely used. The development of petroleum as a major energy source paralleled the development of the internal combustion engine. Liquid fuel engines can be much smaller than solid engines, and so petroleum was in need. Natural gas is often found in the same places as petroleum. It has often been considered non-economical, and 90% of the methane was flared just to burn it off as a waste product. In the 1940s, a network of pipelines were constructed in the United States to take advantage of this gas. The technological man of the 1970s in the US consumed about 230,000 calories of energy per day, or 115 times that of primitive man. Now let's talk about where we are today. Of course, industrial nations differ from non-industrial nations, but in developed nations, our energy goes towards four main purposes: transportation, industrial processes, heating and cooling of buildings, and the generation of electricity. And you can see from this chart where most of that energy is coming from. Oil, natural gas, and coal provide almost all the energy that we are using. Now let's talk about our energy future. We must consider alternative sources of energy that are renewable. And this is the reason why. Fossil fuels are non-renewable. Now, estimates vary widely, but the math is pretty simple. If you're using something faster than you're replacing it, eventually you're going to run out. You can see here that they're predicting 50 years for natural gas and oil and 100 years for coal. From this pie chart, you can see that about 88% of the U.S. energy still comes from non-renewables. Looking at the renewables alone in the bar chart to the right, you can see that hydroelectric and biomass provide the lion's share. Wind and solar provide just over a quarter of the U.S. renewable energy and are steadily increasing in importance. Solar now provides about 6% of the total U.S. renewable energy, while wind provides about 21%. So now let's move on and talk about solar energy. I'd like to discuss the other main use sources, but we'll start with the sun. We can use the sun to produce thermal energy or electricity. Solar voltaic panels produce electricity, while solar thermal systems produce heat. Solar energy can be used very easily to heat buildings and water. It can be quite simple. In a typical passive solar heater, the sun enters through the window from windows facing the sun. Convection currents distribute the heat around the building. Some of the heat is stored in the building, which is released when the sun goes down. In an active solar heating system, water circulates through flat plate collectors on the roof and is heated by the sun and conveyed to a storage tank, which then can be used to heat the house. We have larger solar systems too. This is a picture of a solar thermal plant. And here, heat can be collected and used to generate electricity. There are several different models of this sort of thing, but the sun hits off that reflective surface and heats a fluid in this tube, which then can be used to generate steam, which can be used to generate electricity. Heliostats are used in a circular array of moving mirrors to concentrate the sunlight on a central receiver mounted on a tower in this sort of thermal power plant. Some use pumps of molten nitrate salts as heat transfer media to the central receiver. The salt is heated to about 550 degrees Celsius and again is used to generate steam, which turns a turbine to generate electricity. Some of the plants are quite large. Here's a picture of a plant in Spain. that is about 50 megawatt solar power. The Ivanpah solar power plant in California is 377 megawatts. Photovoltaic cells could be used to generate electricity. Most of these solar cells consist of 2 layers of pure silicon. One has trace levels of arsenic. Arsenic has an extra electron and therefore will be negative, considered to be an N-type. The other layer has trace amounts of gallium. This area is electron poor or positive, considered to be P-type. The extra electron from the arsenic is free to move. Once all the holes are filled, the flow of electrons ceases. If the mobile electrons are energized by exposure to sunlight, the layers are connected by an external circuit, then you can get a current. There are large photovoltaic power plants. This is one of the largest 1,000 megawatt plants. So we have both solar thermal and solar voltaic power plants that are beginning to pop up. There are lots of advantages of solar energy. The sun is free, nobody owns it. In principle, the amount of solar energy that reaches the Earth's surface could provide all the human energy needs forever. There are some disadvantages, however, that tend to take up a large amount of surface area. Another renewable energy source is biomass. Biomass is defined as any accumulation of biological material that can be used as a source of energy. You can burn the wood directly and use the energy, or there are also several other routes available for biomass conversion into biofuels. Biomass is considered to be carbon neutral because, unlike with fossil fuels, the CO2 that is released from combustion was recently in the atmosphere. Domestic heating with wood is still by far the largest market for bioenergy. There have been dramatic improvements in technology in domestic heating equipment. Improved tile stoves, advanced logwood boilers, wood chip boilers, pellets, and pellet stoves. There's also portable wood-based fuel now available. Stoves that burn wood are a classic example. In fact, there has been a 20 to 25% increase in the use of wood stoves over the past several decades. Plants, organic waste, manure, and other forms of biomass can be used as sources of methane. The process is called bioconversion. In India, Nepal, Pakistan, and Bangladesh, biogas produced from anaerobic digestion of manure in small-scale digester facilities called gobar gas is estimated to be in as many as 2 million households. The digester is an airtight circular pit made of concrete with a pipe connection. The manure is directed into the pit. The gas pipe is connected to the kitchen fireplace through controlled valves. The combustion of biogas has very little odor or smoke. Owing to simplicity in implementation and use of cheap raw materials in villages, it is one of the most environmentally sound energy sources for rural needs. A biorefinery is a facility that integrates biomass conversion processes and equipment to produce fuels, power, and chemicals from biomass. These are analogous to today's petroleum refineries, and we can have a sugar platform or a thermal platform. The sugar platform uses the sugars to produce, through a process called fermentation, they produce ethanol. And the thermal chemical processes can produce combustible gases and chemicals that can be used to make other fuels. Ethanol fuel is a biofuel alternative to gasoline, which is gaining popularity worldwide. Car engines can be designed to run on 10, 50, or even 100% pure ethanol. It is cleaner burning than gasoline, and worldwide the use of ethanol is rapidly increasing. In Brazil, ethanol-powered And flexible fuel vehicles are manufactured to be capable of burning hydrated ethanol, which is an azeotrope that's 93% ethanol and 7% water. Ethanol fuel is produced from sugarcane in Brazil. The oils and fats are the product of the reaction between long-chain carboxylic acids and alcohol to form esters. These triglycerides are triesters formed by the reaction of 3 fatty acid molecules with glycerin, and these can produce a bio-oil. The thermochemical platform, where we take biomass and do pyrolysis, what you do is you heat up the biomass without oxygen and decompose it into its vapors, aerosols, and a char. The bio-oil is the liquid that is collected. The gas, or producer's gas, or synthesis gas, can be comprised of hydrogen and carbon monoxide, which can be used to produce methanol, or the synthesis gas, which can be further converted into a hydrocarbon fuel through the Fischer-Tropsch process. Man has been harnessing wind power to do useful work for centuries. A modern wind turbine consists of blades mounted on a tower. Wind speed is higher above the Earth's surface, so the towers are raised. As the blades turn, electricity is generated. The amount of power, and therefore electricity, a wind turbine can produce is largely based on the velocity of this equation, using this equation here. If you double the wind speed, since the term is cubed, you get an 8-fold increase in power. As you can see, the wind turbine area is also a factor. So the wind turbines are getting bigger and bigger. It wasn't too long ago that a large wind turbine was 50 kilowatts. Today they are producing some that are over 10, I believe 12.5 megawatts of power. These things are enormous. Here they are installing one of the larger wind turbines. You can see the relative size, this person climbing to the top. We have somebody standing on top of these wind turbines. So they can be 220 meters high. The turbine diameter is another 140 meters. So they are enormous. Wind farms are getting bigger and bigger. The largest is now 8 gigawatts, with plans to go even larger. Wind is free, commonly available, and can provide clean, pollution-free energy. The capacity is growing quickly. You can see here that in 1995, 6.1 gigawatts capacity, and then by 2016, it was almost a 100-fold increase. There is some limitations. It would take about 1 million watt windmills to equal the energy output of one sizable fossil fuel power plant. Windmills are said to be noisy, and they can interrupt migrating birds, so there are some limitations. Geothermal energy is heat energy that is generated deep within the Earth's interior by the decay of radioactive elements. Geothermal energy is abundant, but like solar, it's widely dispersed. It becomes accessible in only certain unstable regions of the world where, as a result of geological activity, magma rises from the depths to near the Earth's surface. Magma rising from the mantle brings unusually hot material near the surface. Heat from the magma, in turn, heats any groundwater, and this is the basis of geothermal energy. You can see that worldwide there's about 40 geothermal power plants, and most are located along the plate tectonic boundaries. So you can see that in Iceland and on the west coast of the United States, there are places that are good for geothermal energy. There are 3 types of geothermal power plants. One is considered to be a dry stream plant, which takes steam out of the ground and uses that steam to turn a turbine. This was first done in Italy in 1904. Iceland is a volcanic island and has many geothermal energy sources, and they generate nearly 100% of their electricity from renewable sources. The second type of plant is a flash plant that takes superheated water, usually temperatures above 200 from the ground. As it rises, the pressure decreases and allows the water to boil and generate a gas, which can then turn a turbine and produce electricity. In binary plants, the hot water flows through heat exchangers, where you can boil an organic fluid, which as it becomes a gas expands and again will turn a turbine. For all these types of power plants, you have to return the hot water back to the into the surface to keep the power plant running smoothly. The geysers in California is one of the largest geothermal power plants in the world, and by the late 1900s, it had produced over 10 billion watts. This is a picture of a power plant, geothermal power plant in Iceland, and you can see the effluent of the plant makes a nice warm lagoon. Each geothermal field can only be used for a period of time for about a few decades before heat extraction is seriously reduced. Simply put, you can't take hot water out of the ground faster than it can be renewed, even if you pump the water back into the ground. For example, the steam pressure at geysers, the large California power plant, has reduced rapidly. It peaked out at over 2 billion watts in 1991, but has recently been as low as 0.7 billion watts. Advantages of geothermal energy are that it's very high efficiency, it's moderate net energy, low CO2 emissions, doesn't take up much land use, pretty good on the environment. Some disadvantages are that it's scarce. You have to have certain geologic events occurring. You can deplete it rapidly if you're not doing it correctly. It can have some bad smells because along with the warm water often will come some sulfur-containing compounds. And the cost can be high to get started. But overall, if you have geothermal energy available, it is a good alternative source of energy. The queen mother of all renewable energy is water power. In the United States, 1/3 or 33% of all power plants are hydroelectric, but they only generate about 6% of the US energy needs. A cross-section of a typical hydroelectric dam can be seen here. Water flows down the penstock, turns the turbine blades, which generate electricity. And if you dam up the water, you have a high column of water, you can generate more power. Hydropower is very clean, pollution-free, renewable energy source. The water is not consumed, but simply passes through the generating equipment, and since several dams can occur along the same river, the water can be reused and reused. If every stream and river in America was dammed to generate power, we'd still only provide about 20% of our current US power needs. There are about 1,000 dams in the US, but there's very little prospect of building any new ones. In fact, some of the older dams have been removed to try to restore the original condition. The Three Gorges Dam in China is now the world's largest hydroelectric dam. The Chinese began filling the reservoir in 2003. When filled to capacity, the reservoir will hold about 22 cubic kilometers of water. And with any engineering project of this great of magnitude, there have been some serious problems. The reservoir stretches over 600 kilometers. It submerged 125,000 acres of prime farmland, and several million people were forced to relocate, many against their wills. Entire cities were abandoned, and over 120 historic sites were flooded. 3 spectacular river gorges were submerged and are no longer above water and can be visited. All large bodies of water, including the oceans and large lakes, have tides, and tidal power captures the energy, can either be kinetic or potential, contained in the moving water mass due to these tides. So we can take the kinetic energy from the ebbing and surging tides and the potential energy from the difference in height between the high and the low tides. You can see here the water flowing between the high and low tides can generate electricity similar to hydropower. As the tide rises, the water flows in. You can turn the turbine one direction. When the tide is out, the water can flow back to the bay again turning a turbine. These turbines can be placed on ocean floors, for example, at the entrance of a bay, where the flowing water can turn the fan to generate electricity. Another option is to use underwater turbines, which is like an underwater wind farm. This is currently being tested in Scotland. The ebbing and surging tidal flow turns 100-foot propellers, which can each produce 1 megawatt of electricity. Well, in conclusion, I'd just like to say that the transition of energy from conventional fossil fuels to cleaner renewables will take decades. And natural gas and coal will survive for years. The electrical grid must change to carry the renewable energy from the resource where it was being produced to the load centers, which will be the cities. Rechargeable vehicles, which are clean as the utility source, will shift from coal to renewables due to politics, ideology, and good practices. Wind power has been growing and looks like it will continue to grow 30 to 40% per year. As the turbines become more widespread, the pushback against them has begun to fade. Solar energy is growing more cost-effective. Geothermal heat pumps are operating with greater efficiency. Biofuels are being developed at the commercial level. Hydroelectric systems will continue to provide low-cost, clean energy for years to come. Ocean tidal waves and current energy are being developed for coastal regions. Distributed energy from rooftop solar reduces the need for transmission installation lines. So humans must have air, water, food, and energy to survive. And fossil fuel pollution is known to increase the greenhouse effect, which is believed to cause global warming. Renewable energy offers a long-term sustainable approach to our world's energy need. So that's all. Thank you for your time and attention.
We listened to the very interesting presentation by Professor Todd Lesnar. Although he is not present with us here, it was a very valuable speech because of this is about the alternatives for the fossil fuels. That is something very important to everybody in the world. So we also are very interested, as we are also in the research program we are having last 10 years about biofuels. So we thank Professor Lesna, and although he is not present with us here, we like to award this token of appreciation to him, and in due course we will send this to him with thanks. And so.
Next week.
Okay, now we are going to start with the technical sessions. Before starting, we have shortly we have to read the safety guidelines. Presenters, just go through it quickly. Presenters are only allowed to sit at the allocated stations. Masks are mandatory to wear at all times. Presenters allowed to remove their mask when presenting. If you are removing your mask, we advise you to remove it completely after each presentation. The surface, including podium, microphone, and the pointer, will be disinfected. Instructions during the presentations. Each talk is designed for 15 minutes. Therefore, each presenter is allowed 12 to 13 minutes for their presentation, where 2 to 3 minutes question and answer is done at the end, for a total of 15 minutes. In the presentation, the maximum time allocation is 13 minutes. The first bell will ring once at 10 minutes. The second bell will ring twice at 13 minutes. Right, these are the things to mention. So we will start with the presentations. The first presentation, polythene degradation capability of Xylophyllum commune. Presenting author PWNK Derrida.
Good afternoon, dear sir, madam. I am PWNK Pereira. Our research topic is polythene degradation capability of Schizophyllum commune. As we know, the use of polythene in today's world is inevitable, and life without polythene is unimaginable. According to our current knowledge, there are two basic types in polyethylene, as high-density polyethylene and low-density polyethylene. Both are long-chain polymers of ethylene and widely used in the packaging industry. Manufacture, consumption, and accumulation of polythene lead to numerous environmental, economical, and ecological concerns. If we consider about the waste for the polythene management, one comes as incineration. But polythene cannot be incinerated like other waste because in burning polythene, it releases many carcinogenic and toxic substances which cause disastrous effects to the animals, plants, humans, and nature. Recycling is another option, but it is also laborious and expensive. When incineration is harmful and recycling is tedious, biodegradation is the best option for the elimination of polythene from the contaminated environment. What is biodegradation? It is an important approach for waste reduction which relies on biological processes to break down the pollutants. This has been made possible due to the vast metabolic diversity in the microbial world. During this process, microorganisms facilitate this process by secreting enzymes responsible for the breaking down of larger polymers into their subunits. Although there are several bacterial studies in this regard, this is the first comprehensive research on using endolycanic fungi to address this issue. Lichens are a stable mutualism between a photosynthesizing partner and a fungal partner. In addition to the fungal partnering the mutualism, lichens are closely associated with endolycanic fungi which resides inside their thalate. These endolycanic fungi also have been evolved along with the lichens, and Physophilum commune is an example for unsought endolycanic fungi. This is the objective of this study, is to identify the polythene degradation capability of various endolycanic fungi in the liquid media. Here, this is our experimental design. Now let's move to materials and methods. First, pure endolycanic fungal cultures bounced in sterile water were obtained, and in obtaining actively growing fungal isolates out of them, first glassware should be sterilized, PDA medium was prepared, solidified PDA medium was inoculated with these endolycanic fungal cultures, and whole set of plates incubated. In obtaining sterile LDPE strips for further analysis, first commercially available LDPE bags were cut into strips with proper dimensions. They were surface sterilized with ethanol, washed with distilled water, and were dried. In order to identify the ability of various endolycanic fungi to degrade polythene in liquid medium, a liquid medium screening assay was performed. This is the medium composition of mineral salt medium broth which was utilized for this particular assay. Here, 100 milliliters of mineral salt medium broth was added into 250 milliliter Erlenmeyer flask and whole setup was autoclaved. Sterile LDPE strips were added into each 100 milliliters of mineral salt medium broth. PDA plugs of fully grown endolycanic fungal cultures were inoculated into each 100 milliliters of mineral salt medium broth, and as the control, mineral salt medium broth flask without tailor plug fungus was utilized. And then whole set of flasks were shake incubated at room temperature for 21 days. And after incubation, LDPE strips were taken out and they were undertaken for the cleaning procedures prior further tests to check whether these LDPE strips are degraded. Then we are moving for a set of tests to check the degradation of this particular LDPE strips. First one is the calculation of percentage weight loss. Here, LDPE strips were washed with 2% sodium dodecyl sulfate to remove unciliary debris. They were washed with distilled water, were dried and weighed in order to calculate the percentage weight lost. ATR-FT-IR spectroscopy is another test to check the degradation of these LDPE strips. There we study the differences in the functional groups of surface sterilized polyethylene and polyethylene inoculated with this endolycanic fungal cultures. There, the strips were placed on the sample holder plates and percentages of IR transmittance through these samples were evaluated. Hence, a comparative study was made between the controls and degraded samples by comparing the signatures corresponding to the functional group. SEM analysis is another test to check the degradation of these LDPE strips. There we observe the absorption of LDPE onto the hyphae of degrading fungal culture. Their specimens
that means LDP strips along with the fungal cultures, were collected after initial liquid medium screening assays, and these specimens were fixed using glutaraldehyde, dehydrated in a series of ethanol, and final desiccation was accomplished by critical point drug. Then these specimens were sputter coated with gold particles, and gold coated specimens were placed on the microscopic stage to be visualized by the cell. Tensile strength analysis is another test to check the degradation of this LDPE state. The reduction of the tensile strain after initial liquid medium screening assay was identified using universal testing machines. According to the major findings of this study, this test series was carried out for 40 endolycanic fungus, and Schizophilum commune showed some interesting results. So it appeared in this manner in the PDA plates, and in the liquid medium assay, in mineral soil medium broth class, it appeared in this manner. According to the calculation of percentage weight loss, control sample showed a 0% weight loss, while Schizophilum commune treated strips showed a weight loss percentage of 10.54%. According to the ATR-FTIR spectroscopic analysis, control samples showed 4 prominent peaks. And in the treated sample, here treated spectrum is indicated in red color. There we can see fluctuations in the existing peaks as well as formation of several new peaks, especially at 1740 per centimeter, in correspondence to the formation of ester carbonyl forming ketones, and two other peaks at 1215 per centimeter and 1046 per centimeter, in correspondence to the CO stretch of functional groups like primary and secondary alcohols, carboxylic acid, esters, and ethers, which are considered as intermediate products in this particular degradation. These are the SEM analysis results. So the control sample SEM images appeared in this manner, while in treated samples, in the same images, there were pits, cavities, and certain unevenly scattered white areas, indicating the possible erosions during the degradation process. According to the tensile strength readings also, the reduction of tensile strain at break of the test sample, it was reduced by 27.41% in comparison to that of the control. Here, the conclusion is Schizophilum commune shows polythene biodegradation capability in the liquid medium. This slide shows how my topic could contribute in science and practice. Persistence of polythene introduced into the environment poses a major threat to the natural environment. This is the first comprehensive research on determining the ability of various endolycanic fungi for the degradation of polythene substrates. And this would act as a baseline studies on polythene degradation using endolycanic fungi. Here this is suggested future work. I hope to develop a commercially available product out of this Schizophilum commune, which could be applied for real-world polythene contaminated water bodies. These are my references. And I make this the time to acknowledge my financial assistance. I carry out the research granted by Ministry of Science, Technology and Research. Thank you.
It's a very research, and I hope you can have questions So we have little time for that. How did you select this micro to be active for degradation of quality?
Actually, I'm trying this fungus. I'm carrying, I'm just now also I'm carrying out this series, and out of 40 isolates I have tested, this showed those interesting results. I mean, they showed deviations of those peaks in ADR, FTIR spectroscopy, same analysis, fungal species did not show some sort of interesting results. That means they just appeared in the same manner as the controllers. So, based on those 4 tests, that means weight loss, tensile strength analysis, ATR, FTIR spectroscopy, and scanning electron microscopic images, as this one was showed deviations from the control samples in all 4 tests. I concluded that it could degrade. As the capability of degradation even up to a little extent, maybe I'm still carrying out those tests.
Are there any previous studies using such?
Yes, sir. Yes, there are previous studies using bacteria and certain other fungi, but this is the first comprehensive research of using endolycanic fungi to address this quality biodegradation.
One more thing, that have you isolated to identify the degradation process? What is degraded?
Okay, so according to literature, intermediate products, as intermediate products, there should be carboxylic acids, alcohols, esters, and as the final product, carbon dioxide and water. But I haven't identified those degraded products.
Any other questions? Are there any questions?
Economically, is this viable method?
Yeah, finally, this is not the last outcome. I hope to develop a product out of this fungal spores to be applied for the currently contaminated water bodies. So I think this would be more economical than recycling or incinerating the polythene products. Sort of a biodegradation application of fungus to degrade the polythene.
To add to the answer, that what we are planning is to have like develop as a powder or something like that. So when we have this garbage storage places, we can spread, put it there, and we have to do that. We have to do one of field trials and develop a suitable formulation and develop that. Because it is a fungi, we have to make sure that it is not pathogenic. It's not pathogenic, we know that. But we have to develop a product that like a powder and should be able to keep that in the at the room temperature. That's something like that.
As no more questions are there, we thank the speaker. I want to announce that all the speakers will be given a certificate for their presentations, and that will be awarded at the end. So please remain here until the session is over. The next presentation, determination of water quality and suitability in the chronic kidney disease of unknown etiology, CKDU, prevalence areas. pointer is W/48.
I'm Shamila Gupta from University of Canada. This investigation was conducted to determine the water quality and suitability in a CKD prevalence area in Sri Lanka. This is the outline of this presentation. Let's move on to the introduction part. When kidney disease is occurring in the absence of recognized cases such as severe hypertension, diabetes mellitus, or snake bite syndrome, etc., is called as chronic kidney disease of unknown etiology, or CKDU according to WHO guidelines, and it is a major public health problem, mainly in North Central region in Sri Lanka, as the rapid spread of the disease and due to the absence of clear evidence to determine the positive factors, it is receiving a global attention. And it can be arise from direct digestion of toxins due to careless handling of agrochemicals, and pollutants and toxins ingested from food, as well as the prolonged exposure to toxins and pollutants from drinking water. In this study, drinking water is considered drinking water quality is a basic importance for human physiology, and about 80% of all the diseases in human beings are caused by water. And therefore, the assessment of water quality is very important for knowing its suitability for various purposes. In this study, chemical content, water hardness, fluoride concentrations, and other selected anions, basic physicochemical parameters, as well as the water quality index system calculated for chronic kidney disease of unknown etiology prevalence areas. And considering the risk factors, heavy metals are one of the most important factors, and they have ability to bioaccumulate and high toxicity, and the chemical form of the heavy metal, the dose and the concentration, and intermetal and other chemical interactions are mainly causing the chronic kidney diseases. And considering the fluoride, the kidney functions mainly, glomerular filtration rate is very sensitive to fluoride exposure, as well as the ingestion of high fluoride via drinking water can increase the kidney damages. And simply the water hardness is the dissolved calcium and magnesium concentrations in water, and it can the long-term exposure consumption of hard water can cause kidney dysfunction, which restricts sufficient water uptake, and it affects physiologically biochemical and nutritional requirements of the kidney. And considering the water quality index, it provides a single number that expresses the overall water quality at a certain location and time based on several water quality parameters, and it indicates the quality of water in terms of index number. And considering the objective of this presentation, it is to investigate the water quality and the suitability of drinking water in Girard Kotte division, which is a CKD prevalence area, to determine its the quality of the suitability of the water for human consumption. Girard Kotte division was selected as the prevalence site, as well as the Gandhar division in Nambur district was selected as the reference site as no CKD patients. And 30 drinking water samples are collected from drinking water wells, prevalence and reference areas. GPS coordinates were recorded for all sample locations, and duplicates from these samples were used for the chemical analysis.
There are two set of purity mode samples were collected. One of them was acidified and other was not. All the chemical analyses were done at the CPD Information and Research Center in University of California. On-site parameters including pH, dissolved oxygen, electrical conductivity, and chloride concentrations were analyzed. And the acidified water samples were filtered, and calcium, magnesium, cadmium, chromium, lead, and arsenic concentrations were analyzed using inductive Hubble plasma mass spectrometry. And the non-acidified samples were used to analyze the anion concentrations of the samples, and they were filtered, and chloride, nitrate, and sulfate were analyzed using ion chromatography. And the total hardness values were calculated based on calcium and magnesium contents of the samples. And the water quality index were calculated based on the following equations, and the status of water quality were based on the WPI status. And the statistical analysis were done using ETAP 17 software. Spatial distribution patterns were analyzed using IDW tool and Moran's index tool in ArcMap GIS software. Thanks. The table 3 shows the descriptive data of the main physicochemical parameters and selected chemical parameters. And according to the results, dissolved oxygen concentrations was in the report there. Dissolved oxygen content was lower than the standard limits, and electrical conductivity and magnesium concentrations were exceed the maximum permissible levels. And this is the descriptive results of selected anions of drinking water samples in the unrecorded ground division. And this figure 2 shows the spatial distribution of fluoride in the unrecorded ground division, and it ranged from 0.244 to 5.74 ppm levels, while most of the values in sampling points were exceeded the maximum permissible limits. And this figure shows the cadmium content in the ground report, spatial distribution of cadmium in the ground reported ground division, where the mean cadmium level of the collected water samples was 0.124 ppm, and the cadmium concentration values in all the sampling points were complied with maximum permissible limits. And this is the spatial distribution map for the chromium. And it was ranged from 20.79 to 103 ppb level, and most of the values in sampling points were exceeded maximum permissible limits. And this is figure 5 shows the distribution of lead in the unrecorded ground division. In here, the concentration values in all sampling points were complied with SLS standard limits. This is the spatial distribution map of arsenic. And considering the mean water hardness contents, the reference site in Iran report shows the 83.6 and 30.58 ppm levels, while the other report shows the moderately hard water, and the reference site shows the soft water. This table shows the values of the various physicochemical parameters for calculating, which is used for calculation WQI. And this is the water quality index values for the unreported ground division and for the reference site. According to the analysis of qualitative drinking water using physicochemical parameters in the unreported and reference site, the unreported shows the poor water quality, and the reference site shows the good water quality index. And seasonal rainfall, excessive evaporation, meteorological composition and aquifer materials, and reactions that occur in the flow systems may control the geochemical composition of groundwater, and dissolved magnesium, calcium ions can get into the water when it comes into contact with limestone and other rocks that contain calcium and magnesium compounds. And water in Kinagapur was considerably ionized, maybe due to presence of inorganic dissolved solids, and the high water quality values in city prevalence site may be due to the increasing pollution as the discharge of anthropogenic waste. And these are the conclusion of this presentation. Mean fluoride content in the city prevalence area was exceeded the maximum permissible levels, and the electrical conductivity in the Randrapur was beyond the maximum permissible level, and mean chromium and arsenic concentrations exceeded the maximum permissible level, and total water hardness values indicated moderate and hard water, and the quality of water in sampling site in terms of index number is poor for drinking purpose. And it can be concluded that high concentrations of fluoride, water hardness, and long-term exposure to heavy metals can lead to the occurrence of CKD prevalence. And utilization of treated water and introducing suitable household level water filters can be recommended as preventive measures of CKD in the study area. And these findings can be used as a benchmark for the water supply design process in CKD. Affected areas can be. These are the references of this study. And thank you.
Now the session is open for few questions. Okay, now as indicated, how the fluoride level were above the permissible levels, and the arsenic and cadmium were above it. So what are the explanations? Now the fluoride is reaching that those areas, that's we know, but arsenic and cadmium, what can be the source? Like a mineral, geological source, or any other protein other than the human input?
Actually, in the drinking water, it can be said that the geological composition of the solid, as well as we can say that the chemicals also somewhat related for their and the evaporation of the water in dry season, dry zone also affected this.
Is there any special reason for selecting that particular Raman-Niladhari division or randomly selected?
No, actually, we selected this Raman-Niladhari division according to the reports of the health ministry, as there are CKD patients are highly in that Raman-Niladhari division.
Let us thank the speaker in the usual manner. The next presentation is sodium alginate gel beads with slow release fertilizer from seaweeds and biostimulants of paddy growth. The presenter is M. Vadivel.
It's online. It's an online.
Mr. Vadivel, you can start now.
Hello, good morning, everyone.
Mr. Manu, can you share your slides, please? Mr. Arun, you can proceed now.
Good afternoon, everyone. First of all, I'm thanks to Institute of Chemistry, Ceylon, accept my in my work sodium alginate gel beds with slow release fertilizer from seaweeds and biostimulations of paddy growth. Introduction. The agriculture sectors play an important role in the economic development of developing countries. In India as well as globe, the sectors hold a dominant position in the economy. Today's farmers use synthetic fertilizer and pesticides massively to meet the growing demand for food. Although such supplements have helped many developing countries to boost crop yields, many issues can rise at the same time. The use of synthetic fertilizer has not only raising the cost of food production, but also decreased soil fertility and depletion. Its long-term effect of manure and fertilizers on the earth. It's ultimately calls for the optimization of the use of existing farmland by adopting a new plan of agriculture development. So we go to the organic fertilizer. Organic fertilizer means the biofertilizer are one of the alternatives that are eco-friendly, cost-effective, and improve soil quality without degrading the ecosystem. But in our study, organic algae fertilizer considered as a potential alternative to conventional synthetic fertilizer among the various available fertilizer, as they are rich in macronutrients and micronutrients. It also been identically used to organic manners. But our choices, we have millions of algae, but our choices here Sargassum vittae. A Sargassum vittae are nutrient dense and commonly used as a fertilizer and fruit, while phytochemical extract exhibit unusual bioabsorption and medicinal properties. This nutrients dense macroalgae is rich in minerals, water soluble polysaccharides, and phenolic compounds that collectively boost soil health, efficiency, productivity, and enzyme activity. Numerous studies have supported the use of marine resources as a biosorbents for the removal of heavy metals because they are plentiful, sustainable, and environmental friendly in terms of disposal at the end of their life cycle. Algal biomass, Cretaceous cells resource from agriculture waste represents alternative materials that can be used for metal sorption or biosorption by comparing the sorption potential of non-chemically modified white, red, and brown algae to lead and copper absorption. Brown algae tend to have the highest sorption efficiency, 5 to 283 milligram for lead and 51 to 106 milligram for copper 2. This is the higher removal efficiency is partly explained by the presence of alginate, anion polysaccharide as one of the major components of brown algae. Several studies have confirmed the high affinity for heavy metals due to high content of carboxylic acid groups. The use of hydrogels as a medium for slow controlled release of fertilizer is now becoming increasingly popular, suggesting that there is a positive trend towards the lifting of possible application in practical agriculture. The major biodegradable materials commonly used as alginate. among the main source of hydrogel production for slow control release fertilizer holders. Nowadays, the fisherman life is very difficult. Algae production is a life step for supporting technique for fishermen, as well as farmer to use low cost, eco-friendly, sustainable fertilizer. Methodology. Preparation of seaweeds. In these experiments, brown seaweeds collected from Gulf of Mannar area in our college nearby seashore area, Kilakare seashore, Tamil Nadu, India. These are hand-picked and washed very well with seawater to strip off all unwanted impurities, sand particle, epiphytes, and so on. It is sealed in a bag and transported to the laboratory. In the laboratory, the collected algae were again treated with clean tap water to remove the surface salt. The fresh seaweed collected was dried in sunlight for up to 3 days and grinded to form a powder. The chorus powder was blended with distilled water at the ratio of 1:20, then boiled for 40 minutes and filtered to use the further study. Preparation of gel buds. 2 grams of alginate and 5 to 20% of clay, Montmartre clay or kaolin clay, was dissolved in 20 ml of water under ultrasonication for 20 minutes. The gel was taken in the 5 ml syringe with a drop-wise addition of 50 ml of 1 gram of cupric chloride or zinc chloride or ferric chloride or zinc chloride or calcium chloride solution, depending upon the soil deficiency. Sometimes our cultivation land, zinc is very low deficiency, we add zinc chloride. Iron is very low in soil condition, we add ferric chloride condition. That is the marine seaweeds to form a polymer coated marine seaweed nutrients. Then the polymer gel buds put into the soil, the growth of plants. This is the normal fertilizer, then fast, slow release fertilizer, then fast release fertilizer, comparison of those. Characterization of gel buds. All the above prepared gel buds with characterized by atomic absorption spectroscopy and FTIR. NPK, nitrogen, phosphorus, potassium releasing of the gel buds are recorded by atomic absorption spectrometer and UV spectrophotometer. Then SEM. The SEM microscope sample were analyzed using scanning electron microscope. Then swelling studies. The gel buds were dipped in phosphate buffer, saline buffer solution, pH 7.4 at 37 degrees Celsius. The procedure was followed by the reported procedure. Then growth parameters. Seeding length of Voracious sativa as shown on 30 days and 60 days expectedly. Yield will be calculated. Research and discussion. FTIR spectra. The figure 1 shows the alginate. They confirm the alginate, sodium alginate and its characteristic in the 3600 to 1600 centimeter measure. Region 3 bands appeared. One is 3267 assigned to hydrogen bond OH stretching vibration in the weak signal at 2914 centimeters due to CH stretching vibration. This shows these bonds. The following confirmation for alginate. Then SEM and EDAX analysis. The SEM image of freeze-throwing process of Sargassum Vitti loaded alginate clay hydrogel beads. The beads are shown in figure. The image revealed that the smooth surface of hydrogel beads was changed into porous surface. It clearly indicates that consequently it is exerted that the freeze-throwing process can enhance the swelling ratio of Sargassum Vitti loaded alginate clay hydrogel beads as per our expectation. In further confirmation, intactly coupled plasma optical emission spectroscopy, Sargassum Vitti seaweed extract was analyzed optical emission spectroscopy. Results show that the product contained percentage of phosphorus. There's a phosphorus 213.618 nanometer. The concentration was shows that 2.10 ppm and potassium shows that 74.52 ppm compared to another seaweed extract, Padina provenica seaweed results. These are the coupled plasma resonance spectroscopy results. These are plant study used soil the soil contains the phosphorus, the following phosphorus concentration. Then the seaweed extracts. The seaweed extracts the phosphorus intensity is minus 4.18 intensity. The following ppm was occurred. Next ones. This is the potassium calibration curve of intensity plasma resonance spectroscopy result. Then potassium result. Then further copper, iron, magnesium, manganese, zinc also present in the sargassum witty seawards. So sometimes micronutrients imbalance in some area soil. We utilize the sargassum witty seaweeds fertilizer in the following area. Next, and our next study is here plant growth studies. We observed the plant studies. We used different percentage of sargassum witty. Extract used different weight percentage, 1%, 1 and 2 and 3 and 4 and 5%. The result shows that 3 weight percentage used plant height is a high compared to other. That is the pure. That another one, the height is very high, to 7 centimeter. Then next one is a 4, dramatically decreased due to excess of alkalinity seaweeds. The growth also disturbed in the plant studies. So optimized we use of 3 gram is better used in the fertilizer. Conclusion: the calcium crash-linked alginate or iron, zinc, etc. Crash-linked alginate clay hydrogel beads were prepared by simple gelation method and calcium chloride solution to use as a crash-linking agent. Sometimes we used zinc chloride, iron chloride, etc. The sargassum witty loaded hydrogel beads was successfully loaded on the alginate clay hydrogel beads. The prepared calcium or zinc crash-linked alginate clay gel hydrogel beads and its algae loaded beads are well characterizing FTR SM and TGA, but not in TGA. In our college also closed due to COVID-19 pandemic disease, so not so in the TGA results. This cheap, non-toxic and biodegradable sargassum witty loaded crash-linked alginate clay hydrogel bead shows better controlled fertilizer releasing efficiency in soil medium. Observed the plant study, we used different percentage of sargassum witty extracts, the different weight percentage, but the result shows that 3 weight percentage used plant height is compared to other. The yield study is also going on in my results. The following reference for use in this presentation. Thank you. Any questions? Hello?
Thank you.
Hello?
So again, thank you very much.
So if you have any question?
Here now we come to the last presentation of this session. The title: Antioxidant, Anti-Inflammatory, and Antibacterial Potentials of aqueous leaf extract of Poateria campectinia. These two Rakala Ulu represented by OIHTRH.
Please, you can share your screen now. Ma'am, you can share your screen now. Ma'am, we can't hear you. See the screen.
1 minute, please.
Can you share the screen?
Yes. May I start? Can you hear me?
Ma'am, you can enable editing and then you can do the slideshow.
Good evening. I am here to present my research on antioxidant, anti-inflammatory.
Excuse me, Elise, we can't see the slideshow. We can see your screen, but not the slideshow. Can you enable editing? It's on the top below the menu bar. You should share the screen again.
Can you see now?
Yes, I can see, but I can't see the slideshow. So you need to enable editing.
But there's a message that I'm sharing my screen.
Yes, you are sharing the screen. You need to enable editing in PowerPoint. Reshare the screen, please.
Can you see now?
You can't see anything. Right now, we can see.
Can I start now?
We can't hear your voice. Excuse me, ma'am, we can't hear your voice. We can see the screen, but we can't hear your voice.
Good evening. I am here to present my research on antioxidant, anti-inflammatory and antibacterial activities of leaf of Puteria campesiana kunthbemi, commonly known as Ratalaulu. Introduction. Plant sources have been used in folklore medicine as well as in the traditional Ayurvedic system of medicine. Plants are the main source of vitamin E, C, and phenolic compounds, which are effective free radical scavengers. Free radicals are naturally present in the human body, but excess amounts of free radicals cause tissue damage, cell death, and oxidative stress. Therefore, antioxidant mechanism plays a key role in the living system. Inflammation is non-specific defensive system in the body. When tissue cells are damaged, they release chemical agents such as kinin, histamines, which starts the inflammation. Antimicrobial resistance is a major threat in health industry. Therefore, search of novel plant-based drugs against microbes has become a timely need. This is the plant I used. It is classified under kingdom Plantae, family Sapotaceae. Objectives of this study is to investigate antioxidant, anti-inflammatory, and activities of aqueous leaf extract of P. campesiana Kunth Behan. Preparation of the sample. Aqueous extract was prepared according to Kasai preparation method as mentioned in reference number 1. Obtained filtrate was subjected to freeze-dried method and samples were stored at -4 Celsius. These samples were subjected to many assays, including estimation of total phenolic content and total flavonoid content, antioxidant assays, anti-inflammatory assays, and antibacterial assay. I'll be discussing methodology along with results and discussion assay by assay. First, estimation of total phenolic and total flavonoid content. Fall-in Ciocalti method. Phenolic compounds are important because hydroxyl groups in aromatic ring confer scavenging ability. This assay was carried out as mentioned in reference number 2 and methodology is briefly explained here. In this assay, phenolic compounds are oxidized to its superoxide ion in basic medium. Pyrogalol was taken as the reference. Initial color of the reaction mixture was yellow and it turned into intense blue as shown here after the addition of the fall-in Ciocalti region. Obtained results are shown absorbance versus concentration graph. Regression equation was used to calculate the total phenolic content of the sample, which was 230.7 plus or minus 7.6 milligrams pyrogalol equivalents per gram of dried sample. Aluminum chloride colorimetric assay. Flavonoids are a common group of phenolic compounds in human diet. They have been shown to be highly effective scavengers for free radicals and singlet oxygen. Assay was carried out as mentioned in reference number 2 and methodology is briefly explained here. In this assay, flavonoids make complexes with aluminum chloride. Major contribution for this assay is catechol meaty present in the ring B of flavonoids. Initial color of the reaction mixture was yellow and it turned into brown as shown here. Obtained results are shown in this graph. Quercetin was used as the standard. Regression equation was used to calculate the total phenolic content of the sample, which was 140.9 plus or minus 98.4 milligrams quercetin equivalents per gram of dried sample. Previous research has shown there's a correlation between antioxidant assays and total phenolic and total flavonoid content. So let's move to antioxidant assays. First, DPPH assay. This assay is based on scavenging of DPPH radical through the addition of a radical species or antioxidants which decolorize the DPPH solution. This assay was carried out as mentioned in reference number 2 and methodology is briefly explained here. The color of the DPPH radical solution is purple and color changes from purple to yellow with increasing concentration of the extract as shown in this image. Scavenging activity percentage was calculated using this equation and obtained results are shown here. According to the results, DPPH scavenging activity percentage increases with the increasing concentration of the sample. So we can suggest our sample contains phytochemical constituents which are capable of donating hydrogen atoms. Next, FRAP assay. Previous reports suggested that the reducing properties exert antioxidant action by donating of hydrogen atom to break the free radical chain. Assay was carried out as mentioned in reference number 2 and methodology is briefly explained here. In this assay, ferric ions are reduced to ferrous ions which reacts with ferric chloride to produce complex as shown here. Obtained results are shown in this graph. These results shows absorbance values increases with the increasing concentration of the sample and higher absorbance values for higher concentrations of the sample. Next, hydroxyl radical scavenging assay. Hydroxyl radicals are the most reactive oxygen-centered species. They could contribute to cytotoxicity and mutagenesis as hydroxyl radicals are capable of damaging macromolecules. This assay also carried out as mentioned in reference number 2 and methodology is briefly explained here. In this assay, radicals are produced by reacting hydrogen peroxide with iron EDTA complex. These hydroxyl radicals attack 2-deoxyribose and dialdehyde fragments which reacts with thiobarbituric acid to produce pink chromogen as shown here. Diminution of pink color is taken as measure of scavenging ability. Scavenging activity percentage was calculated using this equation and obtained results are shown in this graph. This result shows hydroxyl scavenging activity increases with the increasing concentration of the sample. Ascorbic acid was used as the standard. Let's move on to anti-inflammatory assays. Nitric oxide scavenging activity assay. Nitric oxide is a chemical mediator which is generated by endothelial cells and neurons. Excess amounts of nitric oxide results cytotoxic effects such as AIDS, Alzheimer's disease. Oxygen reacts with nitric oxide and produces peroxynitrite anions, which are also a potent oxidant. This assay was carried out as mentioned in reference number 3 and methodology is briefly explained here. Initial color of the reaction mixture is pink as shown here. In this assay, antioxidants competes with oxygen to react with nitric oxide. This inhibits the generation of nitrate ions. So intensity of pink color reduces with the increasing concentration of the extract. Scavenging activity was calculated using this equation and obtained results are shown in this nitric activity percentage versus concentration graph. This result shows a dose-dependent activity. Ascorbic acid was used as the standard. HRBC assay. This assay is used to study in vitro anti-inflammatory activity of plant extract. Erythrocyte membrane is analogous to lysozyme membrane. Stabilization of RBC membrane implies that our plant extract may well stabilize the lysozyme membrane because during an inflammation, lysozyme releases lysozymal constituents which cause various disorders. Assay was carried out as mentioned in reference number 4 and methodology is briefly explained here. Hemolysis percentage and protection percentages were calculated using these equations. And results are shown in this graph. According to the results, protection percentage increases with the increasing concentration of the sample. Here, aspirin was used as the standard. Antibacterial assay. Agar disc diffusion method. This method is used for antimicrobial screening of plant extracts. Research has shown polyphenols and phenolics exhibit antimicrobial activity. Assay was carried out as mentioned in reference number 4 and methodology is briefly explained here. 2 strains were used in this assay. They were Staphylococcus aureus and Escherichia coli. Antimicrobial potency was assessed by the presence or absence of the inhibition zone. These are the results. Staphylococcus aureus gave an inhibition zone with average diameter 1.1 plus or minus 0.3 centimeters, whereas E. coli did not give any inhibition zone. Positive control gave an inhibition zone with average diameter 1.2 plus or minus 0.06 centimeters, which is larger than the inhibition zone given by Staphylococcus aureus. Conclusion of this study is the aqueous extract of P. campechana kunth beni has the potential to be developed as a remedial measure for diseases in which radicals are implicated, as well as in inflammatory conditions and as an antibacterial agent. These are my references. I would like to convey my gratitude to my supervisors, Professor S.A. Dharaniyagala and Professor C.M. Hetty Arachi for their advice and encouragement throughout this study. Thank you.
As there are no questions, we thank the speaker again in the usual manner. Now it is the time for vote of certificate. So I would like to call the speakers. The first speaker, T.W.N.K. Pereira. W.S.M. Boteju. So with that, we wind up the session name. The next session starts at 4 o'clock.
Can you hear?
No, I don't think you can hear that. Please say it.
We can't hear.
Okay. Repeat again, Uday.
Dr. Mohanamira, can you hear us?
Okay. Hello?
Yes, yes, we can hear you.
Yes, let me see how I'm going to share my file. Very good. This is a basics and files. Oh, it's not library. Because let me.
There's a green button at the bottom of the screen.
Yes, I got the screen, but it doesn't say it is in my desktop. I try to see how can get into my desktop. This. Let's see. Screen sharing, it says advanced basics. Not the right word.
Yes, we can see the screen.
Yes, I can see the screen, but let me see how I'm going to get presentation.
Yeah, for that you have to go to share screen. So
Yes,
when you
go
open the
to,
share
go
screen, you will see the presentation there.
share the screen presentation. This is only for all panelists. Okay. I'm trying to get my. Oh, I'm sorry. Let me check. But it did come the desktop sharing in the desktop.
No, you have to open the presentation first. If you open the presentation.
Okay, I see. Let me open the presentation. Okay. Okay. I got the slideshow. Okay.
Yeah, once you open the presentation, then you can click the share button. Then you will see that presentation.
Okay, I open my presentation. Good. And
now you can share. Go to the share button.
Okay, I see. Can you see it?
Yeah, we can see it now.
Super. Thank you. This is the first time. In fact, I am using the Zoom. So we used to use the Microsoft Teams all the time. Anyway, very good afternoon, ladies and gentlemen. Thank you for the invitation, number one. And thank you for the brief introduction also. I am very pleased to see my teachers and colleagues in this forum, who are in this part of the forum actually. And also it is my pleasure to deliver this short presentation on chemical safety and security management for sustainable industrial development. And it is part of the mandate of the OPCW. Right now I am stationed over here. And I'm so glad to see all of you and listen to this presentation. This is what is so-called digitization. So we are in the digital world. And in fact, OPCW also delivering many programs and activities related to the chemical safety and security management using these online platforms. Right. Very sunny afternoon in The Hague. This is our headquarters in the Netherlands. And also, part of our mandate is actually to improve the chemical safety and security management in our member states. Chemical safety and security is one of our primary activities related to the implementation of the Article 11 of the Chemical Weapons Convention, and actually to prevent chemical accidents and incidents. Chemical industry today play a vital role in global economy, especially it's a key originator of the supply chain. Any disruption to the chemical plants also mean the serious interruption to the industries downstream. Therefore, it is an essential factor to safeguard the global chemical manufacturing industries by preventing accidents and incidents. That is all about mandate, one of the parts of the program of the OPCW. And I just talk one thing, that people every day go to the work, business as usual. But today, people are so advanced. You can see the people be connected to each other digitally. And people expect us to do more and more to prevent chemical accidents and incidents. People today expect about transparency. People talk about safety and security measures in all the countries. Also, people talk about environment. Also, people talk about energy and transition. These all factors are actually influenced by basically fast internet. Today we are talking about 5G, and also social media, possibility of pictures, movies, globalization, big data, clouding. And as educators and trainers, the society expect us to do more and more to prevent chemical accidents and incidents. It takes many lives every year, and as well as it has a direct impact on pollution. In fact, in Sri Lanka also, last couple of years, there were small accidents happen and it took many lives of the people. So everybody asking from OPCW, Chemical Safety and Security Management Program we run throughout the world, how to prevent these chemical accidents and incidents in the world. If you have a good force of chemical accidents and incident task force in your countries, actually, economically, it will bring the investors to your country. But unfortunately, last couple of months, there were few accidents happen throughout the world. I saw that some of our Indian colleagues are in this forum. Right? One of the noticeable accident happened in India. It was in India. The release of poisonous gas, styrene gas into the environment. This led to the death of at least 13 people and injured more than 100. So when we are drafting our future programs and activities, we always think about some questions. Always something come to my mind all the time. How to prevent these chemical accidents and incidents related to the chemical process. Number two, how to deal with these accident scenarios, especially terrorist attacks. It's something come to my mind, the Easter bomber attack, for sustainable and design-based viewpoint. Also, at the same time, we are always talking about risk today, right? Risk, because we are dealing with this biological hazard. So how to integrate different type of risk when you are making risk decisions in your countries, in your organization, also your chemical facilities, also including the financial risk. At the same time, how to develop usable and inclusive dynamic risk assessment techniques using the big data and real-time monitoring. In fact, the many countries in the world today, to deal with this biological hazard, COVID-19, they are using the big data, and also they are doing the real-time monitoring. In fact, in Netherlands, if you want to go to the restaurant, I had to input all the data into the system. Unless otherwise, I cannot enter into the system, even in airport and many other places. It means that they are using the big data in case of if I get infected with the COVID-19, in case of, they know that where did I go. So it is in their system already. And this is a way that people are doing real-time risk assessment monitoring. At the same time, I am always thinking today, chemical industries, they talk about profit. They talk about the number of employees. They talk about how big the chemical industries. But always our agenda is that the chemical industries has to become excellence by not having accidents and incidents. At the same time, we are thinking that how are we going to redesign our programs and activities according to those challenges. These are some questions I just put all the time to our member states and participants. Please think about it. How are we going to prevent these chemical accidents and incidents in the process, which bring the investor to the countries? Also, how are we going to redesign our programs and activities according to the new challenges? Today, entire world, they know about safety. There is no doubt about it. They know what you mean by safety culture. Even they know what you mean by PPEs. I saw that in the forum, everybody wearing the mask. When I was teaching Institute of Chemistry Laboratories, sometimes back, very hard to enforce the students to wear the safety glasses. Today, it has become part of our lifestyle. So our question is that, how are we going to expand the safety and security culture throughout the chemical industries, throughout the laboratories to prevent chemical accidents and incidents? It also saves lives. Every world, every country, there are a lot of standards. We talk about ISO 31000. It's a research assessment standard. American Petroleum Institute, API, OSHA, guidelines, Seveso guidelines in European Union. We have a Seveso guidelines to prevent chemical accidents and incidents. And in fact, every country, we have a national standards. So the question always I would like to ask, regardless of the technology, standards, we have a policies, guidelines, audits, training, chemical accidents and incidents continue to happen. That is the unfortunate thing. And at the same time, we are thinking that we have to change the current audit practices or prevention of the chemical accidents and incidents in the future. Therefore, this current inspections and monitoring system in chemical plants, also for the laboratories, has to be designed based on possible accident scenarios in the future. That is the only way that we are thinking today to prevent chemical accidents and incidents. We don't see the hazard as it is, and we just work with the hazard, but we don't see, we never visualize, we never thought about it, how this hazard going to take lives of the people. Therefore, recently we introduced the concept called scenario-based auditing. We see the scenario well in advance. I'm telling you, ladies and gentlemen, no single country in the world, they never prepare for how to deal with this biological hazard. They never see these kind of scenarios in their countries. So they don't know how to deal with it. Everywhere, every country, even the European Union, there are so many deaths here, actually compared to Sri Lanka. Sri Lanka are doing much more better than us. So here so much of deaths in European Union. These people never prepare for that. So there are so always unforeseen and undetected scenarios in the chemical plants, leading to the catastrophic accidents. Also, number two, we are always talking about reliability of the people who are working for chemical plants, chemical facilities, reliability of the operators, how reliable they are to do their work. We have no measurement on that. So these are the two critical areas we are always thinking about that lead into the catastrophic chemical accidents and incidents. Let's take a quick example. That very recent accident happened in India as an example. We thoroughly investigated what is went wrong. It is a LG plant in Visakhapatnam, India. It led to the death of 13 people and injured more than 100. It is very well covered by the media. The media report have suggested that the styrene had been stored for a very long period of time in the storage tank. Styrene, of course, we know what chemistry is, a very simple molecule. It undergoes radical polymerization, but it's a very good precursor for many industries, especially for tire industries, plastics, as well as in the paint industry. During storage of this chemical, styrene, in the storage plant in Visakhapatnam in India, there are many unforeseen and undetected situations. Number one, polymerization is taking place even in the process of inhibitor. Inhibitor should be continuously added into the storage facility to prevent the polymerization. Number two, due to the lockdown, the storage tank undergo corrosion, of course. And the corrosion is produce iron oxide as a rust. The rust actually accelerates the polymerization of the styrene into the polystyrene. This polymerization process is exothermic. It releases large amount of energy, temperature into the environment. As a result, the large quantity of styrene from the storage facility released into the environment, leading to the death of at least 13 people and injured more than 100. There are so many unforeseen and undetected situations. Storage of styrene in the LG chemical facility in Visakhapatnam in India. The question that how you deal with this kind of unforeseen and undetected scenarios. Let's take the accident scenario as example. the major leakage of methanol storage tank leading to the pool of fire scenario. Depend on the amount of ethanol stored in the storage tank, the fire might be spread into the nearby tanks as well. Depend on the temperature, humidity, and also the other climatic condition, wind direction, it might further spread into the nearby tanks as well. So what you have to do, if you recognize these unforeseen and undetected scenarios well in advance, you can develop the layer of protection, LOPA, layers of protection to prevent these kind of chemical accidents and incidents in chemical facilities. We have developed a lot of software. During our programs and activities, we introduce these kind of softwares for our member states to predict the possible accident scenarios in your chemical facilities as well as chemical laboratories to prevent the chemical accidents and incidents. As a result, every day, there's always insufficient hazard recognition in the chemical facilities. People go to the work industries, laboratories, business as usual. There's always insufficient hazard recognition that is leading to the catastrophic chemical accidents and incidents. At the same time, the reliability of the worker, we call it as a human operator. The reliability of the human operator, how reliable he is to carry out his specific job, always taking into account. As a result, always there's a little attention of these two factors has been given or systematically analyzed to prevent chemical accidents and incidents in chemical plants and laboratories. Insufficient hazard recognition and also the availability of the human operator or the capacity of the human operator to deal with these kind of accident scenarios in the future. So recently we introduced the concept so-called scenario-based audits. The scenario-based audits tells simply to you that regardless of the magnitude of major accidents are rarely caused by the single failure. There's always interactive multiple failure scenarios where the people, the workers, management unable to detect. As a result, these unforeseen and undetected scenarios eventually result in catastrophic accidents and incidents in chemical plants. Unfortunately, in last 2 months, 3 months alone, we have a database. Our database, we have last 2 months alone, there are more than 10 accidents happening in the world. These accidents continues to happen in chemical facilities and even laboratories, and it's cost many lives in the plant. At the same time, Office W is very concerned about how these new advanced technologies is going to affect on chemical plant safety and security management. So, for example, in the expansion of the cybersecurity, artificial intelligence, new engineering technologies like drones, nanoscience and nanotechnologies, and also the advanced organic synthesis, how we're going to affect on chemical plant safety and security management is always our concern. Let's take one single example, this drone. In Netherlands, I can purchase a drone for 54 euros, very advanced one. It's quite cheap here and anybody can purchase it without any problem. But you can see in this unintended threat, this unrealized threat, ultimately become intended threat. And recent attack on world largest oil refinery in Saudi Arabia by using the drones is a great example that where the unrealized threat is became a realized. Today, the technology have a great effect on the chemical plant safety and security management, especially area of cybersecurity, and also these drones and engineering technology as well as automation have a great impact. So the Office W always has a focus on how to deal with these advanced technologies to protect chemical facilities in our member states. It's our great concern. In fact, this year we were planning to do the first workshop, how this advanced technology is going to impact on chemical plant safety and security management, and also including laboratories. But unfortunately, it has been postponed for next year because of the current pandemic situation. Finally, in Office W, carry out many programs and activities related to the chemical safety and security management. We talk about diversion of chemicals, how you can convert chemicals into the weapons or into the drugs and also into the explosives. Something came to my mind when I was drafting this presentation in various very famous Easter Sunday attack. As far as I know from the report, that these terrorists, they acquired the urea from the supply chain and convert into the urea nitrate by simple chemical reaction, adding urea into the nitric acid. So we try to educate our member states what are the high risk chemicals are available. There are more than 300 chemicals has been categorized as high risk that you can easily divert into the weapons or maybe divert into the drugs or even to the explosives. During our program, we talk to our member states, make sure that you look after those chemicals. And also we talk about chemical inventory management. I was thinking that Institute of Chemistry have a big lab, and this inventory management system, we always is our priority. We develop a lot of softwares, and we also get some softwares our developed countries, I'm sorry. And these softwares we can use for manage your chemical laboratory inventory. And also we talk about anatomy of accidents. Also we talk about international responsible care. And also we are focusing on how to predict the accidents and probability of accidents well in advance. So we introduce concept like Bayesian probabilities and also dominoes theory for chemical clusters to prevent chemical accidents and incidents in the future. In fact, these days we develop a lot of tabletop exercises we will share with our member states soon, and videos, and also different kind of learning modules to people to have a self-studies how to prevent chemical accidents and incidents in chemical plants and promote best practices and share the knowledge to prevent these accidents in the future. This year, we introduced advanced training modules on chemical safety and security management. Actually, we were planning to do 5 workshops on advanced training modules. These are some of the top subtopics. Actually, this time we are targeting our undergraduate students. Actually, they are the one in the future. I heard a lot of presentations. In fact, they are actually so eager to learn. And we are targeting these undergraduate students and also the graduate students, how to promote the best practices related to the chemical safety and security management. This is one of the curriculum we have already developed, and we will share with our member states very soon with e-learning modules, video presentations, and also cartoon and animations. And also we are trying to talk about this transport security safety management, also very critical. And also we talk about human reliability assessment to prevent chemical accidents and incidents in the future. During this pandemic condition, OPSW continued to promote our best practices, share our knowledge and experience with our member states. In fact, we also perform many activities in recent past, and some of the programs and activities it is in our website. And we are trying to engage with universities and also the various institutes like Institute of Chemistry in the future to promote and share knowledge and best practices, even during this pandemic situation in the world. This is one of the accidents I saw recently happened in chemical plant in China. This is the unrecognized, unforeseen scenario leading to the explosion, which create the 5.4 Richter scale earthquake in the Xi'an province in China. And after the program, I'm always like to ask these 3 questions. As educators, professors, you are working with the chemistry. What kind of indicators, or we call performance indicators, could be used to predict safety and security performance in your country? How do you perform? What are your indicators that you are doing good? Number 2, do you have any training modules, resources that you can implement? You can train your stakeholders to promote chemical safety and security best practices. Also, we'd like to ask what strategies the member states are using or planning to use to promote best practices on chemical safety and security management in your stakeholders. These are the 3 basic questions I always would like to throw to the member states, and we always ask some of the answers for these questions during our programs and activities. This is a final slide. It's all 30 minutes gone. This is a nice pictures in my neighborhood in Netherlands, where I stay. It's very close to my apartment, and I will show these photos because the life of Netherlands is slowly, steadily get back to the normal. And after this pandemic situation, businesses are open, people understand what is bike safety, and they understand safety of you and safety of others. So if you want to further details about our programs, activities, please log into the www.opcw.org and you log into our website. In future, we carry out a lot of programs and activities for the undergraduate, graduate students, as well as educators, trainers. Most participants are chemists and chemical engineers. And if you need the further details, you can log into our website and you can participate in our program and activities. In fact, your chairperson, Professor Priyanika Parnagava, she came to The Hague, I guess, a couple of years ago. So she knows better more about our programs and activities about chemical safety and security management. And if you want to further details, you can contact her. I guess she came to the Women in Chemistry program hosted by the OPCW a couple of years ago. Thank you so much being with me and take your time, and very much appreciate for you. And thank you for giving me this wonderful opportunity. In fact, OPCW definitely support this program. The approval process is going on. So it's part of the OPCW also this program. And thank you so much. And hope to see you in December in Sri Lanka. Hope to, and hopefully. And I was planned to come in this August actually, but unfortunately travel is restricted here. And hope to see you in the future. Thank you. Appreciate. Thank you so much.
Dr. Rohan, thank you very much. It's a very nice presentation. We are here, right? You can hear me, okay? Dr. Rohan, can you hear me? Please mute. You are muted. Please unmute your phone.
Okay, I can hear. Hello?
Yeah, it's a very informative and nice presentation. It's very nice to see you again and hear your lecture, and also your new programs that you have started. Collaborating with institutes. Don't forget Institute of Chemistry. You are a member of Institute of Chemistry, so we hope to join hand with you and OPCW and continue the strengthen the collaboration. And thank you very much for participating and giving us this good lecture. That's a nice. Mute that again,
No, I have only question how I'm going to get the gift from the Cicero. That is only concern. I'm just kidding. Doing presentation. Thank you very much one more time and hope to see you in the end of this year. Thank you. Bye.
Thank you very much, Dr. Rohan Pereira. As a token of appreciation, we have a small token of appreciation for you. So we will finish after the speaking. Thank you very much, Dr. Rohan Pereira. As a token of appreciation that we have a small gift for you, so we will send it after the FCD 2020. Thank you very much for attending our seminar virtually, and I believe that all of our audience have learned a lot of information about the chemical safety. Thank you very much again. Okay, we are going to start the technical sessions now. I believe that there are some guidelines to be read. So first of all, I will read them for the speakers. So the safety guidelines, all the presenters are only allowed to sit on the allocated stations. And all the presenters must wear masks all the time.
Yeah,
But they are allowed to remove their mask when presenting. If you are removing your mask, we advise you to remove it completely. After each presentation, the surface, including the podium, microphone, and the pointer, will be sanitized. So there are some other instructions for all the speakers. The presentation should be within 15 minutes. You have to finish your presentation. So you are allowed to have 12 to 13 minutes for the presentation part and 2 to 3 minutes question and answer session. Altogether, you have 15 minutes. In the presentation, the maximum time allocation is 13 minutes. So there will be a time notification for you. There will be two bells. The first bell will ring once at 10 minutes. The second bell will ring twice at 13 minutes.
102.
So with that, we are going to start the first
107.
Speaker. We have 6 speakers lined up today for the afternoon session. The first one is Submission ID 70, gold milling induced sulfurization and carbothermic reaction of ilmenite using a combination of sulfur and vein graphite by H.C.S. Subasinger and A.S. Ratnaik.
So good evening, everybody. I'm Chandra Subasinger from representing OLS University of Sri Lanka. So I'll directly move to my topic. It's upgrading Sri Lankan ilmenite using a combination of ball milling induced sulfurization and carbothermic reduction. Right, I'll go through a brief introduction on what is ferrous titanate. You may know ilmenite. So it is the primary source of rutile and titanium metal. So rutile and titanium metals, that is TiO2, has a variety of applications in diversified fields in the modern industrialized fields. So without wasting Pulmude, I'll directly move on to the sampling location, that is Pulmude, which is the most economically interested heavy mineral deposit in Sri Lanka, and probably it's one of the world's or the globally interested mineral deposit, because it is partially replenished through the seasonal monsoonal dynamics of the coast of Sri Lanka. So if we can upgrade the ilmenite source to rutile, so we can earn a huge compensation to the economy of our country. So with that, and in addition, the world is currently shifting towards green technology. So the use of chemicals and toxic elements are little bit deviating from the modern world now. So my recent problem and the objective is the Sri Lanka has high-grade ilmenite sources. Tons of ilmenite are exported without minimum value addition. So the objective is to introduce a feasible and comparatively environmental friendly method to upgrade Sri Lankan ilmenite, that is convert ferrous titanate to TiO2 using a physical method. So this is the methodology in brief. You can see it. And I used several ratios, ilmenite to sulfur first, and 1:1, 2:1, and 4:1, and milling for different milling hours using high energy ball milling. and carried out particle size analysis using DLS method and XRD analysis, and afterwards kneeled at it 400, 600 and 800 degrees Celsius. So the next is weight graphite, which is probably a best source for carbon, which is also used as a reducing agent. The same procedure was repeated once again, and nearly at 800,000 and 1,200, a bit elevated temperature than sulfur. So there, after that, a combination of sulfur and weight graphite was used as a possible additive, and similarly the particle sizes. Here I was mentioned that the particle sizes was reduced better than sulfur and ilmenite with the combination, because the ball pulverization in this is better due to plasticity and lubricity of both sulfur and weight graphite. So I move on to results and discussion. This is the particle size analysis using the initial sample obtained from pool today after separation. So the mean particle size diameter was 0.14 millimeters. So this is the mineralogical analysis under microscope. You can see some minerals, that is ilmenite, leucoxene, garnet, and quartz. I think the garnet grade is pretty highlighted. So after doing the XRF analysis, these were the results. Mainly composing of titanium dioxide, a bit of quartz, and N2O3 as well as the major oxides. So according to the XRD analysis, there are several of the initial sample. You can see some intense ilmenite peaks and some intense silica peaks, that is quartz, and vanadium peaks, and the rest. And you can obviously see the FTIR spectrum of the initial sample. And this is the, after ball milling, this is the particle size analysis. This is the particle size analysis after ball milling using the DLS method, and you can see the combination has produced very less particle sizes. And here I have mentioned the accumulation of particles in the combination of ilmenite, sulfur, and weight graphite has probably the least particle size diameter after ball milling. This, as I mentioned previously, this due to the plasticity and lubricity of both sulfur and weight graphite has constructively interfered in this mechanism. So moving on to the next. After the 4-hour milling and 6 hours milling, you can see that after 6 hours milling, the particles are probably converted to nanoparticles in the range of around 120 nanometers. So that is also mainly due to the ball pulverization, because we used zirconium ceramic crucibles in this ball milling, and so due to its hardness, it has quite converted to nanoparticles after 6 hours milling than 4 hours milling. So this is the XRD analysis of samples milled with ilmenite and sulfur. Probably you could see the intensity of sulfur and ilmenite has probably changed after milling for 6 hours than in 4 hours. Otherwise, there is no much deviation from spectrum of 4 hours milled and of the 6 hours. So there you can probably see the spectrum. There are appearing of the weak reflections in 4 hours milled has probably increased in 6 hours milling. That is the occurrence of pyrite peaks, probably indicated as PY. That is, you can see the induction of a sulfurization reaction. The reduction reaction has started during the process of ball milling. Next, after ball milling, so I you could have seen the methodology, 1:1, 2:1, 4:1 ratios. So in here, so you can see the appearance of brookite, pseudorutile, pyrite, and rutile phases has been induced during ball milling. Once you see, you can see all three spectra. Of course, they are similar to each other, but if you look at it, you can see the intensities and the occurrence of pyrite and brookite and other peaks have increased with IS-416 sample. This is the FTIR analysis of samples made with ilmenite and sulfur. Of course, I'm not interested with the CO2 bonding and OH bonding. Probably they may have been surfacely attached during a sample analysis. So I'm much interested in the spectrum that is below 1500 or 1000, because in inorganic chemistry you don't normally go beyond that, because we are interested in TiO2 and FeO bonding in this study. So this is XRD analysis of samples made with ilmenite and vein graphite. So similarly with ilmenite and sulfur, you can see the diffraction terms of ilmenite and graphite. Here you can see after milling for 6 hours, the 002 and 004 planes of graphite structure is probably dismantled. That is milling for more hours. Probably the structure of vein graphite has quite dismantled along the respective planes. So next, similar ratios 1:1, 2:1, and 4:1 with ilmenite and vein graphite. There you can see the occurrence of pseudobrookite and pseudorutile. But here you can see the pyrite because sulfur was not used in this. Next, accordingly, you can see the occurrence of some pseudobrookite because carbon is also a possible additive in the carbothermic reduction of ilmenite. So this is the FTIR analysis of samples made with ilmenite and vein graphite. Here too, I am not interested in the CO2 bonding, which you probably see around 2400. So XRD analysis of samples made with ilmenite, sulfur, and vein graphite. This is the combination which gave promising results. You can see here too, the 004 and 002 planes have been dismantled quite, if you observe it more clearly. Now, formation of altered forms of rutile and pyrite can be observed with this, with the combination. The broadening of XRD peaks indicates an increase of structural disorder because with the incorporation of the sulfur and carbon particles through cleavage planes into the ilmenite structure during ball milling. Now the FTIR analysis of milled samples with ilmenite, sulfur, and vein graphite. That is here similar. You can see the FTIR spectra and the FeO bonding and TiO2 bonding below 1500 per centimeter. So after isothermal annealing, the samples were annealed, the above samples, and since 4:1 produced the best results, and 6 hours was selected previously as the best time for milling, high range ball milling. So isothermal annealing was proceeded with 4:1 and the 6 hours milled samples. So you can see this 400, 600, 800 samples for IS, that is ilmenite and sulfur, and the rest for ilmenite and graphite, and ilmenite, sulfur, and graphite combination. So XRD analysis after the thermal annealing, you can see the appearance of new peaks, probably more rutile peaks and pyrite. You can see in the XRD spectra. So the occurrence of this may have this indicates the reaction completion which started during ball milling, that is sulfurization and carbothermic. That both reduction reactions have happened after isothermal annealing. They are completed with the formation of rutile. And anatase and brugite have gradually been converted with the isothermal, that is with the thermal treatment at high temperatures, because they are actually metastable states of TiO2. You may know there are three naturally occurring polymorphs of TiO2 and one other form of TiO2 that is known as srilankite or TiO2. Then there is the example analysis of many examples of ilmenite and graphite. There's nothing to explain more. And sharper the rutile, sharper the peaks, you can see that the crystallinity has increased with thermal annealing. And the XRD analysis of annealed samples of ilmenite, sulfur, and graphite in the West have produced promising results. So here too, the crystallization is better. Now this is the TIR spectrum. And as a conclusion, I must say that ilmenite can be successfully upgraded using sulfur and vein graphite without any chemical usage. And sulfur and vein graphite must be effectively combined to produce promising results. And the optimum milling hours was concluded at 6, and the optimal ratio is 4:1. And the optimum temperatures was 800 and 1000 for the combination is 4000. And mechanical, that is mechanical accretion plus beneficial outcome on ilmenite production. And these are the future directions, acknowledgements. So thank you very much.
Okay, now the presentation is open for questions. We have about 1 minute. If you have a question, you can ask from the speaker. No questions from the audience. So I will ask one question. Now you have been different temperatures, right? 400, 600, 800, and for another one 600,000. So how did you get that temperature? So what is the mechanism that you are using?
Actually, for a reaction or to a reaction for a reaction to progress, especially in sulfurization carbon reduction, at least a temperature of above 400 should be provided. Unless the reaction or ilmenite, the bonding ilmenite would not dissociate at the lower temperatures. At least we have to reach 1000 and leave for more than 1 hour to have the reaction going. So that is why several.
Yeah, my question is how did you get that temperature? So what is the mechanism or technology that you are using?
Technology.
So what method you have used to achieve 600 degrees?
That is in muffle birds. Yeah, muffle.
That's what I use. Since there are no more questions, let's thank the speaker again. Okay, our second speaker is Commission 89, water quality of fishery harbors in the southern coast of Sri Lanka. The work done by Rajani Zanaina, Dipti Vikramasinghe, and Padmalal Mane.
Good afternoon, everyone. As you can see in the slide, as soon as you saw it, you realize that it is about coastal pollution. Coastal pollution has been a trending topic in the recent past, it is in the present, and it will be in the future if we are to continue our actions in the same way. And if you remember the incident where in the Mount Lainia beach, not that long ago, where waste got washed away into the Mount Lainia beach, it is actually a consequence of our actions. And such actions would definitely degrade the water quality of the marine environment, which will affect in the human health and as well as the other aquatic life.
So the present study was conducted to determine the water quality of the fishery harbours in the southern coast of Sri Lanka, where many human activities take place. Let's move on to the introduction of this presentation. We said coastal areas are important due to many reasons. Here I have mentioned a few. Coastal areas comprise only 20% of the Earth's surface, but they contain over 50% of the entire human population. It is expected that by 2025, coastal areas would accommodate 75% of the entire human population. More than 70% of the world's megacities are located in the coastal areas with more than 8 million inhabitants. Coastal ecosystems also yield 90% of the global fisheries. Over 1 billion humans depend on fish as their main or sole source of animal protein. Tourism plays an important role in the economy of many nations. It is actually because of the beaches and activities in the sea like diving and surfing, as they are huge tourist attractions, they are important. Sri Lanka being an island nation, it is vital to know the importance of our coastal zone. For this study, we have chose the southern coastal area as our sampling site. It is because southern coastal area provides the highest marine fish production in the country. 12.2% of the country's population resides there, and it is an important intermediary passageway between the Arabian Sea and the Bay of Bengal. Southern coastal area has been selected for focused development as a tourism zone as well. Due to these things, rapid growth of human population and intensive urbanization in coastal regions happen, and that would lead to coastal and marine ecosystem degradation. We talk about pollution a lot, but we pay less attention to understand or assess the impact of the coastal pollution. Even though there are many ways where marine pollution can occur, fishery harbours are considered to be the hot spots of coastal pollution. It is because at the harbour premises, boat-generated pollution can occur, user-generated pollution can occur, and even pollution from the external sources. Boat-generated pollution is mainly due to the oil spillage by refueling, pumping of oil-bilge water, waste water from washing boats, and solid waste from the boat repairs, which are washed into the harbour during the rainy season. User-generated pollution is mainly due to the dumping of fish offal and garbage into the harbour waters, and also the defecation within the harbour premises and the untreated waste from the toilets. External sources, pollution from external sources is mainly due to the loss of untreated wastewater and domestic water from the land-based external sources. So the goal of this study was to study the impact of fishery harbours on coastal aquatic environment. To achieve that goal, we have established two objectives, which is to investigate the physicochemical parameters of the coastal waters in the selected fishery harbours, and also to compare the physicochemical parameters in the marine water with local and international standards. Moving on to the methodology, we have selected Ambalangoda, Hikkaduwa, Todangulu, Mesa, and Tango fishing harbours as our sampling site, and we have conducted the sampling from June to December in 2019. Each sampling site is comprised of 5 sub-sampling locations where we have collected the water samples. The water samples were analyzed for water temperature, pH, electrical conductivity, dissolved oxygen, salinity, light intensity, and turbidity in the site itself using the calibrated instruments. Chemical oxygen demand, total phosphorus, nitrate nitrogen, nitrite nitrogen, ammoniacal nitrogen, and chlorophyll A levels were determined in the laboratory using standard methods. Moving on to the results and discussion part. This is how our physicochemical parameters, we obtained physicochemical parameters during the study period at each location. And this is how the parameters using the laboratory analytical method variated during the study period at each sampling site. According to the Kruskal-Wallis test, we obtained that water temperature, nitrite nitrogen, light intensity, turbidity, and the chlorophyll A level indicated statistically significant variation among the sampling locations. One of the objectives of the study was to compare the water quality levels that we obtained with the coastal water quality standard. According the local water quality standard for marine water is the proposed coastal water quality standard published by Central Environmental Authority in the year of 2001. According to that officially, water temperature should be below 32 degrees and the pH should be between 7 to 8.5 and the dissolved oxygen level saturation must be more than 80% and the salinity should be between 29 to 35 ppb and the turbidity should be below 10%. And when it comes to international standards, we have selected the United States Environmental Protection Agency's standards provided for marine water quality, and they have categorized the water quality into 5 categories. And we have selected the category number 4, which is for harbor premises, and the category number 2, which is for bathing, wet water sports, and commercial fishing. According to their standards, the pH for in harbor premises, the pH of water in the harbors should be between 6.5 to 9 pH, and the dissolved oxygen levels must be more than 3 milligrams per liter. And for bathing, contact water sports and commercial fishing, the pH levels should be between 6.5 to 8.5, and the DO levels should be more than 4 milligrams per liter, and the turbidity level should be below 30 MTU. Coming back to our results that we got, we saw that the pH levels in the Tangor Fishing Harbour, Mirissa Fishing Harbour, and the Hickory Fishing Harbour was below the standards provided by the proposed quality standards of different classes of coastal water in Sri Lanka. And the salinity levels were below than that standard at each sampling stage. There can be many possible reasons for these variations. According to literature, pH can be variated due to the removal of carbon dioxide, temperature, salinity, freshwater influx, and organic matter depletion. In here, we think that lower pH values can be caused by the freshwater influx. And in the Tangor Fishing Harbour, there is a waterway that gets discharged adjacent to the harbour area called Kilama Oya, and that might be one of the possible reasons their pH get lower. And for salinity, average salinity level of the seawater is 35 ppb globally. But in here, the harbours do not achieve that level. Coastal water salinity can be also changed due to several factors like evaporation, precipitation, and freshwater runoff. Here, the case might be the precipitation or freshwater runoff. For the conclusion, the results indicate the need to pay attention to minimizing pollution due to fishery harbours. Because we have seen that nutrient levels in the fishery harbours show significant variations, and high nutrient levels like nitrogen and phosphorus could lead to eutrophication processes where harmful algal growth could occur. And when it comes to studies, a frequent water quality monitoring mechanism should be established not only in the southern coastal area, also at the coastal water around the island. And we also recommend that more similar studies with a long duration are needed to help in decision making, because this is only a preliminary study for a short duration. These are my references. Thank you for your time.
Okay, now the presentation is open for any questions from the audience. So you were suggesting that different mechanism to track the water quality, right? And the last the recommendation thing. Do you have a plan how they are going to install these around Sri Lanka?
NADA, Authority, Ministry of Fisheries and Aquatic Resources should work in collaboration, and they should publish
they should work in collaboration and they should inform the public about this mechanism that's going on. And we should encourage the scientific, we should encourage the scientists to work on these things because even though we talk about the pollution a lot, we don't do much to assist them. So I think we should work in collaboration.
Do you work with them or
No, I'm in budget.
not with your department? Okay, thank you very much.
Okay, our next speaker is under the submission ID 102, determination of descriptive values of environment by JAPCRA Sena and MLJ Pereira.
Good afternoon, everyone. I'm Aman Jasurat, representing Department of Chemistry, University of Peradeniya. My research topic is determination of descriptive values of environment. These are the contents of my presentation. Under introduction, I will be discuss what is environmental risk assessment and what is a quantitative structure property relationship, and then objective of this research, methodology I have used, results and discussion, finally conclusion and future directions. So as the earth is more industrialized, innumerable chemicals emitted to the environment as products, byproducts and waste materials. So it is essential to determine the risks that would occur from these chemicals. According to the United States of Environmental Protection Agency, risk of chemical depend on three main factors: the amount of chemical present in the environment, level of exposure of a person or ecological receptor, and inherent toxicity of a chemical. So these chemicals are distributed in different environmental and biological compartments, such as hot air, air solid, water solid. They are under equilibrium conditions. So there are various analytical methods are established to find out extent of distribution of these chemicals. But most of these methods are time consuming and poor agreement between different methods and cost effective. So therefore, quantitative structure property relationships are established. In here, the quantitative structure property relationship is a chemical property of compound. Is a model as the response variable as a function of physicochemical and structural properties. So solution parameter model is a such quantitative structure property relationships. In here, the distribution of a chemical described by three main processes: cavity formation, reorganization, and solute-solvent interaction. So there are two main types of equation in solution parameter model: transfer solute between two condensed gases and transfer solute between gas and condensed gases. So here the lowercase letters describe system constant while uppercase letters describe solute descriptor. The SP is solute property, which describes some free energy related term like potential factor or equilibrium constant. So here the detail of the system constant and solute descriptors. So system constant L and solute descriptor L describe the ease of cavity formation. We also say, and system constant E and solute descriptor E describe electron lone pair interaction, and system constant S and solute descriptor S describe dipole type interaction, where A describes solvent hydrogen bond base, solute hydrogen bond acid interaction. B describes solvent hydrogen bond acid and solute hydrogen bond base interaction. So objective of my research is to experimentally determine the solute descriptors of antron. So let's talk about how these antron release to the environment. This is, as you know, that this is a reagent using various types of organic synthesis. And this is general reagent for identification of carbohydrates. So antron get released to the environment through these ways. So this is the methodology I have used. As I mentioned earlier, solute property can be some free energy related term like potential factor. Potential factor calculations were done by using gas chromatography by using two different columns, DB1701 column and NP5 column. And solute property also can be obtained by using equilibrium constant like liquid-liquid partition coefficient. There are in liquid-liquid partition coefficient 8 different biphasic systems were used. So this is a detailed methodology of potential factor calculation. First, sample preparation was carried out. In here, 5 mg of analyze was dissolved in 0.75 milliliter of acetone. Then the gas chromatographic analysis were done. After that, calibration curves were constructed. I will be explain how and why these calibration curves are constructed. So, as I mentioned earlier, I have used two different columns. The HP5 column is a non-polar column. This is a non-position of that column. And DB1701 column is a polar dominant column. This is a composition. And so in here, system constant, the lowercase letters system constant are already have been characterized. So they are in standard conditions. They have been characterized in standard conditions. Because of that, solute property also should be in standard conditions. So therefore, we have to construct the calibration curves. So in here, non-chemical compounds are taken and measure their experimental potential factor value and converted to experimental log potential factor value. And standard log potential factor of that non-compound versus experimental log potential factor was plotted. So then we can find standard log potential factor of antron. It is uncommon. So these are the instrumentation that I have used. The data acquisition was done by using ChemStation software. The other conditions are like this. So this is the chemical I have used to calibrate 140 Celsius of HP5 column. So after injecting to the column, the potential times were taken. Then potential times were converted to the potential factor. Then it converted to the experimental log potential factor. Then standard log potential factor value versus standard log potential factor value and experimental log potential factor values. After the graphical equation, we can calculate the standard log retention factor of Antron. Likewise 160, 180, 200, 220 and 240 calibration curves were constructed. So by using graphical graph equation, we can calculate the standard log retention factor of Antron in those temperatures in HP fiber. Likewise, column calibration of DB1701 column were carried out by using these chemicals. Then calibration curves were constructed, and by using graphical equation, we can get the unknown standard log retention factor of Antron. So, as I mentioned earlier, to prepare liquid biphasic system, this is the methodology I have used. First, we have to get 600 microliter of polar solvent and 600 microliter of non-polar solvent. Then 2 microliter of internal standard and 5 milligram of Antron were added. After shaking, it was allowed to overnight. Then 2 milliliter of sample volumes were withdrawn and injected into the column manually. So this is a equation to calculate partition coefficient of Antron, where Kd is partition coefficient of Antron and S is peak area of Antron in solvent 1 or solvent 2, and IX is peak area of internal standard in solvent 1 or solvent 2, and KD/IS means standard partition coefficient of internal standard in given system. So these are the biphasic systems I have used and their respective internal standard and their standard partition coefficient of that internal standard. So by that we can get the experimental standard KD of partition coefficient of Antron each biphasic system. So by using those data, finally we have to insert into the solver algorithm. It is an algorithm constructed by using 2007 Excel. So, as I mentioned earlier, I have calculated the RF value of HP5 column and their respective system constants. Put the solver algorithm. Then DB170 RF value of DB1701 column and their system constant. Put the solver algorithm. Likewise, all the systems they have to put that values also in solver algorithm. Then we can calculate the descriptor values for Antron. These are the descriptor values for Antron. And as a conclusion, electron lone pair interaction is 1.51, dipole stability 0.71, 78, acidity 0, and ease of cavity formation 9.15, basicity 0.65, and Macron characteristic it also ease of cavity formation 1.51. These are the future directions. We can be further optimize these descriptor values by using more biphasic system and more systems, and these values can be further validated by using theoretical models, descriptor values. These are the references I have used, and I would like to thank my research supervisor, Dr. Tiloka Ariselan, and Professor Colin for solver algorithm software, and all academic and non-academic staff of Department of Chemistry and Postgraduate Institute of Science and Fun.
Okay, now the presentation is open for any questions. I will ask one question. Now, you came up with different numbers in the last slide, right? So those are the values. So did you have any errors?
Yeah, it's called standard deviation of, there is standard deviation. The standard deviation, we can't put that position because standard deviation measured in whole process is something 0.09. As I remember, we can't put that number to standard deviation. It actually measures the correct of that method. It only gives idea about how precise of this method. We can't put the end of the values. That is standard deviation.
Final answer, you can have an error.
Yeah, no, we can't. The whole process gives 0.09 standard deviation. That's all. So in Solver, then we optimize these data because of optimize by using further system concept because of we have to reduce that standard deviation. That's all. We can get only data.
Okay, thank you very much.
Okay, our next speaker is under the submission ID number I107. Determination and comparison of the fluoride ion concentration in drinking water wells in selected areas of Uttaram district. The work was done by WMOA Vanasinghe and JATC RSA.
Okay.
Good evening, all of you. I am Ashani Vanasinghe. My research topic is determination and comparison of the fluoride ion concentrations in drinking water wells in selected areas of Woodland district. This is the content of my presentation. Let's go on to the introduction part first. Water is an essential natural resource for sustaining life and the environment. However, the chemical composition of the surface, subsurface, geothermal or non-thermal are the prime factors for the suitability of water for domestic, industrial and agricultural purposes. But the groundwater forms a major source for drinking water in urban areas as well as rural areas. But the main problem is the quality of drinking water, and fluoride acts a major role on this case because fluoride impacts human health adversely. Fluoride are very essential element to the human health, but higher ingestion of fluoride and lower ingestion of fluoride arise dental problems. Fluoride enters to the human body primarily through the drinking water. Mostly people in dry zone and particularly the children prone to dental diseases. These are adverse effects of fluoride like dental cavities, dental fluorosis, skeletal fluorosis, pimples and etc. Dental cavities occur due to the low concentration of fluoride intake. Dental fluorosis occur due to high intake of fluoride, and dental fluorosis is characterized by discolored, mottled and chalky white teeth. Skeletal fluorosis occur due to high intakes of fluoride, continual exposure to fluoride, strenuous manual labor, poor nutrition and impaired renal function. And it is characterized by joint pain, restriction of mobility and increase of the risk of bone fracture. These are standard values for fluoride ion concentration in drinking water. When the concentration of fluoride ion is 0, it limits the growth and fertility. 0 to 0.5 fluoride ion concentration causes dental caries. 0.5 to 1.5 range promotes dental health, resulting in healthy teeth and it prevents tooth decay. 1.5 to 4.0 fluoride and concentration causes dental fluorosis. 4.0 to 10.0 causes dental fluorosis, which is pain in back and neck can be occur. Above 10 ppm of fluoride and concentration causes to 15 fluorosis. So the optimal concentration of fluoride ion can vary according to the climate conditions with the range of 0.5 to 1.0 milligrams per liter. The optimal level of fluoride ions in drinking water for caries protection is 0.6 to 0.9 milligrams per liter, and the upper limit of fluoride ion concentration in drinking water is 1.5 milligrams per liter. These are standard values of pH, total dissolved solid, salinity, and the conductivity. The requirement for the pH for safe drinking water should be in the range of 6.5 to 8.5. Total dissolved solid value should be less than 600 milligrams per liter. Salinity should be less than 10,000 ppm and conductivity value should be in the range of 50 to 500 microsiemens per centimeter. According to the National Oral Health Survey of Sri Lanka 2015-2016 for Putlam district, the prevalence of dental fluorosis among 12-year-old is 20%, 15-year-old is 18.3%, and 35 to 45-year-old is 3.4%. So, in Peramaguttu, Pahalagamu, Kottala Kemiyavu, Kandatham, and Pethukulama areas, observed cases for dental fluorosis are significant. So, my objective is to determine the fluoride and concentration in drinking water as in Peramaguttu, Pahalagamu, Kottala Kemiyavu, Kandatham, and Pethukulama areas. These are my sampling sites. I have selected 5 areas. The first one is Peramaguttu. There are 6 sampling sites in Peramaguttu area, including one tube well which has 100 feet depth. In Pahalagamu area, there are 4 sampling sites, and in Kottala Kemiyavu area, again 6 sampling sites. I have selected 7 sampling sites in Kandatham area, including one tube well which has 230 feet depth. And finally, Pethukulama area, there are again 4 sampling sites. So let's move on to materials and methods. First, I have selected these 5 areas and all the samples are taken each week of the month from March to December 2019. For the sampling sites, 2 tube wells and 25 open tub wells are included. Then on-site measurements are taken using PCS test and 35 multiparameter. The parameters that I have measured on-site are temperature, total dissolved solid, salinity, pH, and the conductivity. And all the samples are kept in freezer until the analysis is carried out, and samples are filtered through microfilter, and finally the samples are analyzed using ion chromatographic technique. This is a chromatogram that I have observed from my one-off samples. In this chromatogram, the retention time for the fluoride ions is 5.29 minutes. So let's move on to the results and discussions. This is the variation of temperature in Peramaguttu area. Respectively, these are variation of temperature in Pahalagamu, Kottala Kemiyavu, Kandatham, and Pethukulama areas. Considering about all 27 sampling sites from March to December 2019, the temperature values vary in between 24.9 to 34.9 centigrade. Let's move on the variation of total dissolved solids. This graph shows the variation of total dissolved solids in Peramaguttu area and respectively other 4 areas. These total dissolved solid values vary in between 161 to 3850 milligrams per liter, and most of the total dissolved solid values are exceeded WHO recommended level for the drinking water, which is 600 ppm. This is the variation of salinity in all 5 areas. Most of the sampling sites are under the 10,000 ppm level, and the salinity values vary in between 86 to 2,760 milligrams per liter. This is the variation of pH. Considering most of the sampling sites, It varies in between the safe level, which is 6.5 to 8.5. And here, considering all the sampling sites from March to December 2019, it varies in between 5.35 to 8.46. And variation of conductivity, considering all the 5 areas, most of the sampling sites are exceeded conductivity recommended value for the WHO. Fluoride also can affect to the conductivity value, and the conductivity value vary in between 183 to 5430 microsiemens per centimeter. And let's move on to let's focus on the most important part in my research study, which is variation of fluoride ion concentration. This graph shows the variation of fluoride ion concentration in Peramaguttu area. There are 6 sampling sites. Out of 6 sampling sites, 5 sites have exceeded the WHO recommended level for the fluoride ion concentration, which is 1.5 milligrams per liter, and the exceeded range vary in between 1.524 to 2.556 milligrams per liter. In Pahalagam area, out of 4 sites, 2 sites have exceeded the 1.5 ppm level for fluoride ion concentration. In Kothagamiya area, again, out of 6 sampling sites, 5 sites have exceeded the 1.5 recommended level. And the specialty is in Kandathar area, I have selected 7 sampling sites, and all the sampling sites have exceeded the 1.5 WHO recommended value for the fluoride ion concentration, which is 1.5, and the exceeded range vary in between 1.522 to 2.659 milligrams per liter. And finally, in Pettukulam area, out of 4 sampling sites, only 1 site have exceeded the 1.5 level. Considering all the 27 sampling sites in all 5 areas from March to December 2019, it varies in between 1.503 to 2.843 milligrams per liter. Then the Pearson correlation test was done to determine the correlation between fluoride ion concentration and rainfall. Only A2 and A3 sites have exhibited the significant correlation between rainfall and the fluoride ion concentration, and both A2 and A3 indicates the significant positive correlation, which is when rainfall increases, fluoride ion concentration also increases. This geological map illustrates the bedrock profile of the sampling sites that I have selected for my research study. You can see here green coloration, it indicates the biotite genesis, and red coloration indicates the biotite and hornblende minerals. Both biotite and hornblende are fluoride bearing minerals. Then groundwater can mix with the fluoride ions by easy exchange of hydroxyl ions. So let me conclude my presentation as this. For 20 sample sites in all selected 5 areas, average value of fluoride ion concentration exceeded 1.5 for at least 2 or more than 2 months over the considered time period, and it varies in between 1.503 to 2.843 milligrams per liter. The highest concentration of fluoride ion is reported in Kothagamiya area, which is 2.843 milligrams per liter. Fluoride ion concentration exceeded the standard levels in all selected sample sites of Kandathar area, and it varies in between 1.522 to 2.659 milligrams per liter. Only A2 and A3 sites are indicated a significant positive correlation between rainfall and the fluoride ion concentration. According to the bedrock profile in selected areas, the biotite and hornblende minerals exist under sampling sites, which may contribute to the higher concentration of fluoride ions in drinking water. The high levels of fluorides in the drinking water wells can be a cause of observed number of dental fluorosis incidents in the investigated area. These are my selected references, and my acknowledgement is to my supervisor, Dr. J.G.C. Aryasena, and thank you for all academic and non-academic staff of Environmental Scientific Program, Department of Chemistry, and Department of Botany in the Ministry of Peradeniya. Thank you very much.
Now the presentation is open for any questions.
Okay, so I have a question. Can you briefly can you summarize the process which before you do the ion chromatography and I mean after you take the sample from the metal, what did you did before inserting to the ion chromatography?
First, I have selected sampling size and I went each mid of the month from March to December.
No, I am asking after you take the sample, I mean sample process.
I have taken the 3 sample in one side and all the check it for plastic bottle and sealed it without entering air and without outflowing the water. And all the samples are kept to the freezer, and then when ion chromatography analysis is carried out, when samples are taken out.
Okay, so when you talk about chlorides, those you mentioned earlier that the water samples contain suspended solid to some amount, right? Then there might be a chance that those chloride ions can bound to those solids, but when you do the ion chromatography part, you filter and inject to the machine, right?
Yeah, actually I filtered the samples first.
Yeah, then
through microfilters.
So there might be a chance that there were some leftover chlorides in those suspended solid particles. So how do you compensate that?
And actually, those are drinking water wells. We have to assume that those wells are somewhat clear to drink water, and there are no more turbid.
Yeah, yeah, but you mentioned about suspended solids when it comes to those multi-parameter measurements, right?
No, suspended. I didn't mention about suspended solids.
So you mean there are you say so what you saying is that there are no suspended solids in the gel board, right?
No, we cannot assume that, but I did only filter through microfilters. Actually, in turbid also can deposit fluoride.
Yeah, okay. The next question is, did you follow any spike recovery calculations when it comes to the analysis? So then how do you come up with that? This is the actual value of fluoride concentration present in the water sample?
Actually, I have taken the average value of fluoride ion concentration.
When I had that question, now when you do that kind of ion chromatographic analysis, one thing is, even I remember that you talked about the turbidity. Is that one of your parameters? You measure the temperature. What are parameters you measure?
Temperature, total dissolved solid, salinity,
Right,
pH, and conductivity.
total dissolved solids. So in that case, one quick question is, did you take the rainfall into account when you take the total dissolved solids into consideration? Because when the rainfall is high, maybe those parameters automatically change.
Yeah, I have taken the rainfall data from meteorological department.
No, I know, but when you have the bar graph and the standard deviation, so if you take that into consideration, okay, is that just the average of result, all results?
Yeah, only the standard deviation of 3
Right, I mean,
data.
and in analytical, when you think about analytical chemistry, the standard deviation is a when you consider standard deviation, when you do scientific method, we change only one, right? So we assume everything else is the same. So you are measuring the standard deviation to measure your instrument accuracy of your instrument, I guess. So if you in that case, for your sample, the rainfall should be a parameter. If rainfall is different, your standard deviation automatically go high. So it is not only your instrument accuracy you are measuring. That is, I think there's a separate parameter in there. So it is a multi-parameter analysis to be And the second one is as Pratuma, so when you do this type, when you do this type of topographic analysis, I think it is better to check the matrix effect. Like when you draw the calibration curve, when you generate a calibration curve using pure water, the sensitivity of the instrument may be different when you analyze well water. And if it is just a well water, it is the depth is different. When it is a new well, the depth is different. So the other components in water can be different. So especially when you are doing hydrography, those matrix components can affect the sensitivity of your analysis. Did you check them parameters? Check those parameters. Thank you.
Okay, the next speaker is under submission ID number 116. A preliminary study on human influence on the water quality of Konkara Dam, Sri Lanka. The work was done by Hamsamari Abhisina, DDGL Ranayakar, and DT Victor's.
Hello everyone, I'm Hansamani Abesina and I am here to present my abstract on human influence on the water quality of the Koggal Lagoon, Sri Lanka. So when it comes to aquatic ecosystems, we all know that they are subject to various anthropogenic stresses. In this slide, you can see some of the few stresses like unsustainable agricultural practices, surface runoff, direct discharge of nutrients, land use changes. All of these anthropogenic stresses exert a direct impact on these ecosystems, which can finally end up with nutrient enrichment. So these nutrients can cause various problems like toxic algal blooms, loss of reduction of oxygen level, and death of loss of biodiversity, and so many problems. So these nutrients can seriously degrade aquatic ecosystems, and so this can visually see through the process of eutrophication. Eutrophication is a process which is triggered due to the deterioration of water quality. So therefore, I have focused my study on Koggal. So why is Koggal Lagoon rather than any other ecosystem? Because Koggal is a prominent ecosystem in the southern Sri Lanka. And here you can see the Koggal export processing zone, which lies within the watershed of the lagoon. It implies that the lagoon is already subjected to industrialization. And the rapid increment of urbanization with unsustainable human practices and the land use changes which are occurring within the watershed of the lagoon, all of these activities exert an immense pressure on Koggal, which can finally affect the fishery production, tourism, and recreational activities. So it is very much important to understand the trophic condition of this ecosystem, and to fulfill that necessity, I have focused my study on Koggal with this main objective. My objective is to determine the impacts of human activities on Koggal Lagoon by correlating the surrounding land use with water quality of the lagoon. So this is my method. There I use two types of data. One is the sampling data, another one is the satellite or the remote sensing data. For the sampling data, I measured on-site measurements and in-laboratory measurements, while these satellite or the remote sensing data were used to monitor the surrounding land use. As I mentioned earlier, my sampling data of two types. as on-site measurements and in-laboratory measurements. Under the category of on-site measurements, pH, salinity, conductivity, turbidity, and water temperature were measured using standard portable instruments. And under the category of in-laboratory measurements, nitrate, total phosphorus, and chlorophyll were measured according to the standard procedures. For the satellite or the remote sensing data, these data were used to observe the surrounding land use and categorize my selected site into two as disturbed and undisturbed sites. For this, I used data from Google Earth high resolution images, data from the Land Use and Policy Planning Department, and the field data analysis. Here are my selected 10 sampling sites, and sampling was conducted from June to November 2019. From each site, I collected duplicate samples and in separate 1 liter bottles, and they were preserved in an ice box and transported to the university for my laboratory measurements. And all these are surface water samples. I think you are clear with that. At the end of one field visit, I am with 30 samples, that means 30 liters for my laboratory analysis. Here are my results. When it comes to total phosphorus concentration in this map, I have included the ranges of total phosphorus concentration at each site during the whole study period. The highest value is recorded at site 5, while the lowest at site 2. Then I use two standards. One is the Central Environment Authority standard for class 2 waters, that means fish and aquatic life. The other one is the Environmental Union standard. I use these two types of standards to tally with both the local and international level. Likewise, in terms of these two standards, there's a phosphorus enrichment in the level. And in the table below, it gives the range of total phosphorus concentration of the two categories. And then I perform ANOVA and see whether is there any significant difference. Yes, there is a significant difference of total phosphorus concentration in between these two major categories. Then when it comes to nitrate concentration, here also I have included the ranges. The lowest value was recorded at site 10. It is a site which is close to the middle of the lagoon, and while the highest value recorded at site 7. The important factor is that during my whole study period, high nitrate concentration recorded at this site, continuous. And this is the site which is located near to the copper export processing zone. According to these standards, there is a nitrate enrichment in the lagoon, and ANOVA also implied that there is a significant difference of this nitrate concentration in between these two major categories. When it comes to pH, we also have included the ranges. Important thing is that there's a lower pH existed within the lagoon when considering the in complying to the Central Environment Authority standard, and it was except in month of June. ANOVA has implied that there's no any significant difference of pH in between these two major categories, and it is very important to mention about temperature with the pH. And here is the range during the study period, and temperature showed no any significant difference between the two major categories. Chlorophyll. Chlorophyll is the pigment which is an indicator which is used to measure the eutrophication level. And here, the lowest value recorded at site 5, and it is a site which is near to the freshwater inflows, while the highest value at site 1. According to ANOVA, there is a significant difference of chlorophyll concentration in between these two categories. And in the table below, I have given you a criteria which is used to categorize coastal lagoons in terms of chlorophyll concentration. According to this criteria, Cobble Lagoon is transforming its status from oligotrophic to mesotrophic level. So that means lagoon is heading towards the eutrophic level. So it is very much important to take immediate actions in order to preserve this valuable ecosystem for the future generation. When it comes to salinity, the lowest value recorded at site 6, it it is the site which is located far in from the seamount, while the highest value at site 8, which is the site closest to the seamount. And the important thing is I have observed a salinity gradient from the seamount to the site at the near the freshwater inflows through the lagoon, and according to ANOVA, it implies that there is a significant, however, there is a significant difference of salinity in between these two nature categories. When it comes to conductivity, though the lowest and the highest values recorded near these sites near to the seamouth, continuously low conductivity was recorded near the sites at freshwater inflows. And there's a significant difference of conductivity in between these two major categories. When it comes to turbidity, high turbidity values recorded continuously near the freshwater inflows, while the lowest value at site 7. There is a significant difference of turbidity in the between these two major categories according to ANOVA. So here you can see the site 5 and the site 6. They are the sites which are located near to the freshwater inflows. And there I have recorded that throughout the study period, low conductivity, high turbidity levels, lower depths, low chlorophyll A, and high total phosphorus concentration. These are verified by both the lab analysis and the field analysis. And it summarizes that the inlet, water from inlet carries sediments and ions to the lagoon. And the photograph in the below shows the color of the fresh water, which is adapted to the lagoon, and they are very much different from the other parts. And in above that, there is a satellite image with a high resolution, 1.5 meters, with a resolution of 1.5 meters. And here also you can see that at the places where the freshwater inflow is connected to the lagoon, the color of the water is changed from the other parts. And I have mentioned about ANOVA near each physicochemical parameters, and except pH and water temperature, all the physicochemical parameters are significantly different. And I performed also MANOVA to see whether how the total effect of these physicochemical parameters change in between these two major categories. Yes, there was a significant difference. My summary is that anthropogenic influence has resulted in the degraded water quality in Kogga Lagoon, and there's a specific degradation in disturbed sites compared to the natural areas. And also, inland activities contribute to water pollution by carrying silt, sediments, and ions to the lagoon, and that's why high turbidity, low conductivity, low chlorophyll, high phosphorus, and lower depths were recorded near these freshwater inflows. Therefore, quality of water should be monitored frequently and also methodically. It is very much important to protect this ecosystem for the sustainable development, and it is very much important to imply a integrated environmental plan to protect this ecosystem for future. Here are my references and
okay, the presentation is open for any questions.
A nice presentation. So what is your overall conclusion? So you compare the phosphate values against two standards. Are the measured concentrations are lower than those standards or higher than?
They are higher than the standard. There is a hyper unification in terms of total phosphorus and nitrate in this ecosystem. Most importantly, this is a preliminary study to get an idea whether is there an effect from human activities to this precious ecosystem. And I have found that there is many land use changes affect this ecosystem, and it is very much important to take immediate measures to protect this ecosystem for future generation.
And I want to give a very quick suggestion. Your research group is trying to continue this work, that if your objective is to measure the anthropogenic activity, I know that you collected a lot of samples from the lagoon, but if you can do some sampling, do some same testing for the water inlets and water ins and water outs. Water ins and water outs. The lagoons, then you can easily do a material balance to check the environmental activity. I know that you get the concentration and you can compare against those standards in your method, which is good. But I'm just suggesting.
Thank you, sir.
Yeah, I have one more. I can take a minute or question. Now you said about the circular lagoon transformation, right? So, how many samples did you take from circular lagoon?
At one sampling, at one field visit, I am collecting 30 samples. That means 30 liters, and I have done 5 field visits.
To the same location.
Same location.
So do you think that number of samples are enough to make such, to come to such a conclusion?
Yes, sir. This is a preliminary study, and I am developing this to develop an algorithm using satellite images. So then, we will, it is not necessary to go for this in situ sampling. We can just take a satellite image and put that algorithm and just take how the trophic level in this ecosystem. So it is very time consuming and it is easy. So that is my ambition.
Thank you. Okay, now we will come to the last presentation for today. So this is submission ID number 122, enhanced removal of methylene blue using nitric acid, pre-modified Lasias Cypnosa or Covilla biochar. The work was done by Janista Fernando, Upicha Valikala, SP Jayasinghe, Satisfactory Manasinghe, Chatru Piris, and Samira Mudira.
Good evening, everyone. I'm Tanisha Fernando, and I'm currently serving as a teaching assistant at Institute of Chemistry, Ceylon, India. So today I'll be presenting my research, which I initiated when I was doing my undergraduate studies and continued further on the topic enhanced removal of methylene blue using Lasias Spinosa Covilla biochar. So a quick outline, my project objective was to find a novel biochar and to do a modification to enhance the absorption conditions. And I also did two experiments to determine the surface characteristics of raw and pre-modified biochar, and also I selected this dummy dye or methylene blue to evaluate the optimal conditions for absorption. And last, I carried out regeneration studies to find the reusability of the biochar being produced. So moving on to my next slide, let's see what biochar is. So biochar is a very common adsorbent used these days. So it is basically used for water remediation, soil amendment, and there are many more uses of biochar. So it is a highly porous structure, and also it is rich in surface functional groups. So biochar is basically produced by the thermal decomposition of organic waste under limited oxygen conditions. So in my case, my feedstock material of interest was Covilla. So why did I choose Covilla? So the main reason for choosing Covilla is known for its porosity. Since it's a water plant, it can absorb a lot of heavy metals. So I thought the porosity might help in my research work. And also it is abundantly found and effortlessly grown in many parts of my country. So the common biomass type that can be used for the biochar production is shown in the slide. Apart from these, can use sludge biochar, municipal waste, and many other organic substances. So as I mentioned earlier, biochar surfaces are rich in surface functional groups. So this particular character in biochar helps to perform many different mechanisms during an absorption process. So let's see what kind of interactions the biochar can have during the absorption process. Since the biochar is a structure where it's highly conjugated with sp2 hybridized carbon, so it can act as an electron donor. So it can have electron donor, etc. mechanisms, hydrogen bonding, surface complexations, and most importantly, the pore-filling mechanism, because biochar is well known for its porosity. So sometimes even if the biochar surface is rich in surface functional groups, sometimes we cannot obtain the expected level of absorption in some cases. So in that case, we'll have to go for a value addition. So value additions can be done by increasing the surface sorption size, that is by increasing the surface functionalities in biochar, or by oxidizing the surface functional groups, which is already there in biochar, or we can increase the surface area by demineralization or removing the trapped constituents, and also by a wall destruction. So how do we go for a value addition? That is basically by modification. So modifications, basically there are two types of modification. That is pre-modification and post-modification. Pre-modifications are done before the pyrolysis process to the feedstock material itself. So what I did was a pre-modification. I will explain how I did it. And post-modifications are done to the pyrolyzed biochar product. So one thing that you need to note is that in a post-modification, there's always a chance of losing the biochar yield during the process. But in a pre-modification, that's not always the case. So pre-modifications can be cost-effective. And so modifications, there are few modifications: acid-base modifications, deactivation, magnetization. So moving on, this is how I did my pre-modification. So first, I took cotyledons, and it was cut into small pieces and dried under sun for 2-3 weeks until I obtained a constant mass. And it was dipped in a 50% air nitric solution for 4 hours, and the remaining nitric acid was drained off, and the resulting biochar, resulting cohila was oven dried for 24 hours at 60 Celsius. And the oven dried cohila was slow pyrolyzed for 3 different temperatures, that is 300, 500, and 700, to obtain my biochar, and finally sieved to obtain the particle size of interest. To see the sorption, to determine the sorption condition, I had to compare my pre-modified biochar with raw biochar. So raw biochar was made using the same method, but instead of doing the pre-modification step. So moving on, to characterize the pre-modified biochar and raw biochar, I carried out FTIR analysis. So for the raw biochar, you can see row 300 showed few peaks, but going from 500 to 700, the peaks has been disappeared a bit. For pre-modifications, compared to raw biochar, there's more peaks being introduced after the modification process. And also, I'd like to highlight that during my preliminary studies, I did few absorption processes. So from that, I found out that row 300 and pre-modified 300 showed maximum capacities. So from here onwards, I carried out my experiments for 300 produced biochar. So next shows the FTIR analysis of row 300 and pre-modified 300. Like I mentioned earlier, there were new surface function groups which is being introduced to the pre-modified biochar. And also, this shows the elemental composition. To see the polarity, the blue graphs show the pre-modified biochar. For all 3 types of biochar, the polarity of pre-modified biochar was higher than the raw biochar, meaning that the pre-modification might have favored introduction of new functional groups to my biochar, and also the aromaticity has been decreased with increasing of temperature, meaning that with the increase of temperature, the aromatic structure has been properly developed. And Most importantly, after the pre-modification step, the nitrogen content has been increased. The blue bar shows the pre-modified biochar. For all three types of biochar, the nitrogen content has been increased. And next on, I carried out beat analysis to determine the surface area, pore volume, and pore size of the biochar being produced. For Rho 300 and pre-modified, comparing Rho 300 and pre-modified 300, the surface area has been drastically increased from 37 to 85, and pore volume has been also increased, but the pore size has been decreased. So that I thought it might be due to nitrogen group fixation upon pre-modification. These are two images I obtained from the SCM analysis. For Rho 300, you can clearly see pores upon the pyrolytic process. For pre-modified 300, there's a bit of pore wall destruction. Maybe I think might be due to pore wall destruction upon modification. So, like I mentioned earlier, I selected this dummy in the Bethlehem blue to evaluate the optimum conditions for the biochar being made. So first I carried out pH studies. So since I am mainly focusing on 300 biochar, so for Rho 300 biochar, there was a significant variation with the pH range I chose, that is from 2 to 10. So for pre-modified, for Rho biochar, so the proposed mechanism, the mechanism would be due to electrostatic interaction. Since there is a effect of pH for the absorption capacities. Pre-modified biochar, even though I mentioned that there were new functional groups being introduced to the biochar surface, there was no big variation with pH for the absorption capacity. So, thought the mechanism could be due to a co-filling mechanism. And further on, I carried out my time scan experiments to do the kinetic modeling. To find out the absorption mechanisms, two kinetic models were analyzed, that is silver first order and silver second order. So for Rho 300, it was the best fitted model was selected using the linear regression coefficient value. For Rho 300, it was found that it was best fitted for the silver second order model, and for pre-modified 300, it was found that it was best fitted for the zero first order model, which affirms the physics absorption process for pre-modified 300, and for 300 it was the chemical absorption process. And to find the rate determining step, intraparticle diffusion analysis was carried out to see that none of the 6 drafts did not pass through the origin, meaning that the rate determining step is not the intraparticle diffusion. So moving on to adsorption isotherms, 4 types of adsorption isotherms were analyzed for Rho 300 and pre-modified 300. For both types of biochars, the 6 isotherm model was best fitted. So this is a comparison between Rho 300 and pre-modified 300. From the isotherm model, it was evident that pre-modified 300 showed a better absorption capacity than Rho 300. So there's like 8 times increment of the absorption capacities upon the pre-modification process. And also thermodynamic studies were carried out to find the spontaneity of the process. So at 3 different temperatures, it was found that for pre-modified 300, it was a spontaneous and exothermic process. And next, I carried out batch regeneration studies to find the reusability of the biochar being produced. This graph shows so 3 regeneration cycles were carried out. For the first absorption, there's quite like above 50 of absorption capacity, but with the increase of regeneration cycles, both biochars, the absorption capacities has been reduced. So it was both Rho and pre-modified biochar, it was reduced by 80% in the batch regeneration studies. And next, I carried out column regeneration studies for both types of biochars, Rho 300 and pre-modified 300. For Rho 300, it was the breakthrough volume was found to be 200 milliliters, And upon regeneration, when you increase the regeneration cycle, the breakthrough volumes has been decreased, and for pre-modified Balcha, it was found that the breakthrough volume was 400 milliliters. And also for the same thing as raw Balcha, when the regeneration cycles increase, the breakthrough volumes has been decreased. So from this also it was evident that the pre-modification process was a success. So finally, I'd like to conclude that there was an enhancement in absorption of methylene blue upon pre-modification, and the dominant mechanism for pre-modified Balcha was for pre-modified D100 Balcha was found to be porphyrin, and for raw Balcha it was electrostatic interaction, and the both Balchas were best fitted for the CIPS isotope model, and from the CIPS isotope model it was again pre-modified 300 showed capacity of 79.63, whereas raw 300 showed capacity of 9.58, and in both in batch regeneration, both raw and 300, raw 300 and pre-modified 300 Balcha show 8% absorption capacity after regeneration cycle. So finally, I'd like to thank my supervisor, Dr. Ramal Tilaka, my research assistant, Mr. Satipir, Mr. Satipur, Mr. Chanak Navaratna, and most importantly, College of Chemical Sciences for giving me this opportunity to carry out my research project successfully, and also to giving me this opportunity to present in the international conference. Thank you very much.
Okay, that marks the end of the presentation, sir, but I think the presenter is very happy to answer any questions if you have.
So where are you changing the hash printing before the modification and after the modification?
Yeah, I carried out ash content experiments too, but I did not mention it in my presentation. But before and after the experiment, for both pre-modified Balcha, there was no significant change in the ash.
Okay, that brings us to the end of the session. But before we wrap up for today, we have a small raffle draw for the speakers. So I would like to. So any speakers want to come and pick a number? So shall I pick a number for you? Because we have some fabulous presents for you. So if you come and pick, it might be yours. Who knows? So the winner of the raffle draw is HCS Subhasinga. And also we are giving a certificate for each of the speakers. Sajani Disanayak. M.L.J. Pereira. W.M.O.A. Vanasinghe. Hamsamali Abhay Singh. Janista C. Fernando. So that brings us to the end of today's session. So thank you very much for attending and have a good night. Thank you.